Hey everyone, Chris Dutton here, and welcome to Microsoft Power BI, up and running with Power BI Desktop. Now, if you're looking for a hands-on, project-based approach to learning business intelligence, you've come to the right place. In this course, you'll be playing the role of lead analyst for AdventureWorks Cycles, a global manufacturing company. Your mission? Design and execute an end-to-end business intelligence solution from scratch. But the good news is, I'll be right there with you, guiding you through the ins and outs of Power BI and sharing crystal clear explanations and helpful pro tips each step of the way. Our journey will begin with an intro to Power BI Desktop and then transition through each phase of the business intelligence workflow. We'll begin by connecting and shaping our source data with Power BI's query editing tools, and then explore concepts like cardinality, normalization, and filter context as we build out a full-scale data model. From there, we'll add calculated columns and measures using data analysis expressions or DAX, and finally take things to the finish line by designing dynamic interactive reports using Power BI's visualization tools. So what do you say? Ready to dive in? Sign up today and get lifetime access to over 10 hours of high-quality video content, downloadable project files and resources, course quizzes and homework assignments, and one-on-one expert support, all backed by a 30-day, 100% guarantee. Thanks again for choosing this course. Now let's get started. All right, let's kick things off and talk about our course project. So here's the situation. You've just been hired by AdventureWorks Cycles. It's a global manufacturing company, and they want you to design and deliver an end-to-end business intelligence solution from scratch. Now, this won't be a simple project. The client needs a way to track core business KPIs like sales, revenues, profit, and returns, but also compare regional performance across sales territories, analyze performance and trending at the product level, and forecast future profits, and use the data to identify the company's high-value customers. And as if that's not challenging enough, all you've been given to work with is a folder of raw CSV files that contains information about transactions, returns, products, customers, and territories. But don't worry, we're going to work through this together. I'm here to coach you through each step of the way and break down the project into a few core objectives. So our mission here is to use Power BI Desktop to connect and transform the raw data from those CSV files, use those tables to build a relational data model to blend information together, create new calculated columns and DAX measures, and finally design an interactive report to actually analyze and visualize all of this data. So let me give you a little sneak preview of the project that we're actually going to be creating from a completely blank canvas. So what you're looking at here is the final deliverable that we're going to provide to our AdventureWorks clients. We've got an executive summary here that allows you to break down the data and explore information by categories, by product subcategories. We can see the core business KPIs, the revenue, order volume, and returns for the current month. We'll provide a quick snapshot of the most ordered products and the top revenue driving products, and include the ability to filter down the entire page by specific sales regions. Not only that, but we'll include drill through functionality to dive deeper into specific product performance and provide insight like pacing against targets, profit trending over time, and forecasts into the future, and even scenario tests to see the impact of pricing adjustments on actual bottom line company profits. Last but not least, we'll provide a view that's all about the AdventureWorks customer so that we can see the top revenue driving customers, breakdowns by demographics like gender, income level, and occupation. We'll see orders by age, top customers and top line metrics, and bookmarks and links to tie it all together. So again, we're going to be working through the business intelligence workflow together step by step to build this entire project from nothing but a folder of raw CSV files. I hope you're excited. We've got a lot ahead of us. Let's dive in. Last bit of housekeeping before we move on to the next section. Just want to take a minute to set some expectations for the course. Now, number one, what you see on your screen might not always exactly match what I'm showing on mine. Microsoft products are constantly changing and evolving, and Power BI Desktop is no exception. In fact, there are product updates released every single month, which means that you're likely to see some differences in the layout or the tools or the functionality over time. Second, important note, Power BI is currently only compatible with Windows machines. At this point in time, there isn't a Mac version of Power BI Desktop available. Number two, as the title suggests, this course is designed to get you up and running with Power BI Desktop. Now, my goal is to give you a deep foundational understanding of the tool, so I may simplify some concepts and I won't cover some of the more advanced tools. So we won't be writing any custom M scripts, we won't be importing custom R visuals, we're going to skip over some of the more advanced or nuanced DAX functions. That said, I'm confident that the concepts covered in this course will give you an excellent starting point for those types of more advanced applications. Number three, Power BI and Power Pivot in Excel are built on top of the exact same engine. So if you've taken my Power Query, Power Pivot, and DAX course, these first few sections will feel very, very familiar. We're going to talk about the same query editing tools, we're going to talk about the same data modeling fundamentals, and we'll review a lot of the same DAX syntax and basic functions. That said, there are a number of very important differences and nuances between the two platforms, so I'd highly recommend working through each lecture of this course, even if you've recently taken my Power Query and Power Pivot course. And last but not least, we will not be covering Power BI Service as part of this course, so we're going to be focusing on Power BI Desktop specifically. Now, the online sharing and collaboration features on app.powerbi.com, those will be covered in depth in a completely separate course. With that, let's move on to the next section, Intro to Power BI Desktop. All right, hey there, I'm going to be checking in at the beginning of each section of the course just to keep a pulse on how our project's coming along. Now, before we dive in and really get our hands dirty, let's take a minute to talk through the Power BI interface and workflow. Let's make sure you've got the program downloaded and the right settings configured, and then I want to share some of my favorite resources that you can use if you need extra support along the way. All right, the time has come for us to officially meet Power BI. Now, a quick summary here. Power BI is a standalone Microsoft Business Intelligence product, which includes both desktop and web-based applications for loading, modeling, and visualizing data. Again, the focus for this course will be on desktop specifically. There's a ton of additional info if you'd like to learn more at powerbi.microsoft.com. Now, I want to show you something called the Gartner Magic Quadrant. And Gartner's a market intelligence research company. They produce these quadrants a few times a year. And what we're looking at here is the Magic Quadrant for analytics and business intelligence platforms specifically, updated February 2018. And the idea is that you have completeness of vision on the x-axis and ability to execute on the y. And when you break down the players into the four quadrants, you end up with niche players, challengers, leaders, and visionaries. And where you want to be is right here in this top right corner where the leaders live. And that's exactly where we find Microsoft with Power BI leading the charge among some very popular, very powerful other platforms like Tableau, Domo, IBM, Qlik, etc. So really exciting time to be learning Power BI because I think it's only going to get more powerful and more popular from here. With that, let's transition into why Power BI. So what are some of the key benefits that make this such a game-changing product? Well, first and foremost, you can connect, transform, and analyze millions, even hundreds of millions of rows of data. And you can access that data from virtually anywhere, whether it's a database, flat files on your desktop, cloud services, folders of files, etc. There's a huge connector library that allows you to access a ton of information. And then not only that, but you can create fully automated and repeatable ETL procedures to shape and transform and load the data from those different sources. Next, we can actually build relational models inside of Power BI to blend the data from each of those multiple sources. And this is a concept that's getting more and more important in the analytics world. By creating relationships between all of those sources, we're able to analyze holistic performance across our entire data model. And that's a critical skill set for anyone working in data or analytics or business intelligence. It's that ability to blend information, tie sources together, and paint that comprehensive view of performance. Third, we can define complex calculations using data analysis expressions, or that DAX formula language. So we'll be doing this to enhance our data sets and enable some really interesting advanced analytics techniques using those powerful and portable expressions. And then perhaps the most important one, we can visualize our data with interactive reports and dashboards. And what we'll be doing throughout the course is actually building our own custom business intelligence tools using Power BI's best-in-class visualization and dashboard features. And then last but not least, fact is Power BI is the industry leader among BI platforms. It's intuitive, it's powerful, and most importantly, it's absolutely free to get started with Power BI Desktop. So again, really, really exciting time to be learning this tool. Now, last but not least, just want to make a quick comparison between Power BI and Power Excel, because there is quite a bit of overlap here, especially for those who have taken my Power Query, Power Pivot, and DAX course in Excel. So let's think of this like a Venn diagram, where you've got Power Excel tools on the left, you've got Power BI tools on the right, and this area of overlap in the middle with features that both platforms share. So here's kind of what it looks like in summary. You've got these Excel-specific tools on the left, like pivot tables, pivot charts, Power Map, Power View, and Cube functions. And then shifting over to the right side, you've got the report, dashboard views in Power BI that don't exist in Excel. You've got those custom visualization tools that we've been talking about, as well as the publishing and collaboration options available through Power BI Service. But where I want to really focus is this area of intersection. Like I've said before, these two tools are actually built on the exact same engine. Power BI takes the same data shaping, modeling, and analytics capabilities and then adds these incredible new reporting and visualization and publishing tools on top of them. So even though they're called different things in different places, the data loading tools will be called either Power Query or Get and Transform in Excel. The data modeling tools will be called Power Pivot in Excel versus the relationships view in Power BI. The fact is, it's all the same thing. And the best news of all is that transitioning is incredibly easy. These two platforms play really, really nicely together. So if you've been investing a ton of time building models in the Excel environment, no worries at all. You can import them right into Power BI in a matter of minutes. And I'll show you exactly what that looks like in the beginning of the next section. So there you have it. That's our intro to Power BI. Let's cover installing Power BI Desktop and adjusting settings for the purposes of this course. If you haven't already downloaded the program, it's a very simple process. Just head to powerbi.microsoft.com and click that Sign Up Free button in the top right. That will take you to another page that should look something like this. You can click the Download Free button. That will actually start your Power BI Desktop download. Once the download is complete and you fire up the program for the first time, you'll likely see a screen that looks something like this. Now, it may ask you to sign in to collaborate and share content. Keep in mind that you don't have to sign in to use Power BI Desktop. In fact, you can click the Get Data button to get started, or simply close this screen and continue using Power BI Desktop as normal. The sign-in is only required to access the sharing and collaboration tools available through Power BI Service at app.powerbi.com. You absolutely can sign in or create an account. In fact, you'll get a free 60-day pro trial when you do, but it's not required for the purposes of this course. And keep in mind that if you do sign up for service, that Microsoft does require a work or a school email address. Next up, let's talk course options and settings. There are 3 different adjustments that we're going to make just to make sure that we're on the same page throughout the course. First, we're going to look at our preview features and make sure those are deselected. Now, as Microsoft rolls out new beta features and tools, those will populate in this list, and you have the option to enable them to try them out. In this case, we're going to deselect any of those and make sure that we're working from the same core platform. Second, we're going to update our data load settings to deselect the Auto Detect New Relationships option. And basically, Power BI, it's a very smart tool. When you load up raw data, it's actually going to analyze that data and look for relationships and say, okay, I've got a primary key here and a foreign key here. I think Chris is trying to create a relationship between these tables, and it will automatically add the relationship for me, which is great, but it's not so good when you want to demonstrate how and why to create certain types of table relationships. So for now, we're going to uncheck that option. And the third update we're going to make is with the regional settings. Now, this is an important one. We need to set the locale for import to English United States. And the reason we have to do that is that the downloadable resource files and the CSVs that I've created for the course projects are built using English settings. So the dates are formatted as month, day, year. We've got decimal places noted by periods, not commas. So if you're in an area with different regional settings, like Europe or South America, for instance, you might experience errors when you try to load up that raw data if your system is looking for a different format or syntax. So I'm going to open up Power BI right now and just show you these three options in the actual Power BI environment. All right, so here I am in Power BI. I'm going to go all the way up to the top left corner. This is kind of my home menu here. Options and settings, select options. And this is that dialog box that we're looking at. We're going to start with preview features. As you can see, we've got some shape maps, custom themes. These are kind of new features that Microsoft is testing or putting out as a beta trial before they roll it out into production. So just make sure these boxes are all unchecked as you're working through the course. Next up, we've got data load, and this is the box that we want to uncheck here, where it says auto detect new relationships after data is loaded. And again, that just makes sure we have a blank canvas to work with in our data model. And then finally, regional settings. Just drop down this list and choose English, United States, press OK, and you should be good to go. Let's talk about the Power BI interface and workflow. So when you open up a Power BI desktop file, it'll look something like this. We're going to dive into each of the specific menus and panes and options here as we move through the course. But what's important to pay attention to now is this set of three icons on the left side of the screen. These are your three core views that represent the entire Power BI universe. You've got your report view, your data view, and your relationships view. Now, when we think about the Power BI and broad business intelligence workflow, it actually doesn't really follow this order. We don't start with the report and then move into data, then relationships. We're going to follow kind of a different process. Instead, we're going to start with the data view and the query editor. This is where we're going to connect, shape, and transform that raw data. Once we have our data, we're going to shift gears into the relationships view. That's where we're going to actually design our data model and tie those tables together with relationships. And from there, we'll move into the third phase, which is actually designing interactive reports and visualizations, and all that's going to take place in the Reports tab. So we will be bouncing around quite a bit between all of these different views, but generally speaking, this is how things are going to flow. So let me pull up Power BI. I just want to give you a very quick preview of how these different views and tabs look and feel. So here we are in Power BI Desktop. As you can see on the left, we've got our three familiar icons: report, data, and relationships. Right now I'm in my report view, which is basically my canvas for creating dashboards. I can drag visualizations and objects. I can access my fields and measures here, but this is where all of the designing takes place. Clicking through to the data tab, this is where you can actually see the tables and the raw data and fields that you're working with. So you can click through to see different previews of your tables. You can also add your calculated columns and measures using data analysis expressions here as well. And then you've got your relationships view, which is all about the data model. This is where you can see your tables as objects, along with the relationships, the cardinality, the filter flow, everything about your model. And we're going to cover all that in the Data Modeling 101 section of the course. So there you have it. That's your 10,000-foot view of the Power BI desktop interface and workflow. Before we dive into the actual hands-on demos in Power BI, I thought it would be nice to share some of my most helpful resources. So first and foremost, right there within Power BI Desktop, you'll find a Help tab that contains a ton of great information. It's got links to documentation, to training videos, sample files, templates, support blogs, and communities, all accessible right there within the program, which is great. I'm also a big fan of the Microsoft Power BI blog. You can find this at powerbi.microsoft.com/blog. And one thing I like in particular is that they post monthly feature summaries. And this is a great way to see what Microsoft is rolling out, what new tools and features and functions are available in the updated version of the program. So I definitely recommend subscribing to that blog and checking it out. Next up, we've got the Microsoft Power BI YouTube channel. They publish some great demos. They also show the feature summaries here as well, and they've got some really good advanced tutorials. Also check out Guy in a Cube. It's another channel. It's sponsored by Microsoft. He does some really great advanced, more technical demos on his channel, which are really helpful. And then last but not least, Power BI user groups, or PUG. These are communities of users, including both local meetups and online forums. You can find them at pbiusergroup.com. This is another one I definitely recommend subscribing. They've got some great threads and forums where users can interact and help each other out. So go ahead and bookmark these, subscribe to the channels. I refer back to these resources all the time, so hopefully you'll find them helpful as well. All right, now before we move on, I want to take a few minutes and talk about a pretty big Microsoft update, which is the new Power BI ribbon. Now, important thing to note here, back in November 2019, Microsoft introduced a brand new redesigned ribbon experience for Power BI Desktop. Now, this was originally a preview feature, which meant that you had to activate or enable that feature in order to access it. But in March and April 2020, Microsoft rolled this out to general availability, which means that anyone using current versions of Power BI will see this new ribbon by default. So what does that mean? What's new here? Well, first of all, we've got a bunch of new contextual menus. And contextual menus are menus that only appear or get activated by specific user selections. So by selecting a visual, you'll access menus like the formatting menu or the data drill menu. By selecting items in your field list, you'll see table-specific tools, column tools, or measure tools. And this is great because it helps us organize those different specific categories of tools and only expose them when they're relevant or necessary. Next up, you'll see a much more consistent style and structure across all of the Office applications, including Excel, Word, and PowerPoint. Really nice to see that consistency, no matter which Office tool you're using. Third is that we have new accessibility tools. So Microsoft is introducing the same Alt key tip functionality that we've seen in Excel and PowerPoint right here into Power BI Desktop. You also have tab controls, basically options that help you access the tools you need without needing to use a mouse. And then last but not least, the final thing that I'll call out here is that we've got a bunch of new report themes and much more intuitive design previews. Now, if you open up Power BI Desktop and you don't see the new ribbon experience, open up your options menu and look for a checkbox that says Updated Ribbon. You may need to activate that depending on which specific version of Power BI Desktop you're using. And note that I've also included a link down at the bottom of the slide. This just goes out to the Microsoft documentation page where you'll learn a little bit more about the ribbon experience. Now, one thing I'll call out here is that most of you will find this new ribbon very, very intuitive. All the same tools are there. Most of them are in the same exact place. It just has a little bit of a different look and feel. But that said, I've actually made two pretty significant updates to the course since initially recording to help make sure people are following along as smoothly as possible. For one, I updated all of the slides in the PDF file for download to reflect the new current ribbon experience. And number two, anytime in the course demos where I'm accessing a tool that may have changed locations with this update, you'll see an overlay that looks something like this, which basically tells you where you can find that tool in the current version of Power BI. So anytime you see this, go ahead and pause your screen, make sure you're able to follow along, and hopefully that helps. Now, if I've missed any points or if you're still stuck at any points in time, go ahead and reach out to our team through the Q&A forum or the discussion board. We'd be happy to help make those updates. So last but not least, just want to give you a very quick tour through some of these new tabs. Keep in mind, these slides are really just designed to serve as a reference point that you can jump back to in case you get stuck, but I want to call out a few important things here. So on the report view, I'm going to walk through each of the tabs that you can access, starting with Home and Insert. Biggest change here is that the original tools that were all compressed into the Home tab in the old ribbon are now split across the Home tab and a new Insert menu. You'll see all the same stuff here, copy paste options, get data, data sources, refresh, new visuals, measures, all of that. Biggest changes that you'll find, in fact, probably the number one biggest point of confusion, is that edit queries is now called transform data. Does the exact same thing, launches the query editor, just changed the name. And on the Insert tab, you'll see kind of a new focus on these newer AI visuals, Power Apps, things like Q&A, key influencers, and decomposition trees. Really great new tools. If you haven't seen that AI section of the course yet, go ahead and check it out. Really great demos there. Next up, we've got the Modeling tab. Very, very similar. You can manage your relationships, add measures and tables here, parameters, view as roles. Got the View tab. This is where you'll see some differences, starting with those themes. You can define custom themes, and these previews make it much more intuitive to see how the look and feel of your report will change by selecting these different themes. You might also notice this Performance Analyzer button that's been kind of surfaced here in the new ribbon. This is out of scope of this course, but it's a great way to help you tune and optimize reports, see how long calculations take to run, visuals take to render, things like that. And then last but not least, you've got the Help tab, which is essentially identical to what you've seen in the past. Documentation, videos, links to support, blog and community, and so on. Now the asterisks here basically just tell you that these two tabs, Home and Help, can be found or accessible across every single view, report, data, and model. Now in the report view, you'll also see a couple different contextual menus, like the Format and Data Drill menus. And these are only going to appear when you have a visual selected. And inside of these menus, you're going to find the same old tools that you're used to seeing. You can access alignment tools, you can edit visual interactions, configure your drill down and drill through functionality. We'll talk about all that stuff later. Another thing to note here, you can access contextual menus like table tools, column tools, and measure tools right here in your report view as well by selecting items in your field list, which we're going to talk about next. So data view tabs. What are the contextual menus that you can access inside of your data view? Well, if we look at our field list here, first and foremost, if you select a table, you'll see a new menu called Table Tools. And as you might expect, this is where you can access things like table attributes, you can manage your relationships, add calculations and measures, and so on. When you select a column from your field list, you'll see a new menu specifically populated with column tools. You can access your column attributes, set data types and column formats, sorting and grouping tools here as well. And then last but not least, when you select a measure, you get your third contextual menu called the Measure Tools menu. And this is where you can determine which home table a measure is assigned to, set a measure format, add a data category, and so on and so forth. So again, quick pass through these menus. Keep these slides on hand as a reference, but hopefully you're able to follow along pretty smoothly. With that, let's go ahead and continue with the rest of the course. Okay, time to roll up our sleeves and actually load our data into Power BI. In this section, we're going to learn how to connect to our source files, shape and transform our tables, and use Power BI's query editing tools to modify, merge, and append our data. Now, make sure you follow along carefully with each step because we're going to be using this data to build our data model in the next section of the course and eventually our reports and dashboards. So let's get started. Let's kick things off and talk about data connectors, because Power BI has a really robust connector library that allows you to access data from virtually anywhere. So when you open up Power BI Desktop, you can click on this Get Data button in the Home tab to access the Get Data dialog box. And this is where you'll see all of the sources available to you. And bottom line, there's a lot. You can connect to just about any type of source data, including flat files, Excel workbooks, folders, databases like SQL, IBM, Azure, online services which are more specialized like GitHub and Salesforce, or other sources like web feeds, R scripts, Hadoop, and so on. So tons of options for connecting to data. Now, I'm not going to speak to every single one of these, but let's fire up Power BI Desktop and I'll show you what this library looks like. Okay, so in this case, I've opened up a brand new instance of Power BI Desktop, and it takes me to this splash screen here. I can just close this out, or I can click Get Data right here on the left. Either way, I'm going to end up in the same place, which is the Get Data dialog box, which looks like this. And again, if you know you're looking for something specific, like a SQL source, you can use that search bar and kind of narrow down your results. Otherwise, you'll default to this all list, which shows you just about all of the connections available to you. Now, some of the interesting ones to call out, looking at the file options, these are pretty common ones, like text files, flat CSVs, contents from an Excel workbook. One of the interesting ones, which I'll show you a demo on later, is the folder. And this allows you to point Power BI to an entire folder containing files so that you can automatically append and blend new files as they're added to that folder over time. Really, really great automation technique, which again, I'll show you in just a bit. Database options kind of speak for themselves. You've got MySQL, Azure, IBM, all sorts of database options here. Online services has some interesting ones as well. Microsoft Exchange, Dynamics, and then some of the more specialized tools here like Google Analytics, Adobe, Salesforce, Facebook, GitHub, and MailChimp. So definitely worth looking through the connectors that are available for you here. And then last but not least, in the Other tab, got some interesting ones in here as well. You can actually type in a web address to scrape data from a web source, or you could launch a blank query. And if you know how to write M code, you can generate a custom connection yourself. And we're actually going to do a simple demo using a blank query by creating a dynamic rolling calendar that updates based on the current date. And we'll cover that later in the section. So it's important to note that in this course, I'm not going to walk through these different types of connectors. And it's not because I'm lazy or because I don't want to. It's because the process is remarkably consistent and user-friendly across the board. So whether you're connecting to a database, a file, an online service, once you enter the specific information, maybe it's the server name and authentication for a database connection, for instance, once you get past that step, you always arrive at the same end result, which is the query editor. And that's where we're going to be spending most of our time. Now, for the purposes of the course and for ease of use, we're going to be using CSV files. Since they're simple, they're ubiquitous, you can download them straight from the course resources. But again, all of the concepts and tools that we cover in the query editor really apply to everything here, no matter the original source. So with that, let's move on and dive into the query editing interface. Now, when it comes to connecting and transforming data, the query editor is our cockpit. Now in Power BI, from the Home tab, you can click Edit Queries to launch the query editor. And there's a lot going on here. We're going to be spending most of our time in this section right here in the editor itself, but let's take a minute to break down the components of this interface. Right up there at the top, we've got our query editing toolbox. This is where we'll find all of the tools that we'll use to shape and transform our data. Right beneath that, you'll see a formula bar, and it's got some unfamiliar code in there. This is called M code, and I didn't write it. This is code that's automatically generated as you apply different procedures or steps to your table. For those of you who are advanced Excel users, this is exactly what VBA does, as it automatically generates Visual Basic code while you record a macro. Now, don't get nervous because you don't need to even know M code to use the query editor. In fact, we really won't be touching M code at all in this course. You can write custom M code from scratch, and you can edit the M code that's automatically generated for you, but you don't need to in order to use all of the tools that we're going to cover in this course. Now, on the left side of the query editor, we've got our queries or query list. Here you can see that I've got 9 individual connections or data queries in place. You can click through to see previews of your data. You can edit the properties, change the applied steps. Basically, any modification that you want to make to an existing query, you can do so here. And as you select individual queries, you'll see this data preview in the middle of the screen update. This is where we can spot check and QA our data and do things like change column types and headers. On the right side, we've got our properties pane. The most important thing to call out here is the table name. Now, it's really important to be strategic and clear with your table names right off the bat, because it can be a pretty big headache to change them later on, especially if you've already referenced them in multiple calculated fields and measures. So, rule of thumb, be strategic and careful about your table names from step one. And then last but certainly not least, the applied steps pane here in the lower right. This is really powerful because what's happening here is that every time you make a change to your data, every time you apply some sort of shaping or transformation operator, Power BI will record an applied step using that M code and add it to the list here. And what that means is that every time this connection is refreshed, Power BI will run through that same set of applied steps to shape and transform your data. And that's a great way to automate things like data cleansing or ETL processes. You don't want to end up running the same processes manually over and over every time you connect to the data. This automates that process for you. You record it once, and then you're good to go moving forward. But perhaps the most helpful thing is that none of this is set in stone. You can click on the X next to any individual step to remove it. You can click through each of your applied steps to actually visually see the impact that it's having on your table, or you can click the gear icon on the right to modify or edit individual steps in the process. Now, moving on into the query editing tools, I want to take a minute to introduce the three primary tabs or categories. First, we've got our Home tab. This includes some general settings, data source settings, parameters, table properties, etc., as well as some of the most common table transformation tools. The next tab, Transform, includes additional tools that allow you to modify your existing columns. You can split or group columns, you can transpose your table, extract text, etc. And then finally, the Add Column tools actually create brand new columns in your table. And you can define those new columns based on things like conditional rules or text operations, calculations, date operators, etc. From here on out, we're going to jump into demo mode, actually get our hands dirty, and practice working with these tools. Got a lot to cover, so let's dive in. All right, so let's kick things off. Let's start nice and easy with table transformations. Now, if you go to the query editor, look in the Home tab, you'll see all sorts of basic table transformation options. Let's talk through some of the most important ones. First off, you can choose to keep or remove certain columns or rows from your table. There are a few interesting options here. Looking at the columns options, you can either select the column that you'd like to remove or select the column that you'd like to keep. Now, that might not seem like a really important distinction, but it can be really helpful in certain cases. So let's say you've got a data connection to a table that might have a variable number of columns. One month it might have 10, the next month it might have 20, but at the end of the day, you always want to land with the same set of 5 columns. If you were to open up the query editor and manually remove each of the columns that you don't want, then any new columns that appear won't be accounted for and will end up in your final table, which you don't want. On the other hand, if you select the 5 that you always want and you say, hey, Power BI, these are the 5 columns I need, anything else that you find in the table, remove it, then you'll be good to go moving forward. So it's a bit of a nuance, but actually a really helpful tool when you need to do something like that. As far as the rows are concerned, you've got some basic options here. Remove the top rows or bottom rows. You can set a specific number of rows to keep or remove. This is really helpful if you have files that might have header rows or footers or grand totals that you need to strip out. Other options here, you can remove alternate rows or you can remove duplicates. And that can be a great way to actually create new lookup tables from scratch by creating unique lists of IDs, for example. You'll also find some basic sorting options, A to Z, low to high, etc., as well as options to change your data types or promote your header rows. Now, Power BI is pretty smart about headers. By default, it should identify and promote those header rows for you, but in case it doesn't, you can always do that manually using this tool here. And then last thing to call out, if you right-click any column header, you can access a lot of these same common tools. plus do things like duplicate, move, or rename columns. And this is a common theme that we'll see time and time again as we work with the query editor, which is that the same tools are often available in multiple places, multiple menus, multiple tabs, sometimes even multiple views within the Power BI file. So with that, let's open up a brand new workbook and connect to our first data source. All right, so I've opened up a new blank Power BI file. Go ahead and do the same, and make sure that you follow along carefully with what I'm about to demonstrate, because what we're doing is actually connecting to the source files that we're going to use to build our project throughout the course. So as you work through these demos and through the homework exercises, you'll be building up all of the pieces that we'll need to assemble into our final project by the end of the course. So let's get started by clicking on the Get Data dropdown. This allows me to access the most common options. In this case, we want a text or CSV file. And what I've done here is create a folder called Power BI Course Files on my desktop. And then within that, I've added a new folder called AdventureWorks. And this is where I've saved all 10 of those CSV files that are available for download as part of the course. So in this case, the file we want to work with first is adventureworks_products. So go ahead and double click to open that one up. Now, as soon as you've selected a file, the first view that you'll see is this preview window. And this has a couple options worth paying attention to. It will automatically detect the file origin as well as any delimiter in place. In this case, comma is correct since this is a CSV file. And then this data detection dropdown basically says, okay, do you want Power BI to take a little sneak peek at your data and take a guess at what these data types should be? If so, do you want it to base that guess on the first 200 rows? Do you want it to be based on the entire data set? Or should we not detect data types at all? In which case you can manually add those data types to your columns in the query editor. So by default, let's just keep it on the first 200 rows. Usually it does a pretty good job detecting the correct data types. And now from here, you can just load straight into your workbook. You can bypass the query editor entirely. As a best practice, I would recommend against doing that. Even if you don't think you'll need to make any sort of transformation to your data, launching the query editor is a great way to just QA and make sure things look good. So let's go ahead and hit Edit, which will open up the query editor. All right, so here we are. We're in our query editor. We've got our one lonely query here, AdventureWorks_product, which you can see has been named based on the file name itself. The same name has been applied to the table, AdventureWorks_products. And take a look at this. There are already 3 applied steps that have been made, and all we did was double click on the file. We haven't done anything else. So let's actually click back through and see what Power BI has done here. And if we expand this formula bar so we can see the M code, we'll get a sense of what's really going on here. So the first step, the source step, this will always happen. And this is just Power BI saying, okay, let's go find the file location and let's pull it in. In this case, we're looking at a path on my C drive, and it's finding the folder on my desktop and grabbing the AdventureWorks products CSV file. Now, I think this goes without saying, but your path will look different unless your name is also Chris and you've created the same exact file on your desktop. So that's step 1, the source, which makes sense. But look at the preview here. Notice how we've got these empty placeholder column headers, and then our first row contains the actual column headers. So the next applied step, as you may have guessed, identifies, it detects those headers and promotes them to the first row. And then from there, the third step looks like it's just changing some data types based on the detection that we talked about in the preview window. So jumping back and forth, you can see it's changed some text strings into whole numbers, numerical values, which looks good. So that's pretty cool. Power BI has already done quite a bit to help clean up this data set for us. And now from here, there are always 2 steps that I start with in the query editor. Every time I connect to data, every time I load up a table, I start with these 2 steps. Step 1 is updating my table name. So let's go ahead and select this and update it to AW_product_lookup. And I'll tell you more about why I'm using lookup in the table name once we get to the Data Modeling 101 section. but that should do the trick. AW product lookup. I can press enter to lock that in. And the second step that I always take in the query editor is to scroll through my column headers and make sure my data types and column headers look good. So let's go ahead and just collapse this formula bar. We've got product key, which is integers, got subcategory key, and then a whole bunch of text fields. Product SKU, name, model name, product description, the color, the size, the style, and then two more numerical fields here, the cost and the product price, which are decimal values. Now we could update these last two to currency or fixed decimal numbers, but I'm going to show you how to do that in a separate place later on, so don't worry about these two just yet. Now things look pretty good here. I don't really need to do much to this table at this point, it's pretty clean, but let's say we don't really want the product size column. It's kind of messy, we've got a mix of numerical sizes as well as text-based sizes like large, medium, small. So let's just remove this column. And like I mentioned on the slide, there are a couple ways to do it. I can either use the remove columns option here in the home tab, or I can right click the column header itself and click remove. And when I do that, it's added a new applied step and removed that column. So that's just about all that I need to do here as far as transforming this table is concerned. If I wanted to, it looks like my product keys are sorted low to high, but if we wanted to make sure, we could go ahead and use the sorting options to do that here. And I think that just about does it. So we've applied some table transformations to our product table. We've given it a meaningful name, and we've confirmed that the data types and column headers look good. So all that's left to do is press this close and apply button, and it will go ahead and load it into our file. So now we can see on the right side in our fields list in the report view, we've got this AW product lookup table with all the fields listed out. You'll also see it in the data view. Here we go, the same table, same fields. And last but not least, it will appear as a new object right here in our relationships view as well. So congratulations, we just created our first data connection in our workbook. Why don't you go ahead and save this workbook. I'm going to call it AdventureWorks_report. You can name it whatever you want. And this is a PowerBI file .pbix extension. Press save, and you are good to go. Next up, we've got text-specific tools. And looking at the Transform tab in the Query Editor, you'll notice that Power BI groups different sets of tools together based on their purpose or function. So in this case, we'll find all of our text-specific tools grouped together at the end of the ribbon. And within this group, we have some really interesting, powerful options. For one, we can split up a column based on a specific character or delimiter, or based on a number of characters. We can format any of our text columns using basic formatting options like lowercase, uppercase, proper case, which is capitalizing the first letter of each word, or we can use tools like trim, which eliminates leading and trailing spaces, or clean, which does the same thing and also eliminates non-printable characters. Now you might be thinking that those trim and clean options really aren't that helpful until you run into the case where you have one trailing space in your data set. And trust me, this will drive you crazy the first time you experience it until you figure it out. And the problem is, as human beings, we are incapable of seeing a trailing space. It's completely invisible to us, and it looks exactly the same as another data point without that trailing space. But to Excel, or in this case to Power BI, it looks like a completely different and unique value. So in cases like that, trim or clean can be great tools just to standardize and help avoid issues like that, especially if you're working with really messy or unstructured text data. We also have some great extract tools. We can extract a certain subset of characters from a string based on a specified length. We can extract the first or last number of characters or a range, but where it gets really interesting is using delimiters. So we can tell Power BI that we want to return all of the characters before a specific delimiter or symbol or character, or after it, or between two distinct delimiters. And there are also some advanced options as well that allow you to specify whether you search from the left side of the string or the right, and if you want to skip a certain number of instances of the delimiter before returning text. So some really great flexibility there with those extract tools. So you may have noticed that some of the tools here are grayed out and inactive, like merge columns or parse. And that brings up a really important point, which is that this toolbar is completely dynamic based on what you've selected. So if you've only selected a single column, the merge columns option is irrelevant, so you can't even click it. You'd have to select multiple columns in order to activate that option. And then taking that even further, if you've selected a column that's numerical instead of text, this entire group of tools might be replaced by number-specific tools instead. So just remember that the entire ribbon, the entire toolbar that you're seeing here will dynamically change based on your selections. Now, one more very important point before we shift gears into Power BI. Anytime you see this yellow box that says, hey, this is important, you guessed it, I'm about to talk about something important. So that means focus in, pay attention, stop playing with the dog or checking Facebook, because this is something that is going to come up time and time again in the course, and it's really, really important for you to fully grasp and understand. So what I want to talk about now is the difference between transform and add column, because this is something that confused me for longer than I care to admit. And what I was noticing was that the same tools, in fact, the same identical sets of tools, kept popping up in different places. And for the longest time, I just thought this was really confusing and redundant until I realized that the outcome is completely different depending on where you select that tool. So when you select a tool from within the Transform tab, you're essentially modifying or overwriting the column that you've selected. But when you choose a tool from the Add Column tab, you're creating a brand new column to your table. So that may sound really obvious when I say it now, but I guarantee as you're learning this tool and as you're playing around with the query editor, you will at some point in time select the tool from the wrong tab. And that's okay, because obviously nothing's set in stone. It's as simple as just deleting that last applied step and you're back where you started. But it is something to keep in mind, and hopefully that will help you at least understand where you're going wrong and why these tools appear in multiple places. So let's open up Power BI and get our hands dirty with some of these text tools. All right, so here I am in my AdventureWorks report. Go ahead and open it up as well. I'm gonna head back into the Get Data option, click Text CSV again. This time, instead of products, let's go into AdventureWorks Customers and double click. Here we've got our preview. All of these default settings look good. So I can go ahead and click Edit to launch the query editor. All right, so first things first, here's our AW product lookup query that we created in the last lecture. And now we see a second for AdventureWorks customer. So let's go through those two steps that we do every time we get in here to the query editor. We're going to start with the table name. And for the sake of consistency, let's go with AW underscore customer lookup. The last file that we loaded was called product lookup, and it was called product lookup for a reason, because it had all sorts of information about individual products, where each row represented a unique product key and each column represented some attribute about that product. Now, similarly, here we're looking at customer data instead. So I can press enter, lock in my table name, and as I look in the preview here, as you can see, I've got a customer key and then all sorts of attributes about my customers. So let's go ahead and finish our quick QA. We've got column headers that look correct. Let's look at the data values very quickly. Our key is a whole number, which is good. We've got names, which are strings or text fields, which are good. We've got a birth date column, which is a date, represented by this little calendar icon in the top left. And then as we scroll through, marital status, gender, email, all text. This one's interesting. It actually recognized the annual income field as a currency or fixed decimal. That's fine, we can leave it as is. And then we've got total children, education level, occupation, and a homeowner yes, no flag, all text. So check those boxes, everything looks good. And now we can proceed to our table transformations. So first things first, let's scroll over. I've got my eye on these name columns because they're all uppercase and that looks silly to me. So I'd like to make those proper case instead. So let's go ahead and select the prefix column, go into add column. We'll find our text tools here. And what we want to do is go into the format tools and click capitalize each word, which is proper case. And when we do that, it created a new column here at the end of our table, which is essentially a duplicate version of our prefix column, but with the correct capitalization. And you can see that the header name has been defaulted to capitalize each word, which is just totally ridiculous. And as you probably have guessed by now, the reason this happened was because we accessed that format tool through the add column tab, when what we really wanted to do was simply overwrite the existing column and transform it. So we should have accessed the formatting tools through the transform tab instead. And so that's what I'm talking about. It's very easy to make these kind of mistakes. So you really just have to be vigilant about knowing which tab you're in each time you create a calculated column. But no worries, the good news is that it's a very easy fix. You can't Control Z to undo here. The equivalent is just going into your applied steps and pressing the X to remove that last step that we just created. So now I'll scroll back, select the prefix column again, make sure that I'm in my transform tab, and go through that same process. Format, capitalize each word, and there you go. It's overwritten the values into the format that I'd prefer. Now to do the same thing to the first and last name columns, I could do them individually, or I can select one, hold the Shift key, click the other. That will grab both of them at the same time. And let's do the 2-for-1 special. Capitalize each word. So now I have a nice clean prefix, first name, and last name. So that's helpful, but I'd really like to have the customer's full name accessible in a single field as well. So what that means is that I'd like to merge all three of these columns together and separate them with a space to create a brand new column that I'll name full name. So what I've done is select prefix, I've held Shift, selected last name to grab all three, and instead of clicking merge, warning signs, we're still in the transform tab. I need to make sure to go into add column instead and access the merge tool from here. So when I click merge columns, it gives me a little dialog box with some options. In this case, I do want a separator in between the values. I want that to be a space. And let's name our new column full name. So I'll press OK. And you can see it's added a new step. When I scroll to the right, there we go. We got our new full name column. Looks good. We've got spaces between the names. And now one thing to note, just kind of a side note, it added this step, but it kind of gave it a default name that says inserted merged column. Now, as I click through, it's pretty easy to see exactly what column was merged and what was added. But if we want to make this even more clear, I can always right click and rename that step. And instead of just saying inserted merged column, I can actually type full name. That just makes it a little bit more explicit what's going on. I inserted a new column and it's called full name. All right, so next up, I want to make a couple more changes. I want to really focus on this email address column here. And the first thing that I want to do is extract the username from this email. But the problem is I can't just say, give me the first 5 characters, because that would work for John 24, but not Eugene 10. So it's got to be a dynamic number of characters from the left side of this email address based on the location of that @ symbol. So this is where we're going to use that extract based on delimiter option. So let's go ahead and select email address. I want to add a new column for username. I'm going to use the extract tools here. So again, not just a default length, not an explicit number of characters, but I want the text before a delimiter. So here you go. All I need to do is say the delimiter that you're looking for is that @ sign. If we drill into the advanced options, this is where you can say, search from the left or search from the right. You can skip a certain number of instances of the delimiter. In this case, we don't need any of that. All we want is the text before the @ sign. So press OK, added a new column. As you can see, it didn't let me name the column at the same time, but it did give me the values that I want. So what I can do here is just double click the column header and I can give it a name. Let's call it username. Now let's do one more similar example, but with one more complication. So going back to our email address, what if this time instead of the username, we want to return the domain name? And the domain is anything that falls between the @ symbol and the .com at the end of the string. To do that, I can use the same extract tools, but this time I want the text between two delimiters. So I can go into this option here and I can say my start delimiter is the @ sign and my end delimiter is either the period or I can type .com. Both will do the same thing. And when I press OK, same exact idea. It's given me a new column with the string or the characters between those two delimiters. I can change the column title to something like domain and press enter. And there you have it. So very, very easy way to do some pretty complex stuff. So one last adjustment to make to this domain column here. I want to get rid of the dash and replace it with a space. So to do that, I'm going to transform the existing column, not add a new one. And you'll see this other grouping of tools that say any column. That means they're not text or number or date specific. They can be applied in a number of different circumstances. In this case, I'll find the replace tool right here in this set. So it's as simple as it sounds. I can find the dash and I can replace it with a space, press OK. Now I've got adventure space works. And why don't we go ahead and format that capitalized in proper case, and we are all set. So there you go. We used the formatting options. We added columns, we transformed columns, we used the extract tools based on delimiters, we merged columns. Some really good examples of how these different text functions can be used to enhance and clean and transform a data table. So I think we're all good with customer lookup. The only thing left is to go back to our home tab and click close and apply to load that data into our file. And as soon as that loads up, we'll see that it's going to appear as another object right here in our relationships tab, right next to our friend product lookup. We'll also see it available in our field list, accessible in both the data view and the report view. So there you have it, query editing text tools. All right, moving right along. Next up, we have our number specific tools. So back to that transform tab in our query editor. Assuming we have a numerical column selected, you'll see a group of number specific tools active that look like this. And the first option within those number tools are the statistics functions. These are your aggregators like sum, min, max, median, average, standard deviation, and count distinct. Now you may be wondering, if you have a whole column selected and you apply an aggregation function that's designed to return a single value, how does that work? And I'll show you exactly how that works as soon as we jump into Power BI, but the answer is that these all return one value. So the entire table gets replaced with one single value. And as a result, you really don't use these statistics functions within the query editor as a means of transforming or preparing a table for loading, but rather as a way to explore it and maybe get some information about it. So the count of products, the maximum cost, the median age, questions like that. Now the next set of tools within this group, the standard, scientific, and trigonometry tools, these actually allow you to apply row-level operations. So you can apply some standard operations like addition, multiplication, division, or some more advanced calculations like log, sine, tangent, etc. And these are actually applied to each value in a column. So unlike the statistics options, these tools are applied to each individual row in the table. So we're going to be using a ton of arccosine and arctangent throughout the course. Just kidding, we're not going to actually touch the trigonometry stuff. If you're looking to go deep into the trigonometry world, unfortunately, I'm not your guy. But that's neither here nor there. In addition to those standard, scientific, and trig functions, you also have your info functions. And these basically just allow you to define binary flags either true false or 1 0, to mark each row in a column, whether it's even, odd, positive, or negative. So let's open up Power BI and practice some of these number tools. All right, so here we are in the AdventureWorks report. This time, instead of grabbing new data, I actually want to edit the product data that we've already connected to. So in that case, I'm going to go to my Edit Queries button. And that just jumps me straight to the query editor, where I'll see the two connections that I have in place, product lookup and customer lookup. You'll notice that all of the applied steps are still there, preserved. And in this case, I want to jump into product lookup and play with some of these number-specific functions. So if I jump to the Add Column tab, here are my number-specific tools. You'll notice that the statistics function is grayed out. And remember, because the statistics functions are aggregators, they're going to return a single value. So it doesn't make sense to add a new column that's derived by one of these stats functions. But when we move to the Transform tab, now you'll see the same set of number tools, and this statistics option will be active. And here you'll see all of those aggregation functions. So let's say we wanted to know the number of unique products captured in this lookup table. I could select the product name column, for instance, go into Transform, Statistics, and you can see that all of the options that require a numerical input, like sum, min, max, are grayed out. Since I'm selecting a text column, the only thing I can do here is count the values or count the distinct values. And in fact, all of my other number-specific tools are grayed out as well. So in this case, I want a distinct count of products. I can select that last option, and my whole table disappears and is replaced with that one aggregated value of 293. So what that tells me is that there are 293 unique product names in my product lookup table. And like I mentioned, as you can see, it's pretty obvious this isn't a means of transforming or preparing data for loading it into Power BI. It's more of an exploratory analysis. So almost every time you use these stats functions, you're going to go ahead and remove that last step to return back to where you started. So let's go through a couple other quick examples. I'm going to scroll all the way to the right to my product price column. And now in this case, I'm curious, what's the average product price in this AdventureWorks data set? So back to my Transform menu, the only place I can access my statistics tools, and I can drill in and calculate the average retail price, which is $714.44. Now that feels pretty high, but if we close back out, you'll see that we're dealing with cycling products, which include some pretty high ticket items like these road frames. And if we scroll over, you'll see that some of these are $1,200, $1,300, some are even higher. In fact, we can go ahead and use another similar statistics function to answer that question precisely. Transform, statistics, maximum this time, and we see that the highest priced item, the maximum product price in the lookup table, is $3,578.27, which must be an extremely expensive bicycle. So there we go, we can X out, back to where we started. And let's test out just a couple more of these tools. Scroll back to our cost and price columns. This time I want to round these off to just 2 decimal places. So let's do it both at once. I can click product cost, hold shift, click price to grab both. And then I want to transform these columns. Don't want to add anything new. I'm going to use the rounding tool this time. And what I can do is choose the third option, round, and say, let's round it to 2 decimal places. Press OK. Both those columns are transformed. Now both reflect just 2 decimal places, and we're good to go there. Now, one last thing I want to show you. I want to do a demonstration of these standard operations here. And so what I'm going to do is not transform this column, but I'm going to select the product price and add a new column using a standard operator. So what we're going to do in this example is we're going to add a multiplication step here. And what we'll do is multiply each value in our product price column by 0.9. In other words, I want to return 90% of the product price for each row. And this might make sense if AdventureWorks as a company, often ran 10% off deals. This might be something like a discount product price. So I can press OK. It's going to create a new column. By default, it gives the column header a name called multiplication. So let's double click and let's call that discount price and press enter. And just like we modified the product price and product cost columns, let's go into transform, rounding, and we're going to round this to 2 decimal places and press OK. And that looks good. So I think that's just about everything that we need to do as far as modifications to the product lookup table are concerned. So let's head to home. And now when we press close and apply, it basically just updates the query, loads the refresh table into our model. And there you have it. So nothing else has changed. We still see our tables here. This product lookup now reflects those new fields that we added, including discount price here at the bottom. So there you have it. That's your crash course in query editing number tools. All right, let's move on to date specific tools. Looking at the add column menu in our query editor, you'll see those date and time tools grouped here on the right. And these are actually pretty straightforward. We've got a few options here. One of the more interesting ones right at the top of the list is the age option. And that actually automatically calculates the difference between the current time based on the today or now function and the actual date in each row. You also have the date only tool, which basically looks at any fields that might contain both a date and a timestamp, and it strips the time component out and leaves you with just that date only. You also have your pretty basic set of date component functions like year, month, quarter, week, and day. And that basically just extracts individual components or individual attributes from a date field. And if you're selecting a field that has a timestamp as well, you also have similar time-specific options like hour, minute, and second. 2 other ones that I want to call out here, earliest and latest. You'll see those 2 at the bottom of the list, and they're both grayed out. And that's because we're in the add column menu, and both of those functions act just like the statistics tool, and they return a single value. So to access those 2 options, you'll need to grab them from the transform option. And as you might have guessed, the earliest option is going to return the earliest date in the column. Latest is going to return the last date. So quick note here, you'll almost always want to perform these date operations from the add column menu as opposed to transform, since most of the time the goal is to actually build out new fields using these date components as opposed to overwriting or transforming an individual date or time column. So pro tip here, what you can actually do in Power BI quite easily is load up a table that just contains a single set of dates, or you can create a date table and then use these date tools to actually build out an entire robust calendar. So that's exactly what I'm going to show you how to do in a second, but first let me give you a little peek of what that's going to look like. So we're going to start with a single column containing dates. We're going to apply those predefined date options using the add column tab in the query editor. And we're going to transform that individual column into an entire calendar containing additional fields like the day of the week, the day name, the start of the week, month, quarter, year, etc. So let's open up Power BI and give this a shot. All right, so if you're following along, go ahead and open up your AdventureWorks report file. You should see those 2 tables. We've got customer and product. We're going to go ahead and get data and grab a 3rd table from a CSV. And this time we want our AdventureWorks calendar table. So when you double click, preview looks very straightforward, just a single column containing our dates. Go ahead and click edit to launch the query editor. And here we are. So first 2 steps, table name first. Let's make it consistent, AW calendar. I could leave it here, but since this is technically a lookup table as well, I want to be consistent. So I'm going to add lookup at the end. So AW underscore calendar underscore lookup. Press enter. Obviously the data type looks good, recognized and formatted as a date. And I've got a column header. So check, check, we're good to go. And now let's explore some of these date tools. And I want to actually start with the earliest and latest options. So I'm going to go to the transform menu, which again is the only place I can access these two options. And when I click earliest, it behaves just like those stats functions, transforms the entire table into a single aggregated value. In this case, it's one date, January 1st, 2015. That tells me that's the earliest date in my sample. So we can close that step, get back where we started, and repeat the process for the latest date, 6/30/2017. So that tells us that the scope of the data set that we're dealing with is from January 1st, 2015 through the end of June 2017, or about 2.5 years of daily data. So I'll X out of that applied step as well. And now let's shift gears into the Add Column tab. And this time I want to create some new fields based on this date. So as you can see, I've got all my options here. Let's start with a day option and choose name of day. So obviously that just created a brand new column, exactly like we'd expect, and it gave it a column header by default of day name. Now I can customize those headers. In this case, I'm okay with that, so I'll leave it as is. And now it's important to note when you use these date tools that you have to have your date column selected to access those tools. If I accidentally selected day name, for instance, which is really just a text string, and I access those tools, you'll see that now they're grayed out. You can't really do anything except parse that field since it's a text string. So I'll select my date again, and now I've got access to everything. So another interesting one I want to show you is week. And I want to do the start of the week here. And there you have it. As you can see, Power BI has decided that a week starts on Sunday. So January 4th, 2015 was a Sunday. The next week starts on January 11th, which was the next Sunday, and so on and so forth. You can actually change this, and it's not very intuitive. You actually have to dig in to the M code, which I told you we weren't going to do, but I lied. I want to show you this just because it's a really helpful little tip. And what you're going to do is I expanded the formula bar here, and you see where it says date.start of week and then the word date in brackets. I'm going to click my cursor right after the closing bracket and press a comma. Now there's two different ways to determine a custom start date for the week. Number one, I could type just a number, which Power BI will interpret as a day of the week. And I know for a fact that number 1 represents a Monday. So if I just type that 1 and press enter, now you'll see these dates all shifted by 1. So now the start of the week is on a Monday, the 5th, the 12th, the 19th, etc. You can go back in and press 2. You'll see they shift again to a Tuesday. So that's the first way to update. The second way, which is a little bit more readable, is to actually type day dot and then the name of the weekday. So day dot Monday, and there you go. I've got my Monday start weeks, January 5th, 12th, etc. So let's go ahead and leave it just like that, as is. I'll collapse my formula bar, and now remember, I have start of week selected. I'm going to go back and select date before I access these tools. And now let's go ahead and grab some month fields. So I want the start of the month, Jan 1, scroll down, Feb 1, looks good. Select date again. Let's go ahead and do the month name at the bottom here, name of month. There we go. And then we'll do 2 more for the years. I don't really need quarters in this case. So let's do the start of the year. And then the last one, let's do the actual year itself. So year. And that looks like a great start. I think that's pretty much all that I'll need. I've got date, the day name, the start of the week, start of the month, name of the month, start of the year, and the year itself. And so what this calendar table will allow me to do is filter and segment the values in my data set, in my data model, by any of these fields that I've just created. So it will allow me to look at things like sales not only by day, but by week or by month or by day of the week. And that's going to be really helpful as we start using more of these analysis and visualization tools. So our calendar is good to go. Let's click on our Home tab, press Close and Apply. and it will load it up into our model. And there you go, we have our third table accessible here. Let's check the relationships view. 3 table objects with all of those fields we just created based on that one single date column. And there you have it, query editing date tools. I want to share a pro tip with you guys that I think is pretty cool, and it's creating a rolling calendar. So in the case that we just walked through, we loaded up a discrete set of dates because we only wanted to analyze the data that we had on hand. In our particular case, we won't need to change that calendar. We won't need to pull in new data or analyze new information over time. But what if you're in a situation where you do? Maybe you've built a weekly report that you want to refresh with new data every week and share with your colleagues or your boss or your client. Rather than creating a fixed calendar and updating it over time, what we're going to do is actually use a little bit of M code. And I know this is the last bit of M that we're going to touch, but trust me, it's worth it. We're going to use that M code to create a calendar that will update based on the current point in time. So it will act as a rolling calendar that evolves as time goes on. So I'm going to lay out the steps here, and then we're going to jump into Power BI, and I'll demo what that looks like. So step 1, this is going to be a great time to test that blank query option that I showed you earlier. So we'll create a new blank query. And then in our formula bar, we're going to generate a starting date by entering something called a literal. And you're going to write it exactly like it's shown here with a hash mark, the word date, and then a starting date, whatever you choose, in the year, month, date format. So in the example we're looking at here on the slide, this would represent January 1st, 2018. From there, you're going to click the FX icon, which adds a new custom step, and you're going to enter the following M formula. Now, I know it's a lot, and I'll post this function into the Q&A section as text so that you can copy and paste it, but we're not really going to dig in and unpack how this formula is working. We're just going to use it almost like a recipe to create our list of dates. So once you've added that formula, a list will populate in the query editor, and then we're going to convert that list into a table, and then we'll format that column as a date. Last but not least, if you want to, you can add some more calculated date columns, just like we showed with our last example. You can add years, months, week, whatever you need using those add column options, but it's really as simple as that. So let's hop into Power BI. I'm going to write out this formula, and I'll show you exactly how it works. All right, so I'm back in my AdventureWorks report. This time I'm going to go into the Get Data option, but instead of choosing CSV, I'm going to pick that blank query option down at the bottom. This takes me straight into the query editor and creates a new query just called query 1. And if we wanted to, we could give this a name like rolling_calendar. Don't worry too much about this because I will be deleting this query after I write it. But just for the sake of habit, you'd want to give that a proper table name. And then inside of the formula bar, this is where we're going to type that formula that I just reviewed. So first step was to use the literal equals # or hash, date, open parenthesis, and then for the sake of example, let's use 2018, comma 1, comma 1. That will give us January 1st, 2018. And when we press enter, it just basically creates a single value, 1/1/2018. So that's not very helpful yet on its own, but it's a good starting point. The next step is to click this FX button to add a new step. And right here where it says equals source, this is where I'm going to type that long M formula that I shared with you. So follow along. I'm going to move kind of quickly, but go ahead and pause it once I enter the whole function so that you can make sure you've got it written down. So we're going to start with list.dates, open a parenthesis, source, comma, number dot from, open paren, date time dot local now, quick open and close paren, just like the now or today function in Excel. We're going to close out one more parenthesis, minus number dot from, open paren, source, close paren, comma, #, duration, open paren, 1, 0, 0, 0, and then 2 closed parentheses to end it. Now, without diving too deep into exactly what this M code is doing, in a nutshell, what we're saying is calculate the current date, compare that against the literal that we just created, which is our starting date, and then based on the difference between those two dates, I want you to list out all of the individual values where the duration is 1 day. So it's basically saying, give me a list at daily granularity between those dates, the literal and the current date based on today. So when we press enter, there we go. It created this whole list. And look at this. It starts at 1/1/2018. And as I scroll down through, it ends at 4/16, which is the current date. It's April 16th, 2018, as I'm recording this. And if we were to refresh this query a week from now, that end date would extend 7 more days. So we've essentially created this dynamic rolling list of dates. That was the hard part. Now all we need to do is click this new List Tools tab that popped up. And we're just going to click this button on the left to Table. And it basically converts it into a table. There's no delimiter. We shouldn't have any errors here, so we can just press OK. There we go. Final step is to format and name the column, and then we should be done. So go ahead and format as a date. Instead of column 1, you'd call it something like date. And now we've got a single column date table, just like we started with in the last demo. And from here, we could go ahead and add as many of those calendar fields as we wanted to. So really great tip that I use a lot in my own work. I manage a ton of reports that have to be updated very frequently, and this rolling calendar is a huge time saver for working with reports like that. So for the purposes of this course and this demo with our AdventureWorks data, we actually don't need the rolling calendar. We're going to rely on our AW calendar lookup table instead. So I know we just did all that work. We could keep the calendar here if we wanted to, or in this case, I'm just going to right click and delete that query. Really just want to focus on the one calendar table that we've got for the sake of this analysis. But there you go. Let's close out of the query editor and we're back to square one. So that's your pro tip, how to create a rolling calendar. Let's talk about 2 more types of columns that you can add from within the query editor: index columns and conditional columns. So starting with index columns, you'll find the option right here in the Add Column menu. And basically what an index column is, it's a list of sequential values that uniquely identify each individual row of a table. Typically these start from 0 or 1, and they're most often used to create unique keys or IDs that can be used to form relationships with other tables. And I know we've been kind of hinting at this idea quite a bit. That's going to be covered in depth in the Data Modeling 101 section of the course. So index columns, super simple. Moving on to conditional columns, these are a bit more interesting. You can find them right there above the index column option in the Add Column tab. And basically these allow you to define new fields based on logical rules or if-then conditions. So example that we're going to be walking through is creating a new conditional column that we're naming quantity type. And the way that we want to define quantity type is a function of the order quantity column. So we can tell Power BI for any row in our table where the order quantity equals 1, I want to set my quantity type equal to single item. If my order quantity is greater than 1, I want to set my quantity type to multiple items. And then you always have this kind of catch-all value if false otherwise statement at the end. That's basically the value that you want your column to take in the case that all of the rows or line items above are false. So Power BI is going to cycle through each row from top to bottom, and if none of those conditions are met, that otherwise statement is the value that's returned. So let's open up our AdventureWorks report and see what this looks like in Power BI. All right, so I'm looking at the relationships view. I see the 3 tables, 3 connections that we already have in place. We're going to go ahead and add a 4th now. So follow along. We're going to get more data from a CSV. And this time I want my AdventureWorks Sales 2017 file. And preview looks good. Let's go ahead and edit it to jump into the query editor. And right off the bat, let's simplify this table name a little bit. We're just going to change this to AW Sales 2017. Now you'll notice that I'm not adding the word lookup to this table name, just like I did with product, customer, and calendar. And that's intentional because we're not dealing with a lookup table here. We're dealing with something called a data or a fact table. And we're going to explain what that means in the data modeling section of the course. But to give you a quick teaser, essentially we're looking at order quantities and order line items here with keys that will allow us to map those orders to territories, to customers, to products, and if I scroll all the way over, to dates. So no need to dive any deeper than that quite yet. Just put that in your back pocket because that will come into play in the next section of the course. So why don't we go ahead and practice adding an index column. So we'll add column, index, and if I drop down that menu, you can select to start from 0 or 1, or if you're feeling crazy, you can start with any custom number you choose. In this case, my keys or my ID columns typically start from 1, so we can choose that option. Creates a new column here at the end. Kind of interesting, it formatted it as a decimal number, which doesn't really matter, but let's go ahead and make it a whole number, just like the other columns here. And a little shortcut, instead of dragging it to the beginning of the table, you can right click and use this move option and move it to the beginning just in one click. So there we go. Maybe this is something like an order ID that we want to use to kind of track each individual order, in which case we could rename the column. But to be honest, we don't need this ID or key column here. In fact, it may just complicate and confuse things down the road. So I'm actually going to right click and remove this column. Now what's interesting here is that I've landed basically exactly where I started. This is the table in its current untouched form, but you'll notice that there are now 7 steps in my applied steps here, because even though I removed my index column, that step was recorded and that step still exists here in the history of my applied steps. So what this means is that whenever this Sales 2017 connection is refreshed, Power BI is going to run through all of these applied steps. It's going to add an index column, change the type, move it to the beginning of the table, and then delete it, which is really inefficient and downright silly when you think about it. So rather than just calling it a day because I'm back at the correct table format, the proper approach here would be to actually remove all of those steps back to before I even added the index column in the first place. And now nothing's changed with my table preview. This is its original raw form, but now I only have 3 applied steps instead of 7. So kind of an important nuance to keep in mind there, and a good demonstration of how these applied steps are actually working. Now, last little demo, let's go ahead and add a conditional column right here above index. This opens up my dialog box, and we're going to name this column quantity type. And just like we talked about, we're going to say, okay, for every row in this table, if my order quantity equals a value of 1, then the output, or the value that my quantity type column should take, is single item. Just like that. Now I can press this button to add a new rule, and it gives me an else if line. So if this first row condition is not met, then what's the next thing you check for? Well, you check that order quantity is greater than 1, in which case my output, or my quantity type column, should equal multiple items. And you could keep adding conditions here if you had more complex scenarios. In this case, what we have here is a fully comprehensive and mutually exclusive list of conditions. We don't have any rows with an order quantity of 0, and I sure hope we don't have any rows with a quantity of negative values. So that just leaves us with 2 possible options. You've ordered one thing, or you've ordered more than one thing. But that said, as a best practice kind of rule of thumb, I always put an otherwise value in here. So let's just say, if something's crazy, we get some weird data that we weren't anticipating, we'll just set quantity type to other and press OK. And there you go. You've got our new column, quantity type. You can see that it's taking values of either multiple or single item based on this order quantity column. And if we look at our header dropdown, One thing to call out here, it does show that the only two items or the only two options in this column are multiple items and single item. You'll often see this little flag that says list may be incomplete. That's just telling you that Power BI looked at a small sample of rows within that column in order to produce the list above. And that's just to save memory and processing power. But if you want Power BI to check the entire column to make sure that this list is comprehensive, just press the Load More button. And that flag goes away, and this confirms that this quantity type column that we just created contains two values, multiple items and single item. So press OK, and that's just about all we need to do. So let's go ahead and enter our Home tab and press Close and Apply. All right, let's save our workbook and keep moving on. Next up, I want to talk about grouping and aggregating data. So within the Transform tab of the query editor, you'll see this Group By option on the left, and this allows you to aggregate or roll up your data at different levels of granularity. So some common examples of this would be doing something like transforming daily transactions into weekly or monthly, or rolling up transaction level data by store, by product brand, by region, etc. So it's taking a really deep, really detailed table and rolling it up into a higher level summary. So let's take a quick look at an example. I know it's a little bit tough to see, but what we've got here are order quantities by order date, product key, and customer key. And the important thing to note here is that we have multiple orders for a given product key. In this case, product number 214 has been ordered multiple times on multiple dates by multiple different customers. And if you wanted to transform this table into a summary of orders, of order quantities, rolled up by unique product keys, the Group By option is a great way to do that. So when you click that Group By button, you'll see a dialog box that looks something like this, that basically allow you to tell Power BI, I'd like to group this table by unique product keys, and the operation that I'd like to evaluate for those product keys is the sum of the order quantity column. In other words, you're taking all of these duplicate rows with the same product key and multiple order quantities, and you're compressing them down to one. When you do that compression or that aggregation, how do we want to treat those order quantity values? In this case, we're taking a simple sum, and we're ending up with a table like this. Two columns, one containing unique, distinct product keys, and the second containing the total quantity or the sum of order quantity values associated with each. So to recap, what we've done is essentially transform a daily transaction level table into a summary of total quantity rolled up by product keys. And important thing to note here, as you may have noticed, any fields that aren't specified in our Group By settings are lost. They're not preserved in that final table because we eliminated that level of granularity in the process. Now, one more example using the Advanced option. Consider the same exact table that we started with. We're using the same Group By option, but this time looking at the Advanced version. And really the only difference here between Basic and Advanced is that Advanced allows you to specify multiple columns or additional columns to group by. So this time, instead of just grouping by product key, we're grouping by product key and customer key. And again, we're evaluating that same operation, the sum of the order quantity values, just like before. This time what we end up with is a 3-column table: product key, customer key, and total quantity. So to recap, we've again transformed that daily transaction level table now into a summary of total quantity aggregated by both product key and customer key. In other words, we're now looking at quantities by each unique combination of those two fields. So the best comparison that I can make, if you're an Excel user, this is just like creating a pivot table and pulling in the sum of order quantity into your values and your product key and customer fields into your row labels. So that's grouping and aggregating data in a nutshell. Let's actually work through an example or two in Power BI. So back in Power BI, I'm in my AdventureWorks report. Instead of adding new data, I'm going to edit my queries to jump into the query editor, got my 4 connections, my 4 tables here. I'm going to dig into my AW Sales 2017 data, which contains daily sales records broken down by product keys, by customer keys, by territory keys. So this is a good candidate for using these grouping or aggregation tools. So just like our demo, let's go ahead and select the product key column. And let's say we want to turn this entire table, which contains multiple product keys and multiple instances of product keys, which we can see if we sort these. As you can see, multiple sales for product number 214, and so on and so forth for all of the other products in this table. There's a lot here, so we'll have to scroll quite a bit to get to them, but take my word for it, there are many, many more product IDs in here. So the idea is we want to take this table, collapse these rows with multiple product keys into essentially a summary table. And just like our example in the slide, let's evaluate the sum of order quantity for each of these product keys. So we can go ahead and transform, click group by. We're going to start with our basic option here, grouping by product key, the new column name, which is the column that contains the values that are getting aggregated or rolled up. We can call it whatever we want. Let's say total quantity, for example. And again, that operation, you have different statistical functions here, different aggregator functions. You could take the sum, you could average those order values, you could translate them all to a max or a min, you could count the rows. In this case, we want the sum, and we want the sum of that order quantity, and press OK. So just like our demo, this collapsed our data into a 2-column table with that new aggregated quantity field that we've named total quantity and a unique list of product keys. And I can test that they're unique by sorting them. And as you can see, there's only one instance of each of those IDs with the associated total quantity. Now let's do one more example. I'm just going to get back and remove those applied steps. And I want to do one more group by example with the advanced options instead. So let's select product key again, group by, click the advanced button, and now we can add a second grouping here for whatever other field we want to pull into this summary table. So in this case, maybe customer, maybe territory. I'm going to choose customer key here because I want to see the total sales for every combination of product and customer. And again, my column name could be something like total quantity, and it will be the sum of the order quantity. Press OK. And there you go. Very, very similar process here. It's now collapsed my table into a 3-column table containing unique combinations of product key and customer key. So there you have it. Once again, let's go ahead and remove those steps. We don't need the sort by product key. And then in fact, if we don't even want to save anything that we've done in here, we don't even need to go to the close and apply button. We can simply close out of that query editor. So there you go, grouping and aggregating data. Okay, so by this point, you should be pretty comfortable with the basic query editing tools, your date tools, your text tools, your number tools. And for the most part, they've all been pretty straightforward, pretty intuitive to use. But there are some pretty interesting, maybe not so intuitive tools available in the query editor as well. And one thing that I want to cover now is the idea of pivoting and unpivoting a table. So the way I describe it, pivoting is kind of just a fancy way to describe the process of turning distinct row values into columns, which is called pivoting, or turning columns into rows, which is called unpivoting. Now it sounds pretty simple, pretty straightforward on the surface, but it's actually a little bit tricky to get a hang of, at least it was for me. So I'm a visual learner, and what I'm about to show you is what finally caused it to click for me. So imagine this simple 2-column table. You've got years in the first column, and you've got a numerical field like unit sales in the second column. If we were to select the year column and pivot this table, we would essentially take the year in each row and turn it into its own column. So now instead of a row for 1994, we have a column for 1994. Same goes for 95, 96, 97, 98. So we've basically flipped that table from a vertical format up to a horizontal format. we've turned rows into columns. Now on the flip side, if we started out with the table in that horizontal format and we selected the years in the first row, we could unpivot to transform it into that vertical form. In other words, we take those years, which had been columns, and transform them into rows. So my little mental tip here is that I imagine that the table is kind of like on a hinge in that upper left corner. Pivoting is like rotating it up from vertical to horizontal, and unpivoting is like rotating it down from horizontal to vertical. Now, one thing to note, there's another tool in the query editor called transpose, and that works in a really similar way, but the difference is that it doesn't recognize unique values. So if you're dealing with a table like the one we're looking at here, where we don't have duplicate years or unit sales, pivoting and transposing would yield the exact same result. But if instead we had 2 rows of 1994, for instance, pivoting would collapse both of those rows into a single 1994 column, while transposing would preserve both versions and keep 2 separate columns, each with a 1994 header. So one way to think about it is that transpose is kind of clunkier, it's kind of brute force. It just takes the entire table and it just flips it on its side. So I actually have a little demo file that I'm going to show you, because you do have to really see this happening in real time to understand what's going on. So let me show you what that looks like. All right, so this file isn't available as part of the course resources, so just sit back and follow along for this one. I'm going to go ahead and grab my data as a CSV, and I've called this file unpivot demo. And I'm going to go ahead and open this up right here in the query editor. And right off the bat, you can tell this table is a little funky. There's some things wrong with this table. Number one, I don't have column headers, which is not that surprising. The column headers here are actually years. So when PowerBI took a look at the sample of this table, it said, okay, you've got numerical values in each column. I have no way of knowing if that's a year or if it's a similar value to the one in row 2 or 3. It's an easy fix. We can just go ahead and click use first row as headers. And there you go. Now our years have been promoted to headers. So we've made one improvement, but this table is still far from ideal. And what we have here is information about unit sales and revenue. We've got 2 different metrics broken down by year, 94, 95, each as columns. And as an analyst, as someone who needs to take this data and interpret it and analyze it and explore it, this type of table format can create a lot of headaches. Really what we're looking for here is a rectangular table with each dimension or metric as a column and each observation as a row. So ideally, what I want to transform this table into is a format that has 3 columns: year, sales, and revenue. That would give me a format that I could take and plug into my model and analyze in any way that I choose. So let's see if we can do that with our pivoting and unpivoting tools. Now, first things first, I don't like the fact that I have years in columns, so I want to turn these columns into rows. And to do that, I'm rotating down from horizontal to vertical or unpivoting. So what I can do is go ahead and select all of my year columns, go into transform, and then press this unpivot columns button. And there you go, it's transformed my year columns into year rows. It's labeled that column attribute, which is okay, we'll fix that later. And that hasn't totally solved my problem. I still have unit sales and total revenue as my rows instead of columns, but it's gotten me one step closer. And one thing to note before I move to the next step is that there's another way I could have done that. And let me just remove that step. And instead of selecting all 5 of these year columns, I could have selected this first column and chosen the unpivot other columns option. So you arrive at the exact same place, just another way to get there. So I've gotten a little bit closer. I've got values here, I've got years in a column. The only adjustment I need to make now is turn these unit sales and total revenue labels from rows into columns. So I need to do the reverse of what I just did and take this vertical orientation and pivot it up into a horizontal. So you guessed it, I'm going to select that first column, pivot the column, and this says, okay, where do your values live? Do they live in the attribute column or the value column? In this case, the value column. Press OK. And there you have it. So now we've got first column, which is attribute for year. We can go ahead and name that column year. We've got a unit sales column and a total revenue column. And this is a table format that I can work with as an analyst. So that was a great demo of how both pivot and unpivot can be used to kind of wrestle a messy table format into something more workable. Now, last quick demo here. If I take this all the way back to the start, just delete each of these steps, back to square one, because I'm not dealing with any duplicate values here, I could use transpose in this case as well. And in fact, that's actually a more efficient way to do this. I could select this entire table as is and essentially flip it or rotate it onto its side using that transpose option. So in the transform menu, I can just press transpose here, and that pretty much did the trick. It put years on a column, it put unit sales on a column, and it put revenue on the third column. The only thing we have to do now is use those first rows and promote the headers. And there you go. We've gotten to our same ending point using both combination of pivot and unpivot and transpose. So again, kind of tricky to work with at first, but these tools can be really, really helpful when you need them. So with that, I'm going to go ahead and delete that query that I just created. There we go. Close out of the editor. And there you have it, pivoting and unpivoting. All right, next on the agenda, we have merging queries. So you'll see the merge queries option in the home tab of the query editor. And when you click that button, it'll open up a dialog box like this, where you can select two tables and matching columns in order to create a merged table. And basically this works just like a VLOOKUP works in Excel. You're joining information from two different tables based on some common column or key. So in this example that we're looking at here, we're merging a table called AW sales data with another table called AW product lookup, both of which contain a matching product key column. So essentially what we'll be doing here is grabbing information or attributes about those product keys from the product lookup table and pulling them in or embedding them into our sales table by matching them to the associated product keys. So my trick for remembering this is that merging adds columns to an existing table. You're not adding any rows, you're pulling in more information and making your table wider by adding columns. So very important point here, just because you can merge tables and because it's an interesting tool to use, doesn't mean that you should. In fact, generally speaking, it's better to keep tables separate and define relationships between them within a data model. So more on that later, but keep that idea in the back of your head that you can merge queries like this, but it's not always the most efficient solution. So why don't we go ahead and jump into our query editor and I'll show you what one of these merges actually looks like. Okay, so I'm in the query editor of my AdventureWorks report, right where we left off. I've got my product table, customers calendar, and my sales 2017 data. Now to demo the idea of merging, let's say that we want to look at our sales data, which has our quantities and our keys for territory, customer, and product. And let's say I want to pull a little bit of information about these products right here into my sales table without having to look at a product key and find that associated product key here in the product lookup table and get my information that way. Let's say I just want that information accessible in one place. I want to pull those columns right in there to the sales 2017 table. That's a case where you could use a tool like merge. So I'm going to start by selecting the sales table. I'm in my home tab all the way on the right. You'll see these merge and append options. We're going to talk about append next. But within merge, I can do it two different ways. I can merge or merge as new. And if I just simply merge queries, it will preserve the exact tables that I have in place now. It will just add the merged columns into my existing AW Sales 2017 table. If I choose the second option, it's going to create a brand new merged table that contains the merged result while maintaining my original component tables as well. So I don't really need or want that option at this point. So I'm going to go with the first option, just merge queries. And what I see here is, all right, I've got my first table, the one I've selected, already populated here on the top half of the screen. And now it just says select a table and the matching columns to create this merge. So I can choose from one of my other queries or tables here. In this case, let's go with AW product lookup. Gives me a little preview here as well. And now the only column that actually matches here, if I look through these, is that product key column. So I'm going to go ahead and select product key in the product table, select it in the sales data, and I get this nice green check mark that says it's matched 29,481 out of the first 29,481 rows. So we've got a perfect match here, which is always good to see. So don't worry about the join kinds here. There are a few different options, different join types that you can choose from. The default left outer is typically the one you want. It's basically saying, take all the product keys that exist in my first table and grab any rows that find a match from my second table. And for our purposes, that will do the trick. So let's press OK. And you see what happens here? It added a column, but the column looks kind of funny. It says table, and it's formatted with these links. So there's one extra step we have to take here, which is to click this button here that actually expands the table out and converts it into the actual columns that I want. So by default, it selects all of the columns from the product table. If I pressed OK, it would pull in all 10 or 12 of these columns into my sales table. In this case, I don't want all of them. Let's just pull in the product key so that we can make sure we have a match, and maybe the product name and the color. And this last checkbox here just determines what the name of the column is going to look like. If I leave this selected, it's going to create a prefix for every column with the name of the product table, which for the sake of this example, that's fine. So when we press OK, it basically expands that temporary table column into the 3 columns that I had selected from the list, the product key, and again, it's got that prefix of the table name, the product name, and the product color. So if we scroll to our original product keys, we've got product 529, 214, scrolling to the right, 529, 214, you can see that it matched. And now we have this new information that hadn't existed in the sales table up to this point about the product name and about the product color. And this populated for every single row in our table, just like a VLOOKUP would have in Excel. So like I hinted at earlier, just because we can do things like this and merge our tables together doesn't mean we always should. In fact, merging information in the way that we just did actually creates a lot of duplicative and redundant data, which can be avoided entirely using table relationships instead. So again, we're getting there soon, but for now, let's go ahead and delete that merge that we just did, and we're back to where we started. So there's a quick demo for how to merge queries. All right, next up we've got appending queries, and you'll find that append queries tool right under merge in the home tab of the query editor. When you click that button, you'll see a really simple dialog box like this, where you can choose to append either 2 tables or 3 or more. Now both merging and appending are similar in that they're adding information to an existing table, but they're different in that merging is adding columns and appending is stacking rows. So basically, appending queries allows you to combine or stack 2 tables, assuming they share the exact same column structure and data types. So keep that in mind, same structure, same data types. So in this case that we're looking at here, we're appending 2 tables together. They're 2 different AdventureWorks sales tables, one from 2015, one from 2016, and it's a valid append since they both share identical table structures. So just like we talked about, merging makes tables wider by adding more columns. Appending makes tables taller by adding more rows. Now, pro tip here that I want to share with you, which we'll actually dive into with the demo in the next lecture, is to use the folder option from the Get Data menu. And what that lets you do is actually point Power BI to a folder containing as many files as you choose, which allows you to append all of them at once, assuming they share that same structure. And the beauty of it is that over time, If you add new files or remove files, simply refreshing that query, that connection, will automatically append any new data that's shown up within that folder. So it's a really powerful option that we'll dive into in the next video. But for now, let's cover the basic append option and shift gears into Power BI so we can take a look. Okay, so I'm here in the query editor. I'm inside of my AW Sales 2017 table. And because I've got 4 different tables here, each with a different column structure, there's nothing that I can really use to append with what I've got on hand. So I know that I'm going to need to grab some new data. We can do that right from the editor by clicking New Source, Text CSV, and I want to grab my other 2 AdventureWorks sales files. So let's grab 2016 first. Let's see the preview, and we can press OK to load straight into the editor. And why don't we update the table name while we're thinking of it, AW Sales 2016, and we'll repeat that process, New Source CSV, for the 2015 file. Press OK from the preview, AW Sales 2015. Okay, so now we've got 3 separate AW Sales files, all of which are consistent in terms of the columns. There's 2015, 2016, with one exception in 2017, which is that new quantity type column that we added when we practiced that conditional column tool. So one option would be to go ahead and continue to append these together. You'll see some null values for the quantity types in the other 2 tables, and you could pretty easily redefine that conditional column to the full appended version. In this case, we're not going to be using this column for anything, so let's go ahead and just remove it. There we go. And now we've got a perfectly consistent table structure across all 3. So now with one of them selected, it doesn't matter which one, I'm going to start with 2017. In my Home tab, let's go to Append Queries. And this time, instead of the first option, we've got that same choice that we had with Merge, where we can either append within the existing table or as a brand new table. This time, let's try the new table. So when I click that button, this time we have more than 2 tables to append. We have 3 or more, and it's automatically populated the first one that I've selected. So the only other 2 that I need are Sales 2016 and Sales 2015. So we can go ahead and press OK, and it creates a new table. It names it Append 1 by default. Let's go ahead and change that to something like AW underscore sales underscore 2015 through 2017, just to be clear. And now we can look through the column structures, look exactly as we'd expect. Same column structure as each component table. And now when we sort these order dates, let's sort them ascending. We see that the table now starts on January 1st, 2015. And if we expand and load more to see the full list, we can actually scroll all the way down and see that it takes us all the way to the end of June 2017 with 2016 dates in between. So we've got dates from all 3 of those sales tables. So that's great. We've successfully appended the sales data from our 3 individual tables into one appended version. But one downside of this approach is that now that I've got the table that I want with all of the data in one place, let's say I want to get rid of these older individual tables just because they're taking up space. If I right click and try to delete the 2015 query, it won't let me because it's being referenced by another query that appended 25 through 2017 table that we just created. So the problem here is that our new table, our 2015 through 2017 table, is dependent on the other 3. So we have to kind of keep all 4 of them here, which is okay. There's nothing wrong with that. It's not going to create any big problems. It just feels a little bit messy. So one way around that, which I very much recommend, is to move these files into a folder and then connect to the folder itself. So stay tuned because in the next video, I'm going to show you exactly how to do that. All right, so I just showed you how to stack some tables together using the query editing append tools. We took these three individual AdventureWorks sales files from 2015, 16, and 17, and we appended them as a new table called AW Sales 2015 through 2017, which included all of the data across all three files. And that worked pretty well, but remember the downside. This new table that we created is now dependent on the three individual component tables. So we can't delete any of these individual tables. We have to keep this whole set of four. So let's actually scrap these four sales files and pull them into Power BI using the folder approach instead. So I can delete the appended file first and press OK. And once that one's gone, now I can delete any of these individual ones because no relationship between them exists and there are no more dependencies that we need to worry about. So 2017, delete. There we go. So all of our sales data is gone. We're left with just the product lookup, the customer lookup, and the calendar lookup. And what I'm actually going to do here is pull up the folder on my desktop containing these individual CSV files and create a new folder there. So go ahead and pull up your folder as well. Okay, so here's where I've got all of my AdventureWorks CSV files, including the three individual sales files. What I'm going to do is actually right-click and create a new folder right here within this same AdventureWorks folder. And I'm going to name it something like AW_sales. You can name it whatever you want. And then once I've created that empty folder, I'm going to select each of my sales tables, 2015, 16, and 17. I'm going to drag them all into that AW sales folder. Now when you click in, you can see that it contains all three of those files. And once I've done that, I can go ahead and close that file window, return back to my query editor, and I'm going to go ahead and grab a connection to a new source. And this time I need to go down into the More options. And right here on the right, you'll see the option to connect to a folder. So let's go ahead and connect. And the first thing that Power BI is going to ask for is the folder path. So let's go ahead and browse and navigate to those course files, Power BI course files, AdventureWorks, AW sales. So that's the folder that I just created that contains those three individual sales files. And I can go ahead and press OK and OK once more. Now the preview window looks a little bit different. It has this column that says content binary. It's got file names and extensions. So rather than actually previewing the data, the actual rows and columns, it's previewing the files that exist within this folder path. Now we have two options here. We can either combine and edit on the spot, or we can edit and actually walk through each of the steps of the combination. So I'm actually going to choose the edit option because I want to show you exactly what this looks like bit by bit. So there we go. When I press edit, it lands me here in the query editor, and I see that similar kind of view that I got in the preview, right? I'm not looking at actual data points. I'm looking at attributes about the files that exist in the folder that I've linked to. So the key here is to look at this first column. This is kind of similar to the column that was created when we merged tables, where we had to take one extra step to actually split out the columns from the table itself. Same idea here. We have to take one extra step to break out the actual content within these CSV files located in the folder. And to do that, we'll just press this Combine Files button right here in the Content column header. And when we do that, it runs through the append process and opens up a new preview window with a Combine Files header. And this shows us an actual data preview from each of our files. We can select the first, the second, or the third here. And if our preview looks good, if we know we've got the same column structure, data types, which we know we do, then we can go ahead and press OK. And after it runs through some processing, you'll see that the data lands right here in the preview window and contains data from all three of our files. So same thing, we can filter on that order date, show more, we're starting in January 2015, and our dates extend all the way through 2016 through the end of June 2017. So we've got all of our data in here, got all of our familiar columns out to the order quantity column. We do have one additional column here, which is the source name, and that just tells us which file within the folder that data came from. So kind of a helpful attribute if you do want to keep it. In this case, we don't need it. So let's go ahead and remove that source name column. And there you have it. We have our appended table containing all of our sales data in one place. And as you can see, it automatically gave us a table name based on the way we named our folder, which in this case was AW_sales. We can either leave it just like that or add the years to that, 2015 through 2017. In this case, I think this is the final version of the sales table that I'm going to use. So in this case, AW sales, it's nice, it's clean, it's concise. That'll work just fine. So last thing to note, over here on the left side of the screen, you'll see that AW sales table showed up right beneath our calendar lookup. You'll also see some automatically generated query information above that. And this was all automatically written, automatically generated in order to make all that magic happen by appending the files within the folder. So we don't even have to touch this. We don't even have to think about this. I usually will just kind of collapse it. And then in this other queries folder, this is where all of our kind of primary tables will continue to live. So again, same end result as loading up 3 individual tables and using the append tools from the home menu, except now we have one nice clean table without those extra tables and dependencies. And even more importantly, if we ever needed to pull in additional years of sales data, we could simply drop those CSV folders right into that AW sales folder and press refresh right here inside the query editor, and all of that data would automatically be pulled in. So that should just about do it. Last step is to close and apply. And that'll go ahead and load that new AW sales data to our file. And let's take a look at relationships. There it is, AW sales. So with that, there's your pro tip, connecting Power BI to a folder of files. Okay, so up to this point, we've talked about a number of the most important data transformation tools in the query editor. Next up, to round out the section, I want to cover some important settings and options. And the first topic is data source settings. So in the home tab of the query editor, you'll see this option for data source settings. And that basically just allows you to view and manage all of the individual connections in your Power BI file. So in this example that we're looking at here, we've got connections to a number of individual CSV files, as well as a folder down there at the bottom of the list. Now, the critical concept to understand about data source settings is that when you make a connection to a local file, a file that's located on your computer, Power BI will basically take a snapshot of that exact file path to that exact file name. And what that means is that if anything changes about your file, if you rename it or if you move it to a new location, that path won't automatically update. So what you need to do is go into these data source settings, click Change Source, and browse to the revised version of that file. So this is probably the most common issue that I see in Power BI. People inadvertently rename a file or rearrange things on their desktop and accidentally break these file paths. But the good news is that it's a very easy fix as soon as you understand how these data source settings work. So let me show you what I mean. So I'm here in the AdventureWorks report. I've got my 4 tables at this point, including that AW sales table that's now linked to the folder that we created in the last video. And you can either follow along with me here, or you can just watch, because we're not actually going to be adding new data or revising anything that we have. I'm just going to show you a demo of what happens when a file path does break in the way that we talked about. So I'm going to edit queries to open up the editor. And as you can see, all 4 of my tables look good. And when I drill into the data source settings button right here in the home tab, I can see these 4 connections in place, my 3 individual CSV files, calendar, customers, products, and then that folder that we just created. So everything looks good, everything's running smoothly. But now what if I accidentally changed one of those file names? So let me navigate to my actual source folder on my desktop. There we go. Here are my AdventureWorks CSV files that I'm pointing to. And as you can see from my query list, one of those files is the products file. So let's say I accidentally rename this file products2 or something similar. Now when I minimize this window and return back to the query editor, when I click the product lookup query and click this refresh preview tab, as you can see, I get this error that says we couldn't find the file. And if you read closely, you'll see why. It's because it's looking for the file with its original file name and location, AdventureWorks_products, not products2. So the issue goes all the way back to the very first step, which is the source. And again, it's because Power BI recorded or locked in the exact file path when I first created that connection. So I have two options to fix this here. Option one is simply to rename that file and remove the 2 that I added at the end. Option two is to drill into my data source settings, find the trouble spot, in this case the products line, click change source, and simply browse to the updated version, which lives right here, AdventureWorks Products 2, press open and OK. And now when I close this data source settings window, go back to product lookup and refresh once more, now we're back to usual. So the source populated properly, all of those applied steps are maintained, we didn't lose any information, and we're back right where we started. So pretty simple fix. We could leave things just like they are, or to kind of show you the same process in reverse, what I'm going to do is change that file name back to its original form. So I'll go to my desktop folder and then simply remove that 2 at the end of the file name, close that window, go into data source settings, products 2, change the source, and again browse back to the original named AdventureWorks_products. Press OK, close out the settings window, and if I refresh, there we go. Everything looks good. So we haven't actually made any changes, but hopefully that was a helpful demo for how to address those data source errors using the data source settings options. Next up, I want to take just a second to talk about refreshing queries. Now, in the Home tab of your Power BI file, outside of the query editor, you'll see this refresh button across all of your views. And by default, when you press that button, it's going to refresh every single query, every connection, every table that exists in your model by default. But you can customize these refresh options. So within the query editor, in that queries pane, you can actually right-click any one of your individual connections or tables, and you can simply deselect or uncheck that box that says Include in Report Refresh. And as you might expect, that prevents that file from refreshing whenever you hit that refresh command from the Home tab. So, helpful pro tip here, what you can do is exclude all of your queries that don't change often or don't change at all, like your lookup tables or any static data tables that you might have. So let's go ahead and open up the query editor and make some of these adjustments ourselves. All right, so here I am back in my query editor. I see my 4 queries or connections here. And when I right click each one of these, you'll see that Include in Report Refresh line, and I see a checkbox, which means that each one of these tables, product, customer, calendar, and sales, will all refresh with the report. And in fact, if I just go back to my relationships view here and press refresh, you'll see all 4 of these tables are evaluating, processing, refreshing. So essentially Power BI is going to those source paths and refreshing the data in the CSV, even if nothing has changed. So there you go, it's just refreshed all 4 tables. Now let's hop back into the query editor. And what I want to do here is actually prevent my 3 lookup tables from refreshing when I hit that command. Because at least for the time being, I'm not going to be adding information about products, about customers. I won't need to add more dates to my calendar. But just for the sake of example, let's keep AW sales as is. So let's allow the sales data to refresh. So I can simply right click and click that include in report refresh option, which just deselected it. I'm going to do the same thing for customer and the same thing for calendar. And now when I close and apply and press refresh again, only that AW sales table was loaded. And you see that it worked a lot more quickly that time. That's because we're not refreshing 3 queries that aren't including any more data. It's just redundant, it's a little bit inefficient and slow. So again, good rule of thumb, if you have data that's static, if you have tables that aren't going to be changing, go ahead and exclude those from the report refresh and only refresh the ones that may be changing over time. So we've already seen some options for formatting or changing data types within the query editor. We've formatted columns as dates, as whole numbers, as currency and decimals. But there are some additional options that we'll find outside of the query editor in the data view, specifically the modeling tab, that will help us not only define more specific data formats, like specific date or currency types, but also categories. And many of these categories that you see here are geographical in nature. They capture things like addresses, cities, latitudes, longitudes, etc. The purpose here is that categorizing your data in this way, especially geospatial data, helps Power BI accurately map and visualize those location-based fields, those things like addresses, countries, continents, zip codes, etc. So let's head back to our AdventureWorks report, and I'm going to show you a couple examples of how we can do this. All right, this is one that you're going to need to follow along closely with because we're going to be modifying some of our data formats and adding a new table or a new connection to our file. So first and foremost, let's head to our data view, which we haven't really spent much time here yet. And within this view, you can see previews of your tables. Here are my 4 tables on the right side of the screen. You can drill into different individual fields as well. Now, looking at the calendar table, you'll note that the dates have defaulted to this long form format. And there's nothing wrong with that. It's still correct. I would just prefer a shorter, more concise format. So when I select the column, these formatting options within my modeling tab now become available. So the data type is set to a date, which was established within the query editor, but now I have more specific formatting options. So under the date time menu, I actually like this first option, month, day, year. This is kind of the classic standard English US format. So I'll just click that and it will refresh and basically overwrite that long form and format it in that new kind of shorter form date format. I'm going to go ahead and do the exact same thing to my start of week column as well, start of month, and start of year. So that just kind of cleaned things up a little bit. I also have a date field in my sales table. In fact, I have 2 date fields, the order date and the stock date. So let's go ahead and just select each one of these and format in that same short form date. And now one other adjustment with the data that we already have. If we jump into our product lookup table and scroll to the right, remember we hadn't really been able to format those currencies exactly how we wanted to in the query editor. So same idea here. We've got the data type, decimal number. We can actually format as a specific type of currency. So many more options here than we had within the query editor itself. So I'm going to choose the dollar sign in English format. And there you go. Repeat the process for product price and then for discount price as well. There we go. Now these are nice and clean, properly formatted US currency fields. Now, last item I want to address here is this data category field. And this is what I showed you in that slide with those geospatial fields. You've got other kind of categorizations like web URL, even barcodes and image URLs. So to show you how that works, I actually want to connect to a new table. So you can go to Home, Get Data, Text CSV. And this time the field that I want, the table that I want, is AdventureWorks Territories. So I'll double click, Fire up the preview pane. Default looks good. Edit it in the query editor. And as you can see, pretty simple table here, only about 10 rows. We've got sales territory keys, and each key is associated with a given region, country, and continent. So this is going to help us understand for those sales in our AW sales data, where are they coming from? What countries, what regions, which continents are driving the most sales? And help us kind of answer questions like that. So first things first, you know the drill. Let's change this table name to AW underscore territories. And you guessed it, this is a lookup table. So AW territories lookup, press enter. We've got proper headers. Our key is a whole number, everything else is text, so that looks good. Go ahead and close and apply. And now as you can see, we've got this new table that's popped up here at the bottom of our field list in the data view. And just to save space, I'm going to collapse these other tables and drill into that territory lookup. And there you go, that looks nice and familiar. So last step here, we will want to visualize some of this data using the map tools and visualizations, which are really, really handy in the report view. So to make sure that Power BI is visualizing things properly, let's go ahead and use those categorization options in the modeling tab. So we'll start with country, select the column, and under the data category dropdown, be careful you don't click county because that's different from country. I've made that mistake before. You want country/region. And then for continent, you've got a continent option as well. And because these regions are kind of custom defined, Northwest, Germany, UK, they don't really follow a standardized mapping syntax. We're okay with just categorizing country and continent for now. And important note here, Power BI will almost always recognize these fields properly by default, automatically. So had we not gone through this step and just plugged these countries into a map visual, 99.9% of the time it's going to work exactly as you'd expect and you'd get accurate results. But as a best practice, it really couldn't hurt to explicitly define what types of data categories you're working with. And last thing to note here, see these little icons to the left of the fields? You'll see a bunch of different types, and we'll talk about what these mean. But the two little globe icons indicate that these have been categorized as geographical fields. So a nice little helpful visual cue there. So let's return to our relationships view. See that territories table object pop up. Now we've got 5 connections here in our report. Let's go ahead and give it a save and keep cruising ahead. Next up, I want to touch upon one other option available in the Data tab of Power BI, which is the ability to define hierarchies. Now, hierarchies are essentially groups of columns that you nest underneath each other to reflect multiple levels of granularity or detail. So for example, a common type of hierarchy is a geographical one, and that might include columns like country, followed by state, followed by city. And note that they become more granular, more specific and detailed with each level of the hierarchy. So what's nice about these is that they can actually be treated as a single item in your tables and reports so that users can view the data at the highest level and then drill up or drill down through the different levels of detail in a meaningful way. So one example here is creating a hierarchy with date fields. So what you'd actually do in the data view is drill into your calendar table and you'd right click a field, in this case start of year, and select the new hierarchy option from the menu. Now what that does is it creates a brand new field. It doesn't overwrite the existing ones, it creates a brand new one that now contains start of year. And I'll show you what this looks like, but it shows you a very clear icon that indicates this isn't just a regular field, this is a hierarchy that we're dealing with. So then from there, right click any other fields that you'd like to add, like start of month or start of week or date, for instance. And instead of clicking new hierarchy, you're going to click add to hierarchy and select the date hierarchy or whatever you've named it that has already been created. So this is the method to actually build one of these hierarchies within the data view. So one thing to note here is that I know I'm showing you a hierarchy example with date fields specifically, but Power BI is actually very, very smart about dates. And in fact, it will create a lot of date related hierarchies for you automatically without having to manually create a set like you see here. But there are other examples where that's not the case, where Power BI won't automatically recognize fields in a hierarchical way, in which case building a set like this is very helpful. So I'm going to show you an example of that right now. Let's head back to our AdventureWorks report, and I'll show you what I mean. All right, so once you've opened up your AdventureWorks report file, you should see the 5 table connections that we have in place. Let's jump into the data view. And for the sake of example here, we're going to create a very simple hierarchy using these territory fields. And this is a good candidate to use here because we've got 3 different fields kind of in descending order of detail or granularity. Continent is the broadest category, followed by country, followed by region. So let's go ahead and start with continent, right click, create new hierarchy. As you can see, it maintains or preserves that original continent field and adds this new line item with this little icon that indicates that there are subfields within it. In other words, this is a hierarchy, and it's named it by default continent hierarchy since that was the field that I had originally selected. So you can right click and rename it, and I'm going to call it something like, oops, kind of in the way there, something like territory hierarchy. Okay, so it shifted things around since it's alphabetical order here, and put that territory hierarchy there at the bottom. So the 2 other fields that I want to add to this are country and region. So I can select country, right click, and add it to that territory hierarchy. Same goes with region, right click, add. Now it's just nested each of those fields under continent and created this hierarchy containing 3 different levels. If you added them in the incorrect order, like continent, region, country, you can simply click and drag to reorder them around. So now to recap, once we get into the report view and start visualizing things, building charts and graphs, instead of pulling in 3 individual fields for continent, country, and region, we could pull this single hierarchy object into the visual and allow users to drill up or down to these different levels of detail. So a really interesting tool, great way to add more depth to a Power BI report. All right, time to share one of my favorite pro tips, importing entire models directly from Excel. So in Power BI, we've got this import menu that we haven't really talked about with the option to import Excel workbook contents. And note, this is different from using the get data option and pointing to an Excel workbook. This is actually importing additional information about an entire model from Excel into Power BI. So what's incredibly helpful about this is that this import process preserves just about all of the information about your model. It transitions information about the data source connections and queries that are in place, all the file paths. It maintains the query editing procedures, all of the applied steps, the data modeling details like the relationships, hierarchies, field settings and formats, etc. And then last but not least, all of the calculated columns and calculated DAX measures that you've added to your model in Excel. So quick pro tip here, Power Pivot in Excel does actually include some features, some really helpful features that Power BI does not. So some additional filtering options, a little bit more of a user-friendly DAX interface, for example. But the fact is, if you're more comfortable building models in the Excel environment, which is covered in my Power Query, Power Pivot, and DAX course, then go ahead and continue to build there within that environment, and then import those models into Power BI for the reporting and visualization phase. You'll end up at the exact same place. It's really just which environment you're more comfortable in. So sit back, relax for a minute, just watch this demo. I'm going to show you what this looks like when you actually import a full data model from Excel into Power BI. All right, so I actually want to start in Excel for this one. This is my Food Mart data model complete file, which is probably bringing back some flashbacks to students who were in my last course. And basically we've got a data model here with a bunch of lookup and data tables. Got a diagram view, which, there we go, should show us all of the relationships in place, got parameters and disconnected tables as well. So it's a pretty robust model. And on top of that, if I manage my measures, we've got all of these DAX measures that we created, which would be a huge headache to have to recreate from scratch in Power BI. Luckily, I won't have to. Now, one thing to note here, I also have these additional pivot tabs with things like conditional formatting and data bars and icon sets. Now, there is no equivalent pivot view quite like this in Power BI. There's a matrix visual that's similar but not quite the same. So these views, these actual pivots, these additional tabs will not transfer over. So I just want to caveat that. So from here, I'm going to open up a blank, brand new Power BI file so that I can import this model directly into it. So here we go, blank file, untitled. And now again, instead of going to get data from Excel, I'm going to choose this top left main menu and import Excel workbook contents. Big difference here. And when I do that, I can navigate to my FoodMart data model complete file. It gives me this little note that says, hey, we don't work directly with Excel workbooks, but what we can do is extract the content so that you can use it right here in Power BI Desktop. And so I read this, I'm like, all right, that sounds great. Let's go ahead and start the process. And we get an error, which is pretty straightforward. It says, oh, we can't do it right now because your model is open in Excel. So easy fix. Let's go ahead and close the Excel version. Don't need to save any changes. And let's go ahead and retry that. There we go. So now it says, okay, we've got some tables that exist in that original workbook. In other words, they were created with actual cell ranges in Excel. And it just says, do you want to copy the data and create a version right here in the Power BI desktop environment, or keep this remote connection back to the Excel workbook, which sounds like kind of a nightmare. So I'm going to say, let's take the data from that price threshold and age threshold table, and let's copy it so that it exists here as well. And now it runs through all these fancy things. That was real time. That was about, I don't know, 5 or 10 seconds. And check it out. It's migrated all of these items, different queries, different data model tables, all these KPIs and measures. And when we press close, obviously there's nothing in our report view because there's no equivalent to the report view in Excel. But if we go to data, check it out. All of our tables exist here. All of our fields, including all of these calculated measures. I think there's a bunch here in my transactions table. Yeah, they've all carried through all of our measures. In the relationships view, we can see that our data model with all of its table relationships is still intact. It got a little bit scrambled, so it doesn't look quite as nice and clean, but we can go ahead and just rearrange things as we see fit. So some of these details aren't really going to make sense quite yet until we dive into the data modeling and the DAX sections of the course, but I wanted to just give you a little preview and let you know that there is this option to pull a fully baked model from Excel straight into Power BI. All right, everyone, time to take this section to the finish line with some best practices for connecting and shaping data. Now, number one, get yourself organized before even loading any data into Power BI. So I've said it before and I'll say it again, defining those clear and intuitive table names right from the start will save you a ton of time in the future. Updating table names can be a big headache down the road, especially if you've already referenced them in multiple places, like DAX measures. One other side note here, I'd recommend not using spaces in your table names. If you do, it just means you've got to surround that table reference with single quotes every time that you reference them. Now, second, highly recommend establishing a clear and organized file and folder structure that makes sense from the start. This will help you avoid having to go in and modify your data source settings anytime those file names or locations change. Number two, I'd recommend disabling report refresh for any static sources in your model. And at the end of the day, there's no need to constantly refresh those sources that don't update frequently, or in some cases at all, like lookups or static data tables. So you really only need to enable refresh for tables that you expect to change over time. And last but not least, when you're working with larger tables or models, only load up the data that you need. So there's no point including hourly data when you only need daily, or product level sales or transactions when you only care about performance at the store level. So keep in mind, this can be changed over time. Nothing's set in stone, but at the end of the day, extra data is only going to slow you down. So there you have it. We've officially wrapped up our entire section on connecting and shaping data, which is the first major phase of the business intelligence workflow. So congratulations, but keep in mind that we're really just getting started and we've got some great stuff ahead. Next up, we'll shift gears into creating table relationships and building custom models within Power BI. Stay tuned. All right, time for the homework solution walkthrough for the connecting and shaping data assignment. Now, important comment here, if you didn't complete the homework, I'd highly recommend that you go back and do so, or at the very least, follow along closely with the solution that I'm about to walk you through, because we're actually going to be adding new fields and new tables that will be critical for the rest of the course. So with that, let's get started. Question 1 asks us to create 2 new queries to the product categories and product subcategories CSV files from the course resources. Then once we load those, we're going to name them consistently with our other tables, AW product category lookup and AW product subcategory lookup, and go through and make sure that the headers look good and the data types are correct. So let's go ahead and start with the category file. I'm going to get data from a CSV, and I'm going to find AdventureWorks product categories, and that's the one I'm going to start with here. I'm going to edit to launch the query editor. I'm going to change this one a bit to AW product category underscore lookup. Again, just for consistency with all of our other table names. Press enter. Looks like my headers have been promoted properly. I've got a key, which is a whole number, consistent with my other tables. That looks good. And I've got a category name as a text field. So I'm good to go with this table. And from right here within the query editor, I'm going to grab my second table, which is the subcategories table. Okay. And same idea here. AW product subcategory lookup. Pretty simple, pretty small table. Headers are promoted. I've got my key as a whole number, which looks good. I've got my subcategory name, mountain bikes, road bikes, etc. That looks good as a text field. And I've got an additional key here, also formatted as a whole number for product category. So all looks good here as well. I can check that box. And now the last thing I need to do for question 1 is disable report refresh for both of these new connections. So product subcategory, just deselect that report refresh. Same with category. And now I'll just double check both of these. Should not refresh when we use that command from the Power BI file. So there you have it. Question 1 is complete. Moving on to question 2, we need to make some modifications to the AW product lookup table. And the first thing we need to do is add a calculated column that extracts characters before the dash in the product SKU column. So this is our product SKU column. You can see we've got some text characters, dash, some numbers, another dash. And essentially what we want to do is create a calculated column. We want to name it SKU type, and the value that we want that new column to take would be the characters before that first dash. So to do that, we're going to add a column, and from our text tools, we're going to extract text before a delimiter, and that delimiter is the dash. So we can press OK. And as you can see, it added that field. It extracted the 2 characters before the dash. You can go ahead and double click the column header and name that SKU type. And there you have it. Now the next question actually asks us to modify that calculation that we just made. Now we want to pull all of the characters before the second dash. So to do that, let's go back to that step, press the gear to edit it. And we're going to go into our advanced options. And we're still going to start from the left, or the start of the input, but we're going to skip that first delimiter, that first instance of the dash. And we press OK. We can go ahead and scroll back to that calculated column. And now it contains those first characters, as well as the first dash, and those characters before the second. So we can go ahead and click through to keep that renamed column step. And now we've got that updated SKU type column, which pulls in all of the text from that product SKU column before the second dash. Next up, we need to replace zeros in the product style column. So here's our product style column. Let's see what we're working with here. We've got the zeros, and then we've got M for men, U for unisex, W for women's. So just check that out, press OK. Now what we want to do here is not add a column, but transform this existing one. And we're going to use the replace values option and simply find the 0 and replace it with NA. Press OK. You can see those swap in. And when we drill back in, now we have same 4 values except that the 0 has been replaced by that NA. Now the final part of question 2 is to update the discount price calculation from 10% to 15%, which means we'll need to multiply that product price value by 0.85 instead of 0.9. So let's jump back to the step where we calculated that discount price, which is this step right here, inserted multiplication. We can press the gear icon, and all we need to do is update that 0.9 to 0.85 and press OK. And there you go, it's updated the raw values here. And now we can click through the additional steps. You don't have to do it one by one, but I kind of like to see the history and take us to the end. So now we've updated that discount price column from 90% to 85. And that wraps up question 2. So now moving to question 3, we're going to practice using those statistics tools in the transform menu. So there are a few values that we need to validate here. First one is the average product cost. So we can stay right here in our product lookup table, select the product cost column, make sure we're in the transform menu, go into our statistics tools, and select average. That returns a value of $413.66, which checks out. And now for each of these transformation steps, I'm just going to end up deselecting that step to take me back to where I started. And let's move on to the next one. So number of distinct product colors. Let's scroll through. Here's our product color category, and we want the count distinct from this column. So transform, statistics. Note that we only have our 2 count options because this is a text field. And we want count distinct. That gives us 10. So we've got 10 different distinct product colors that we're dealing with here. Next up, we need the number of distinct customer names, which means we need to move to our customer lookup table. And let's go ahead and find that full name column that we had created. Here it is, full name, transform, statistics, count distinct, 18,110 distinct customer names in our lookup table. So that one checks out as well. And then we've got a couple more, maximum annual customer income. Here's our annual income column, transform, statistics, maximum. That translates to $170,000, which is correct. And then 2 more, we need the count of order numbers and the count of distinct order numbers. So for those, we need to go into our sales table. And we've got our order number column right here. And you guessed it, transform, statistics, count values. Got 56,046. And if we undo, select order number again, transform, statistics, count distinct, we get 25,164. So the difference there means that there are duplicate values in the order number column, which might seem weird at first because we feel like one row should represent each order. The difference is that we have this order line item column. So there may be a single order with multiple line items, in which case one order ID might show up twice with an order line item of 1 in the first row and 2 in the second. Okay, so that's all of question 3. We validated all of those numbers. Now let's move on to question 4, which is making a few modifications back in that customer lookup table. So number 1, we need to add a new calculated column for the year of birth. We're going to name it birth year based on the birth date column. So here's birth date, add a new column. We use the date tools for this one. And all we want to do is just extract the year out of that birth date. And there you go. All we need to do is double click, rename that column header to birth year. Simple enough. Now, last but not least, we're going to practice a conditional column. And what we're looking to do here is create a new column named income level based on criteria from the customer income column. So let's go ahead and select that income column. There it is. We're going to add a column. We're going to add a conditional column. And the column will be named income level. So we can start there. And then we're checking conditions against that annual income column. So the first criteria is if that annual income is greater than or equal to $150,000, then the output, the value that we want our new income level field to take, is very high. Now, if this condition is not met, what's the next condition that we want to test for? So the next condition, the else if condition, is if annual income is greater than or equal to 100,000, in which case income level equals high. And then the third condition is if annual income is greater than or equal to 50,000, then the income level equals average. And then we don't have to add another explicit condition for less than 50 because that's kind of the only other option here. So we can go ahead and account for that condition here in the otherwise statement and say if none of these conditions are met, if a customer in a given row didn't make more than 150,000, they didn't make more than 100, and they didn't make more than 50, then the label that we want to assign them is an income level of low. And that should just about do it. Let's press OK. There we go. It added that new column called income level. And if we drill into the header, load more, as you can see, we've got values populating throughout the whole range: low, average, high, and very high. So there you go. That's all the table transformations and modifications that we need to make. All of the edits that we just made in one go can be applied by going to the Home tab, close and apply. It's going to go ahead and factor in everything we've just done. And you'll see two new tables pop up in your relationship view: product category, product subcategory. You'll also find them in the fields list, category and subcategory here in the data view. And then if we drill into our customer table, you'll see that calculated income level field that we just created in the query editor. So that wraps up the homework assignment. Hopefully you were able to follow along. I'd recommend that you go ahead and save a backup version of this report somewhere else on your machine, just to have on hand in case anything happens. But with that, we're ready to move on to the next section. All right, great work so far. We've got all of our source data connected and loaded into Power BI. The goal of this next phase is to create table relationships so that we can blend all of this information together within a single normalized data model. We've got a lot to cover, so let's get started. All right, so to kick off this entire section about creating data models, I figured it would only be appropriate to start with a simple question. What exactly is a data model? Now consider a relationships view that looks like this. We've got three different tables here: a product lookup table and two data tables, sales and returns. This alone is not a data model. What we're looking at here is a collection of independent tables which share no connections or relationships. So think of each of these tables as its own little island with no idea that the other two even exist in the model. And what that means is that if you were to try to do something like this, breaking down a field from the sales data, like order quantity, or a field from the returns table, like return quantity, and break those quantities down by a field from the product lookup table, you're going to get the same grand total in every single row of the table. And again, that's because both the sales and the returns data tables have no idea that there even is a product lookup table that exists in the universe, let alone how to break down those quantity values by individual product names. So if this is not a data model, then what is? Well, let's consider that same structure, that same relationships view, except now we have relationships connecting the tables together. This is a data model. And again, it's a data model because the tables are now connected via relationships based on a common field or key, which in this case is the product key column. And without diving into the specifics just yet, what this means is that if we revisit that same analysis, looking at order quantity and return quantity by product names, now we see the correct values, because now the sales data table knows that the product lookup table exists. In fact, it's connected to that product table based on the fact that they share a common product key. And the same story holds for the returns data and its relationship to the product lookup. So as a result, we're able to take any field from the product lookup table and filter and segment values from those two data tables. Now you'll see that same familiar grand total row at the bottom, but now we get accurate numbers for each individual product. So this is obviously a relatively simple example, but it's this core concept of joining and blending our data together using table relationships and common keys that will be the focal point of this entire section of the course. And it's this core concept that's going to enable us to do some really interesting, really sophisticated analyses. So let's shift gears, open up our AdventureWorks file. I want to show you what this looks like in the Power BI environment. All right, so once you've opened up the AdventureWorks report file, you're going to want to make sure that you're using the latest version after the homework assignment from the last section. So you should see a product category and a product subcategory table. We're going to go into the report view now for the first time. And there's going to be an entire deep dive section covering all of these visualization and reporting tools. But for now, we're going to use one type of visual in particular called the matrix, which looks like this. And the matrix acts kind of like a pivot table. You can analyze values from a numerical field and break those values down by dimensions placed in rows or columns. So in this case, our values are going to come from our AW sales table, specifically the order quantity field. So let's click and drag that order quantity to values, and you'll see the total quantity from that column populate here in the matrix, 84,174. Now, if we want to break down this quantity or analyze it in a more detailed way, our only option is to use fields that exist within this same sales table. So product keys, for instance, can be placed on the rows, and now we see those order quantities broken down at the product key level. So that's all well and good, but we're extremely limited by the scope of that table. And to show you what I mean, let's go ahead and remove that product key. Let's go into the product table itself, which contains all sorts of interesting information about those products, the price, the name, the description, the color. And let's say we want to break down those quantities by product name. When we drag that field into rows, we get that same grand total over and over and over and over and over again, which is the exact same issue that we saw earlier on the slide. The sales table has no idea that a product lookup table even exists. As a result, it has no way to break down those quantity values based on any field in the product table. So this limitation is exactly why we need to build out a data model, and exactly why we're going to spend so much time learning how to do that in this section of the course. So stay tuned, more to come. All right, time to talk about something really, really important called normalization. Now, this is a tricky one to wrap your head around at first, so I'd encourage you to rewatch this video as many times as it takes until it starts to really stick. So by definition, normalization is the process of organizing the tables and columns in a relational database to reduce redundancy and preserve data integrity. So a lot of fancy words there, kind of tough to understand what that really means, but basically it's used to do three different things. Number one, eliminate redundant data, which helps to decrease table sizes and, more importantly, reduce processing speed and improve efficiency. Number two, helps us minimize errors and anomalies when we make data modifications. So if we need to insert or update or delete records in our database. And number three, it helps simplify queries and structure the database in a way that enables meaningful, useful analysis. So still feels kind of overcomplicated if you ask me. So my tip to remember what normalization is all about is to think of it this way. In a properly normalized database, every table should serve a distinct and specific purpose. So you might have one table that only gives you information about products. You might have another that only gives you information about dates, like a calendar table. You might have one that's only daily transactional records, and another that's only about customers. Now, this should sound pretty familiar because these are the exact type of tables that we're using here in this AdventureWorks demo. So let me take a stab at visualizing why normalization is such an important concept. Consider a table like this. You've got transaction quantities here in the third column, broken down by product ID and by date, as well as all of this extra information about each product ID, the brand, the name, the SKU, and the weight. And as you can see just from this small sample, that we have multiple transactions or multiple quantity values per day and multiple quantity values per product ID. So this table is not normalized. It doesn't serve a single unique purpose. It's actually serving at least two purposes. One, providing the transaction quantity by date and product ID, and two, providing additional attributes about those products. Those are two different purposes. So what you end up with here are all of these duplicate rows in any case where the same product ID appears more than once. So you see duplicate brand names, product names, duplicate SKUs and product weights. And you might be wondering, okay, that's not that big a deal. I'm still getting the information that I need. In fact, I have it all in one place in a single table, which is great. So I don't see the downside here. Well, imagine if we were dealing with 100 different products, and each of those products, on average, sold 10,000 times a day. Now all of a sudden you're talking about 1 million duplicate rows for every single date in the data set. So you can see that with larger or more complex models, minor inefficiencies like this can become major problems as you scale up in size. So the way to avoid issues like this is to strip those product attribute columns out of this table and create a relationship with a single product lookup. And if that product lookup contains a unique list of product IDs with those associated attributes, then we can access the exact same information here while eliminating every one of those duplicate rows. So again, this concept may still feel a little bit ambiguous, but trust me, we're going to get our hands dirty. We're going to do a ton of demos, walk through a bunch of samples, and this is going to start to feel much more natural as we continue through this section of the course. So next up, we're going to talk about data tables and lookup tables as our first step towards building a properly normalized model. All right, continuing on with this concept of normalization, let's talk about data tables versus lookup tables. Now, generally speaking, data models contain two different types of tables. Data, sometimes known as fact tables, and lookup or dimension tables. And the way to kind of differentiate between the two is that data tables contain those quantitative metrics, the numbers or values that you really care about. Typically, these data tables are pretty granular and detailed level with ID or key columns that can be used to create table relationships to lookups. Now, on the other hand, lookup tables, they provide descriptive, often text-based attributes or characteristics about each dimension in a table. So you remember in the last lecture, I talked about each table in a model serving a specific and distinct purpose. Well, that's exactly what lookup tables are doing. They're providing rich information and attributes about things like customers, like products, like dates. And that's exactly the role that they play within our model. So let's walk through an example here. This blue table is a data table. It contains numerical values, those quantities, along with two key columns that we can use to connect this data table with some lookups, a date column and a product ID column. So what we'll be able to do is take that date column and connect it to a date column within a calendar lookup table. And the entire purpose of the calendar lookup table, its entire reason for existing, is to provide additional information about each date. So it's got one row per date and additional attributes like the day of the month number, the year, the weekday, and so on and so forth. So the bottom line is that if you know the date, you also know all of this additional information about months, quarters, years, weeks, etc., and the calendar lookup provides or gives us access to that information. Same story holds for the product ID. That product ID column in our data table can connect to or relate to a matching product ID in a product lookup table. And that product lookup table's purpose is to provide all sorts of product-specific information about each ID. So similar concept to the calendar table, just in this case, if you know the product ID, then by definition, you know the brand, you know the product name, you know the SKU, the retail price, the cost, the weight, and any other product-specific attributes captured by this product lookup table. So in order to understand the real mechanics of how these relationships work, one of the first things we need to dig into is the idea of primary versus foreign keys. Now consider the same set of three tables: our blue data table, our green calendar, and our orange product lookup table. Consider the date and product ID columns in our data table. These are called foreign keys. They're keys because they're used to create relationships with our lookup tables, and they're foreign because they contain multiple instances of each value. And this is the case with many data tables. Here we have multiple transactions and multiple quantity values per day, and multiple transactions and quantity values per product ID. So we could potentially see many duplicate values in both of those date and product ID columns. Now when we look at the same columns in the lookup tables, date in the calendar table and product ID in the product lookup table, these are called primary keys because they uniquely identify each row of the table and they match the foreign keys in any related data tables. So it's easy to mix these up, but as a rule of thumb, primary keys are unique, foreign keys often contain duplicates. So let's jump into Power BI. I want to open up the relationships view and see if we can identify some of these primary and foreign keys in the AdventureWorks tables that we're working with. Alrighty, so once you've got your file open, we're going to go ahead and navigate to the relationships view. And we're going to be spending a lot of time here because this is where the data modeling magic really happens. And the first thing I want to do is just looking at these tables that we've got, I want to identify which are data tables and which are lookup tables. Now we've already started hinting at this quite a bit. We know that the one table that contains our quantitative metrics, the values that we care about, the order quantities, is our AW sales table. So let's grab that. I'm just going to pull it down to kind of distinguish it from the lookup tables. So now we know this is our data table. Looking up at our other tables, product lookup contains all sorts of information about products. Customer is all obviously focused on customer level information. Calendar is all about dates. Territory has information about sales regions, countries, and continents. And then we have some additional product related category and subcategory tables that are almost getting orphaned off here. So come on back, guys. So all of these tables serve very specific, distinct purposes. And I'm kind of an OCD person, so I'm going to drag the product lookup table over here with its friends and click and drag and just rearrange things a bit. We're going to be doing more designing in here, but there we go. So at this point, we know which tables are lookup tables, and we know which table is our data table. Let's take a quick pass through and see if we can identify our primary and foreign keys. So starting with our lookups, customer lookup clearly has a customer key that uniquely identifies each row within this table, and therefore uniquely identifies all of this information about customers. Calendar lookup, same story here. It's not called a key, but the date serves that purpose. If you know the date, you know all of this information about that date, the month, the week, the day of the week, and so on and so forth. Territories, we've got a clear sales territory key here, which maps to regions, countries, and continents. And then products are a little bit more complicated. We're going to get into this later when we talk about snowflake schemas. But what you may notice is that some of these tables actually contain more than one key. But for the time being, pretend like you never even saw that. Now shifting down to the data table, let's talk about foreign keys. So we know that multiple sales take place per day. So both of these date fields, order date and stock date, are both foreign keys because there are multiple instances of each value, and those dates can tie into the date field of our calendar lookup. Similar story with product key. We've got multiple sales per product. Same with customer key. Same with territory. So all three of these keys plus the two dates make up our foreign keys within the data table. So that's about enough for now. That's your crash course in data versus lookup tables and primary versus foreign keys. All right, one last conceptual lecture before we get our hands dirty and actually create some table relationships. And I really just want to drive home this very important idea of relationships versus merging tables. Now, I know some of you out there are thinking like this guy. Can't I just merge my queries or use familiar functions like lookup or related or index match to pull attributes into the fact table itself so that I have everything in one place? And the answer is yes, technically you can. You can create a table that looks like this, where you've got your original data, your metrics, your fact table fields on the left, just like the one we've been looking at with a date, a product ID, and a quantity field. And you could take those key columns and you could stitch in attributes from your calendar lookup table, attributes from your product table, and this could go on and on and on until you have hundreds of columns based on a handful of IDs or keys. And the thing is, this is a totally normal habit to be in. This was a habit that I had as a longtime Excel user, where it was this instinct to want to always blend and stitch things together and force my tables into one place. And there's a good reason for it. Before these tools came along, like Power Query and Power Pivot and DAX in Excel, there were very few user-friendly, intuitive tools that would allow you to do this type of data modeling work. So as a result, you were kind of forced to mash these different sources of data together into these Franken tables that contain all sorts of information, because that was the only way you could analyze it. Like if you wanted to use a traditional pivot table, for instance, you had to point that pivot table to a single data source or a single table. And that often required using hundreds of thousands of lookup or index match functions to tie this information together with brute force. So bottom line, sure, you can do this. Mechanically, it's possible, but it's just really, really inefficient. Like we talked about in that normalization lecture, merging data like this creates a ton of redundant information. As a result, it utilizes way more memory and a lot more processing power than simply creating relationships between multiple small, thin tables. So next time you feel that instinct to mash everything together, to merge it, to stitch it manually, just say no. All right, guys, it's an exciting moment in the AdventureWorks world because we are about to wire up our data model and create our table relationships. So in Power BI Desktop, there are two common ways to do this. Option number one, which I prefer, is to simply click and drag to connect your keys in the relationship view. So it's as simple as clicking on a foreign key, dragging the mouse, finding its primary key match, and releasing to create that relationship. Very, very simple, very straightforward, also a very visual way to create those relationships. The second option is to add or detect relationships using this Manage Relationships dialog box. So same idea here, just a little bit more manual. You would manually select the two tables that you'd like to relate, as well as the primary and foreign key columns. So without further ado, let's head into Power BI and add these relationships. All right, so here I am in the relationships view, and I'm going to show you the slow way to create a relationship first, and then we'll never do it that way again. I'm going to use the Manage Relationships button in the Home tab. And as you can see, I have a couple options here. You can choose Auto Detect and basically say, I don't know what my relationships are going to look like. Why don't you analyze the tables and tell me? Whenever I've played with it, it usually gets some of the relationships right, but misses others. So let's go ahead and disregard the Auto Detect option. And we're going to add a new relationship manually. And we're going to connect our sales table to our customer table. So AW sales to AW customer. And without even clicking on a column, Power BI automatically identified the foreign and primary key, that customer key column that matches these two tables together. And it gives us a little bit of information about the cardinality and the cross filter we're going to talk about both of those in depth, as well as this make relationship active option later on this section. But for now, that's good enough. We'll press OK and close. And there you go. We've created our first table relationship between sales and customer lookup. And you'll see as you hover over this relationship line, it kind of highlights what the key column is. So you see that box around the customer key. So that's option number one, the manual way. The easier way is to click and drag. So to connect calendar to sales, I'm just going to grab my order date, and we'll talk about whether or not to use order versus stock in a little bit. But for now, let's focus on order date. And we're going to click and hold the mouse and just drag up and release it over the date field, which is our primary key in the calendar lookup. And there you go. We've created our second relationship. Same story with territories. Let's grab that territory foreign key, drag it up to the sales territory key in the lookup. And now before I connect up the product lookup, I want to return back to my report view for just a second and remind you that we had been looking at order quantities and trying to break them down by product names to no avail. Because remember, without the relationship, these two tables are essentially islands that can't talk to each other. But now, when we go back to relationships, grab that product key, drag it up to our product lookup, and oh, it's going to be tricky. There it is, product key. Created the relationship, and now, drum roll please, we go back to report, and look at that. We've got correct values for quantities broken down by product name. And again, this could be any field from the product table, all by simply dragging our mouse, making a couple clicks, and creating that relationship between the two tables. So let's hop back into our relationships view. And I'm just going to drag things around a little bit. You don't have to organize things exactly like I am. Really doesn't make any difference. Now, I'm going to hold off on these two tables. We're going to talk about these in the next lecture. And actually, I'm going to rearrange kind of in a hierarchical way. Product, subcategory, and category. But for now, we're good to go. So congratulations. We've officially just built an AdventureWorks data model. All right, time to talk about snowflakes. And I'm not talking about weather, I'm talking about schemas. Now consider this table structure here. This should look extremely familiar because this is the exact table structure that we're working with our AdventureWorks demo. We've got one data table, the sales data table at the bottom, and three product-related lookup tables: products, subcategories, and categories. Now, here's the thing. The sales data table can connect to products using that product key column, but we have no means of connecting the sales data directly to either subcategories or categories because we don't have any foreign key that can map to one of the fields in those tables. But fear not, we've got an alternative, and what we're going to do here is actually connect products to product subcategories because both of those tables share a product subcategory key, and then by similar logic, connect subcategories to categories because those two share a product category key. And in doing so, we've essentially connected sales data to each of those lookups in the chain. So when you create those actual table relationships, it looks something like this. So little pro tip here, models that have chains of lookup or dimension tables like this are often called snowflake schemas, whereas star schemas generally have a bunch of individual lookup tables surrounding one central data table. So let's hop into our relationship view and build out these product relationships. Okay, so we're back to our model in the relationships view. We've got these set up nicely to create that snowflake chain. And all we need to do here is connect the product subcategory key to the product subcategory key there, and the category key to the category key. And there you go. We've created our snowflake, our chain set of lookups that connects all the way down to that sales table. And that means we can filter or segment these order quantity values by fields in the product table or the subcategory table or the category table. Now, interesting thing to call out here is that you'll notice that a table like this, product subcategory, or the product lookup table for that matter, contains both primary keys, in this case product key, and foreign keys, like the product subcategory key, because in this case for products, you have unique values for product key and multiple values for subcategory. And the same thing holds in the subcategory table as well. It's got a subcategory key, which is primary, and a category key, which is foreign. So just an interesting thing to call out there. Tables don't necessarily have to have only a primary or a foreign key. They could potentially have both. So there you have it. We've created a little snowflake schema here, and we've officially wired up all of the tables that currently exist in our model. So go ahead and give the file a save, and then we'll move on to managing and editing these relationships. Let's take a minute and talk about managing and editing relationships, because nothing's set in stone in Power BI. In fact, it's very, very easy to edit, add, or delete table relationships. Now, within the relationships view, you'll see this Manage Relationships option. That will show you all of the relationships that exist in your model and give you some tools to add, edit, or delete them. Now you can select an individual relationship and hit Edit to see some additional details, which two tables are involved, which field they're connected by, in other words, which column contains the primary and foreign keys, and then also some editing tools that allow you to activate or deactivate the relationship, view the cardinality, or modify the cross-filter direction. So more to come on all of that stuff very, very soon. Now let's hop into Power BI and do a very quick basic demo. All right, so back in the relationships view, we talked about this sales table and the fact that it has two date columns, the order date and the stock date. And at the moment, we can see that the relationship to the calendar table is using order date as the foreign key. But let's say we want to switch that to stock date instead. Well, from our Home tab, we can click Manage Relationships. We can navigate to that relationship, order date to calendar, and we can press Edit to see some additional options. And now it's really just as simple as selecting stock date instead of order date and updating the relationship that way. So I can press OK, close the box, and now when I hover over that relationship line, you can see that stock date field bordered in that black box. And now if we wanted to go back and maybe we changed our mind and we actually do want to use order date instead of going up to the menu and clicking Manage Relationships from there, I can also simply double click on that relationship line and jump straight to the Edit Relationship options. And go ahead and click order date, press OK, and I'm back where I started. So again, what you're probably starting to realize is that this data modeling, this relationship view is very, very user-friendly. In fact, you can add and delete relationships in really just a matter of seconds. For example, this customer key relationship to the sales table, I could right-click, delete that relationship, and then simply grab customer key and drag it back to the lookup table, and we're back in about 5 seconds. So again, Power BI makes it very, very easy and user-friendly to manage and edit your table relationships. There are two types of table relationships in Power BI Desktop, active and inactive. Consider a case like this. Our sales data contains two date fields, an order date and a stock date. And while you can connect both of them to the date field in the calendar lookup table, only one can be active at a time. That's why one of these relationships shows up with a solid line, that's the active one, and the other shows up with a dotted line, which is the inactive one. Now, if you edit both of these relationships, you'll see that one has the checkbox where it says make this relationship active, the other does not. Now you can toggle these back and forth, but the one catch is that you have to deactivate the active one first before you activate the other. In other words, there can be no point in time where both of those checkboxes are activated. So let me show you what this looks like in the relationships view. Okay, so here we are back in our AdventureWorks model. As you can see, we've got these two date fields in our sales table, order date and stock date. Right now we're connected to the calendar table based on order date, which in this case is our primary date field. But what we can do is grab stock date as well without deleting our order date relationship and drag it up to date so that both are connected. Now you see that it added another relationship, one of which is dotted, which is the second one we added, stock date. The other is solid, order date. That's the active relationship. And remember, if I double click the inactive stock date relationship and try to activate it, it won't let me because it says there's already an active relationship between sales and the calendar lookup. So I've got to deactivate or delete that existing relationship before I can activate this one. So I need to uncheck, press OK. And basically the process looks like this. Start with order date, deselect to make that one inactive. Now I've got two inactive relationships here, and then I can double click and activate my relationship between the stock date and the calendar date. So there you go. I've just swapped the two. And because order date is my true primary date field, I'm going to go ahead and just reverse what I did. I want this stock date field to be available but not active. And my order date is the one that I really care about. So there we go. So again, I have both of these relationships in place when I do need them, but can only keep one active at a time. It's time to talk about relationship cardinality. Now, cardinality, by definition, refers to the uniqueness of values in a column. So for our purposes, all of the relationships that we're going to be creating with the data tables that we have in our model should follow a one-to-many cardinality. One instance of every primary key from our lookups, but potentially many instances of each foreign key from our data tables. So looking at the screenshot here, in this case, we have one instance of each product key in that product lookup table. You'll see that blue box around the number 1, since each row contains attributes of a single product, name, SKU, price, etc. On the data table side of that relationship, because there are many instances of each product key, which is the foreign key here, you'll see that the relationship terminates in an asterisk in that yellow box because there are multiple sales associated with each product ID. Now, the other types of cardinality that we're trying to avoid here are many-to-many or one-to-one. So I thought it would be helpful to put a little case study together for each of those two to show you why we'll be using one-to-many relationships instead. So our first cardinality case study is many-to-many. Now consider these two tables. You've got a product lookup table in green on the left, which has IDs, names, and SKUs. And you've got a data table in blue on the right, which has dates, product IDs, and transactions. So if you were to try to create a relationship between these two tables, you'd get an error message that looks something like this. PowerBI is going to tell you you can't create a relationship between those two columns because one of the columns must have unique values. And as you can see above, we've got two instances of product ID number 4 in the lookup table and 3 instances in the data table. So now let's take a minute and step back and really think about this for a second. Even if we had some magical way to force this relationship to stick, it really just doesn't make sense logically. So we know that product number 4 was sold 12 times on January 1st, 9 times on the 2nd, 11 times on the 3rd. But since ID number 4 is associated with multiple product names, how do we know how many of those sales or transactions were for Washington cream soda versus Washington diet cream soda, which for the record sounds like the worst beverage on the planet? That's not relevant here, but you get my point. There's no way to make sense of this data with the tables in this kind of form. Now let's move on to our second cardinality case study, one-to-one. Now compared to many-to-many, this one's not nearly as bad. In fact, you can create one-to-one relationships. They're just a little bit inefficient. So consider these two tables. You've got a product lookup on the left, just like we showed before, but without those duplicate ID number 4 rows. And then almost like a smaller product lookup in orange on the right with product IDs and product prices. So if we were to connect these two based on product ID, we're creating a one-to-one relationship since each ID only appears once in each table. So again, unlike many-to-many, there's nothing illegal about this relationship. It's just kind of an inefficient way to do things. So to eliminate the inefficiency, What you could do here is simply merge those two tables together into a single valid lookup. Now, I know what you're thinking. I've been telling you this whole time never to do merging, it's inefficient, use relationships instead. But trust me, in this scenario, it's legit because we're still respecting the laws of normalization. All of our rows here are unique, and this merged, blended table still captures attributes related to the primary key. So it still serves one single purpose. So there's your cardinality crash course. Now let's jump back to Power BI and make sure that our relationships follow a one-to-many cardinality. So back in our relationships view, what we're looking for here is that the lookup table side of each relationship shows a 1 and the data table side shows an asterisk. One instance of the primary key in the lookup table, many instances of the foreign key in the data table. So customer lookup looks good, calendar lookup on order date looks good, calendar lookup on stock date looks good, territories one-to-many, product one-to-many, and then we can follow our way right up the snowflake, one-to-many, one-to-many. So it all checks out. We've got a good set of one-to-many cardinality relationships, so we're in good shape. All right, it's time to shake things up a little bit. To this point, we've been dealing with a pretty simple, straightforward model, just our one data table, that sales data table, and a bunch of individual lookups that we've created connections or relationships to. Now, here's the thing. I just got off the phone with our client at AdventureWorks, and it turns out that they have another data table with information about product returns that they'd like us to integrate into the model as well. So in other words, they don't just need us to analyze product sales, but they want to get a sense of which products are being returned most often as well. So what we're dealing with here is something like this. In this particular case, we've got a simplified model with 3 lookup tables, customer lookup, calendar and product lookup, and 2 data tables, sales data and returns data, each with its own set of dates and other foreign keys. But take a minute and look at the relationships here. What you'll notice is that the sales data is connected with one-to-many relationships to all 3 of the lookups, customer lookup, calendar, and product lookup. But the thing is, the returns data is only connected to the calendar and the product lookup. We don't have any way to connect returns data to customer lookup since we don't have a foreign customer key. And this isn't entirely uncommon, especially for larger or more complex real-world models where you're pulling in data from a number of different sources. It's actually quite uncommon to have the exact same set of foreign keys in every source data table that you're working with. So this is the type of scenario that you may very well run into in a real-world application. So what this means is that we can analyze sales and returns data, sales quantities and returns quantities, within the same view or visual in Power BI, but only if we filter or segment our data using fields from shared lookup tables. So looking at the returns data in this particular case, we know which product was returned because we have a product key, and we know which date the product was returned because we have a return date, but we know nothing about the customer who made the return. So there's no way we could slice or dice or filter that returns data by any field in the customer lookup, like names, marital status, gender, income, any of those fields. So what you may be noticing here is that we've successfully integrated that returns data into the model, but we did not attempt to make any kind of relationship between the returns data and the sales data. And the reason for that is that no matter which fields we tried to use to form a relationship between those 2 data tables, we're always going to run into a many-to-many relationship error. And that's because both data tables, sales and returns, have multiple dates in the date field. They have multiple products in the product key field, multiple territories in the territory field, and so on and so forth. So even if we wanted to connect those 2 together, there'd be no way because we have no field that would give us a valid one-to-many relationship. So that's a very, very important point. Generally speaking, you will never create direct relationships between data tables. Instead, you connect them indirectly through shared lookup tables. So what we're going to do now is jump back into Power BI. We actually have that returns CSV file that we're going to load up, and then we're going to wire it into our model, creating relationships just like the ones you see here. All right, so once you're back in the relationships view of your AdventureWorks report, go ahead to the Home tab and click Get Data. We're going to get our last file of the project. It's another CSV. And this time we want AdventureWorks_returns. So go ahead and double click. Take a look at the preview. Pretty simple data set here. Got a return date, a territory key, product key, and that numerical quantity field as well. So let's edit this file to fire up the query editor. And first things first, let's head to our table name and call this one AW returns. Check our headers. They're promoted. We've got dates for return date, whole numbers for territory key, product key, and quantity. Very straightforward. All looks good. Let's go ahead and just close and apply just like it is. And we'll see that object pop in right here in our relationship view. There we go. So here's our second data table. I'm going to kind of click and drag and make some room for it here. And I want to make it clear that these two tables here are the two data tables that we care about. Now remember, I can't just grab a field, a foreign key from my returns table and try to force a connection right to my sales table, because I'll get that many-to-many relationship error. You can't create a relationship because one of them must have uniques. So press OK, and the same holds even if I try to use my keys. Territory key to territory key, can't do that either. So again, the way that we integrate a second data table, or a third or a fourth or a fifth for that matter, is by wiring it in and creating the same relationships just like we would with any other table. So territory key can connect to territory key, return date can connect to calendar date, and then last but not least, product key can connect to product key, and by association, product subcategory and category as well. So again, no customer key means that we can't form a relationship with that customer lookup table. Now, to really hammer that point home and understand how this impacts our analysis, let's jump all the way back up to the report view. And as you can see, we've still got our matrix here showing product name and order quantity. So what I'm going to do is select that matrix. You can see my returns table has populated here. I'm going to grab return quantity and pull it in right under order quantity in my values. And I can expand to view and take a look. This looks great. I'm now seeing order quantities and return quantities side by side in the same visual, broken down by product name. So that's really helpful, and I can get a lot of insight from this. But what if we want to see this same view, these same values, broken down by gender instead? I'm curious if men or women tend to return items more frequently. So instead of product name, let's pull that right out of our matrix. And let's go ahead and drill into our customer lookup. And right here we can find gender, pull that into rows, and take a look at this. We see the order quantity, which seems to be correct, but for return quantity, get that same repeating number issue that we've seen in the past. And almost every time you see that repeating number issue, it's because of a relationship problem. And in this case, the relationship problem is that we're trying to apply a filter from the customer table and show values from returns, which is an unrelated, disconnected table. And that goes back to the point that I made earlier. You can only view fields from both of these data tables in the same visual when you're filtering or segmenting using a field from a common or shared lookup. Since the customer table is not shared by both of these, this is an invalid view, and that's why we see these duplicate, erroneous values. So let's jump back to our relationships view. And this is our finalized data model. So we've got all of our tables in here. We've got all of our relationships in place. This is going to set us up for some really interesting analyses down the line. But before we move on to calculated fields with DAX and then visualizations, we need to hit one more really important concept when it comes to data modeling, which is the filter flow. So stay tuned, that's coming up next. All right, time to cover one of the most important lectures, certainly in the data modeling section, but perhaps in the entire course. Let's talk about filter flow. Now, to demonstrate, I'm going to use a very simple example. Here we've just got a 3-table model, 2 data tables, sales and returns, both with valid connections or relationships to a single lookup, territory lookup. Now, when you look closely at the 2 relationships, you'll note the filter directions, which are shown as arrows, point from the one side of the relationship, or the lookup side, to the many side, the data side. And when you filter any table, that filter context is passed along through that relationship line to all related downstream tables, following the direction of the arrow. And by contrast, filters or filter context cannot flow upstream. In other words, it cannot flow against the direction of the arrow. So you can almost think of these relationships as filter wires, because that's all that relationships do is they pass filter context back and forth between tables. Quick pro tip, one thing you may have already noticed that I've been doing is that I like to arrange my lookup tables above my data tables in every data model that I build. And that just helps serve as a visual reminder that filters flow downstream from those lookups down to your data tables. So let's look at a visual representation of why filter flow is so important. We're going to look at that same simple 3-table model, and let's say we want to analyze sales and returns broken down by territory key. Now, the only valid way to do that is to use the territory key field from our lookup table. And when we grab that field from the lookup, pull it into our matrix rows, we see the proper, accurate values for order quantity and return quantity, both broken down by territory. Now, the reason we get the correct answer here is because that filter context that we created by using the territory key in the lookup table is able to pass or flow downstream to both the sales table and the returns table. But keep in mind, we also have a territory key in the returns data, as well as a territory key in the sales data. So technically, there are 3 different ways we could try to replicate this view. So let's take a look at what happens when we try to do that. Filtering using territory key from our sales data table will yield the correct order quantities, since those come from the sales data table, but incorrect returns values. And the reason that's the case is that the filter context that we created by using territory key in the sales data table is stuck in this table. It cannot flow up through this relationship because it can't flow against the direction of the arrow to filter either the lookup or the returns data. So as a result, the return quantity knows nothing about the filter context that was set from using the territory key in the sales data table, and therefore just returns the same grand total value over and over and over again. Now, very similar case, if we try to use the territory key from the returns table, we see the correct value for the return quantity now, but incorrect values for order quantity, because the filter context that we created by using the territory key in the returns data is stuck in the returns data table. It can't filter the lookup or the sales data table. So just like our last example, order quantity now knows nothing about the filter context passed from the returns data table, and therefore returns the grand total over and over and over again. In addition to that, you'll notice that this table is smaller. It contains fewer rows, and that's because only territories that registered returns are even going to be visible in this table, since the filter is taking place within that returns data table. So we don't even see data from territories 2 and 3, even though they registered orders. So this is a little bit tricky to grasp at first, but it's an incredibly important concept that's going to come up time and time again as we start working with more complicated concepts like DAX formulas and interactions between visuals in the report view. So to really drive this point home, let's hop back into Power BI and build our own matrix visual to see this filter flow concept for ourselves. All right, back in my report view in my AdventureWorks file, I've got the same matrix that we just showed in our last video. And to follow the demo that we just talked about, I'm going to select the matrix. And instead of gender here, let's go ahead and find our territories table. There it is. And we want the sales territory key. We're going to drag that into rows. So just like we were demonstrating, we've got 10 sales territories, 1 through 10, and we're seeing proper order quantities and proper return quantities. And you can see from that last example that territories 2 and 3 did not register any returns in our sample, so those cells are blank. So this is an accurate, valid view for orders and returns by sales territory. But just like we demonstrated, if we pull sales territory out of the rows and we drill into the actual sales data itself and grab the territory key from there, when we drop that one into rows, now you'll see that return quantity duplicated every single row. But you'll still see all 10 territories because all 10 territories generated orders. And I think you see where this is going. We can pull territory key out, drill into our returns table, grab the returns table version of the territory key, and there you see that order quantities are now duplicated, return quantities are correct, and those 2 territories that did not register returns don't even show up here in the matrix because they were filtered out from the start. So hopefully this demo starts to give you a sense of why filter flow is so important to understand. Making sure that we have a crystal clear understanding of our model's filter flow will be critical for making sure that the views we're creating, the filters we're using, and the numbers that we're showing are 100% accurate. Now, when it comes to filters, there's one important difference between Power BI and Power Pivot for Excel, and that's that Power BI actually enables you to create two-way or bidirectional filters. So let's take a look at that familiar 3-table model. Just like we've seen before, with one exception, that relationship between territory lookup and sales data now contains a bidirectional filter. So by updating the filter direction in that relationship between sales and territory from single to both, we've essentially allowed filter context to flow in either direction. What that means is that filter context could flow from the territory lookup down to the sales data, just like normal, but it could also flow from the sales data up to the territory lookup, and then from there down to returns. So what we'll see now is that we can control and filter returns data using filter context from within the sales data table, which is something that we could not do using the one-directional filters in the last lecture. So let me show you what that looks like. Here we go, same 3-table model. The only difference is that one bidirectional filter between territory and sales. And because we've enabled cross-filtering between those 2 tables, we can now see correct values using the territory key field from either one of those tables. So again, just like before, using the territory key from the lookup will yield proper, accurate values for both order quantity and returns quantity, since it's upstream and connected. What's new now is that pulling in the territory key from the sales data will not only return proper order quantities as you'd expect, but that filter context is now able to travel up to the territory lookup, which then filters territories based on which ones generated sales, and then that filter context in turn passes down to the returns data table, which filters accordingly as well. So we've essentially created a way to transmit filter context from within the sales data table all the way to the returns data through the territory lookup. Now, as you'd expect, if we pull in territory key from returns, same story as before, that filter context is trapped in the returns data table because we've got that one-way relationship between territory and returns. So let's keep this idea going a little bit and consider a similar model with one difference, which is the bidirectional or cross filter now exists on the relationship between territory and returns instead of sales. What we see this time is that, as always, the territory lookup version of territory key returns the proper values. The territory key pulled from the sales data table returns incorrect return quantities because now that filter context is trapped within the sales data table. But here's where it gets interesting. When we pull in the territory key from the returns data table, the returns are accurate, which we know will be the case, but check out territory key and order quantity. At first glance, things look good, but remember that territories 2 and 3 don't even exist in the returns table. So since no information about territory 2 or 3, ever gets passed up to the territory lookup, then they'll subsequently get filtered out of the sales data table as well. So the filter context that we created by using this territory key field from the returns table is properly flowing up to the territory lookup and then down to the sales table. But in doing so, it's yielding misleading data. And this is dangerous because this type of issue can be very, very difficult to detect, even if you know your data model inside and out. So had we not gone through this exercise, we may never have realized that territory 2 actually drove an order quantity of 40 and territory 3 drove an order quantity of 30. But because of the way our filter context flows, those values get completely stripped out of this view. So that brings me to my next point, which is a word of warning about two-way filters. The fact is you've got to use two-way filters carefully and only when necessary. Now there are cases where two-way filters are helpful or sometimes even necessary. Like for instance, if you want to intentionally filter a lookup based on a data table, kind of like we just showed. But the thing is, two-way filters really aren't recommended for models with multiple data tables, exactly like the one that we're working with. And in fact, if you try to use multiple two-way filters in a more complex model like this, you run the risk of creating something called an ambiguous relationship, because you're essentially introducing multiple filter paths between tables that could potentially contradict each other. So consider this data model shown here on the left. We've got the same three tables that we've been looking at, plus now a product lookup table as well. And you'll notice that there are two bidirectional filters here from territory lookup down to sales and down to returns. What's important to call out here is that only one of the relationships from the product lookup table to the data tables can be active at one time. If you tried to activate both, you'd see an error message like this. It basically says you can't create a direct active relationship here because it introduces ambiguity. So you've got to either deactivate or delete a relationship or change one of your bidirectional filters to one way. So very, very confusing and not really intuitive at first glance. So I'm going to take a stab at explaining this to you in plain English the best way that I know how, but this is a little bit nuanced, so it might be one of those cases where you're going to need to step back, pause the video, maybe rewatch it a few times before it starts to really click. So here's the deal. Let's imagine that we want to filter our data for a specific product. And to start, all we care about is the relationship between product lookup and returns, which is currently active in the model that we're seeing here. So for the sake of example, we want to filter down our data to just the product named racing helmet. Okay? So that filter context, product name equals racing helmet, passes down, it flows downstream right to the returns table. And as a result, that returns data table filters down to only rows where that racing helmet was returned. Now, if that helmet was only returned in territories 7 and 8, because territory keys 7 and 8 were the only ones remaining in that filtered down returns table, that's the context that gets passed up to the territory lookup through that bidirectional filter and tells that territory lookup table, hey, there are only two territories that exist in the universe, 7 and 8. Now, shifting gears to the relationship between the product lookup and the sales table, let's go through that similar thought process here. Imagine we could also activate that relationship. That way we can say, all right, product name is racing helmet. Let's allow that filter context to flow down to the sales data table, just like it flowed down to returns. Except now this time the sales data table is going to collapse and filter down to only rows showing records where that racing helmet was sold. And if that racing helmet was sold in stores 7 and 8, as well as 1, 2, and 3, then that filter context also would pass up to the territory lookup through that bidirectional filter and tell the territory lookup, hey, there are 5 territories that exist in the universe, 1, 2, 3, 7, and 8. So what we've done in this hypothetical situation is pass 2 conflicting sets of filter context to that same territory lookup table. The returns data table is telling the territory lookup that the only territories that exist are 7 and 8, and the sales data table is passing along different information and saying that territories 1, 2, 3, 7, and 8 are the 5 territories that exist. So that's what we mean by ambiguity. Both can't be true at the same time, and all we end up doing is confusing Power BI and confusing that territory lookup table in a way that prevents our model from producing or yielding meaningful values. So as a result, Power BI forces you to keep one of those relationships inactive so that you can't possibly pass conflicting filter context to the same table. So at the end of the day, that's really just a long-winded way of saying we don't want to use two-way filters in our particular model. And as a pro tip, rule of thumb, I'd recommend that you try to design your models with one-way filters and one-to-many cardinality, especially as you're first learning, unless more complex relationships are necessary. So with that, let's take a quick peek at what this actually looks like in the Power BI environment. All right, so in the AdventureWorks report, I'm going to start in the report view first. And as a reminder, I've got my matrix here. And one thing that you can do is actually hover over the field that we've pulled into a row list to confirm exactly which version of territory key we're looking at. In this case, we can see that it's coming from the AW returns table. So remember that we've got the key from our returns table, and we're getting incorrect order quantities here. When we jump to our relationships view, and we find that relationship from returns to territories, we can double click to edit, drill into this cross filter direction, change it to both, and press OK. See that little arrow switch from one direction to both. And now when we return to the report, this is exactly what we had talked about. So now order quantities look to be correct, and to the untrained eye, the initial reaction is to flash a thumbs up and say, okay, we're good to go. You know, we've got order quantities broken down by territories, we've got returns by territories. But again, remember the problem here is that we are missing data. There are actual valid order quantity values for territories 2 and 3 that aren't showing up because by using territory key from the returns table, we've filtered them out from step 1. So now let's go back to relationships. I'm going to double click that same relationship, change it back to single, press OK. And I'm going to find the relationship from sales to territories. There it is. I'm going to make this one bidirectional, press OK. Head back to report, pull out the territory key from returns, and pull in the territory key from sales. And here's what we see. In this case, we see the correct values from both, but only because each of the 10 territories registered a sale or showed up in that sales data table. So important nuance there. These numbers could very well be incorrect as well had there been one of the 10 territories that didn't show up in the sales data. We'd have the same issue that we just had with territories 2 and 3 in the return table. So last little demo here, back to returns. If I go back to the relationship between territories and the returns table and double click, watch what happens when I try to click both here. I get this error that says you're trying to create an ambiguous relationship. You can only have one filtering path between tables in a data model. So you can't even press OK. You have to deactivate one of those existing relationships, or unless at least one of those filters was changed back to single direction. So for the sake of our model, I only want one-way filters because I don't want to introduce the potential headaches that we just talked about. I'm going to go back to my sales territories relationship, change that back to single as well. There we go. And now just for good measure, let's go back to report, pull that territory key from sales out, and let's grab the proper one from our lookup table and drop it in rows. So I know that was probably a little bit confusing at first. Again, I'd recommend rewatching this a few times until it starts to make more sense. But the one big takeaway from this entire conversation is that for our purposes, we will not be using two-way filters, and therefore we will never pull in foreign key fields from our data tables. So it's going to keep things simple. It's going to keep things accurate. From here on out, every time we filter our data, we're going to do so using fields from our lookup tables. Okay, so after talking about filter flow, in depth and learning about the risks of using bidirectional filters and the pitfalls of pulling in a foreign key instead of a primary, you may be thinking to yourself, man, it is really easy to make major mistakes in Power BI. And to some extent, that's true. Without having a good fundamental knowledge of how data models and filters actually work, it certainly can be easy to make this type of mistake. But the good news is that Power BI gives us tools to help prevent this type of thing from happening. For example, hiding fields from report view. Now, in either your data view or your relationships view, you'll have this option called hide in report view. And you can simply right click on either a column, a field, a measure, or an entire table and choose this hide in report view option. And what that does is essentially make that field or table inaccessible from the report tab. It makes it invisible. So you can still access the data and see the information within the data or the relationships views, but end users in the report view will not be able to access those fields. So this is a really common way to prevent users from accidentally filtering using invalid fields, like a foreign key from a data table instead of a primary key from a lookup. So pro tip here, my recommendation in general is to hide the foreign key columns in your data tables, which will force users to filter using the primary keys from the lookups, since that's the only option they have left. So let's go ahead back to our AdventureWorks demo and work on foolproofing this model. All right, so we're back in our AdventureWorks report. We're in the relationships view looking at our model, and I want to show you how to hide some of these fields. First of all, you can select an entire table, right-click the header, and hide a whole table from report view, which will essentially gray it out. But we don't want to do that in this case. We need information from all of our tables, including the values or quantities from returns and sales, at least for now. But what we can do is start hiding some of these foreign keys, because 99% of the time, we don't want users filtering on dates or products or customers or territories within the data table itself. You can access that same exact information using fields from the lookup tables instead. So all we need to do is hover over the field, right click, and click hide in report view. You might see it flash at you like that. That's okay. We're going to do the same thing for stock date. There we go. It grays out. That means it's now hidden. We can keep order number in there, but let's hide product key and customer key and territory key. There we go. So all 5 of those foreign keys, the one that connects to customer, the 2 dates that connect to calendar, and the connections to territory and product are now hidden. And we'll do the same thing for returns, return date, territory key, and product key. So we haven't lost anything. You can easily right click and re-enable any of these fields. And also note that we could have done the same thing in the data tab as well. You'll see we're in our sales data now. Those columns that we did hide are now grayed out. You could also select or right click the column header and choose the hide and report view option there as well. Just 2 ways to do the exact same thing. So now here's the real impact. If we go to the report view, here in my fields list, you'll note that my returns table only has that one lonely field, and my sales table has been chopped down to just these 3. So remember, hiding from report view makes them invisible or inaccessible, but only within this one view. So there you have it. That's a great way to foolproof your data model and your Power BI reports by hiding fields from report view. All right, so if you just worked through that section and noticed that your screen looked quite a bit different from mine, that's okay. Let's talk about what some of those differences look like. Since recording the course, Power BI has gone through a number of updates that have changed the look and feel and functionality of the platform. So the first thing you'll probably notice is a view like I'm showing here. We've got this default light mode, which is very bright and airy and light, compared to the default dark mode when Power BI was first released, which had a lot of blacks and dark grays. Now that was just a purely stylistic change, so nothing really to talk about there. But where we do see some additional differences is inside of that relationship view, which is now called the model view. So the first thing you've noticed, I'm sure, is the addition of these two new panes here called properties and fields. Now, these aren't adding a lot of new tools or features to the platform. They're just making existing features a bit more accessible and user-friendly. So now I can select objects from my model, either entire tables like so, or individual fields, either from the model canvas or from the field list here on the right. And as I do so, I have access to different properties that I can customize right here, like the name, synonyms, description, whether or not it's hidden from report view, and I've got advanced features or properties that I'll walk through as well. So table name speaks for itself. Synonyms, these are automatically generated. They don't really mean much in the desktop environment, but if we were to publish this file to Power BI service online, they've got some great features there like natural language questions, which allow users to actually type in questions to retrieve information or insights from their model. So instead of forcing users to type the name exactly as shown, capital AW underscore calendar, you can use different variations with lower cases, spaces instead of underscores, and Power BI will recognize that you're referencing the same thing. And then down here in the advanced options, you've got storage mode, either import, direct query, or dual. Now, this is a little bit outside the scope of this course, but just in a nutshell, to give you a sense of what the difference is, import means that you're grabbing data from your source and actually loading that data into the Power BI environment. Direct query, on the other hand, is when you've got source data that's typically stored in a database, data warehouse, or data lake, like Access, SQL, Azure, and you're asking Power BI to send queries to that source data to retrieve the data that you need, as opposed to actually storing the data here inside of Power BI. So in this case, we're using import because we're actually grabbing data from those CSV files and loading them here into the system. Again, a little bit outside the scope of the course, but just wanted to cover that quickly. And same goes with individual fields here. If you select one individual field, you've got properties at the field level as well. Name, synonyms, description. Display folder is something that's a little bit new. It's purely for the sake of organization, but if you've got fields that are related in some way and you want to organize or group them together, but they don't follow a hierarchy necessarily, you can create a folder just to organize things a little bit more clearly. So to give you a quick example, let's drill into product lookup. You can follow along if you'd like. I'm going to delete this in a minute so you don't have to. But let's say we want to take the model name, the product color, the product name, and style, for instance, and put those into one folder. This is something that's new with this view that I couldn't do before, which is I'm going to select a field, hold Control, select the others, like description, name, style, just kind of arbitrary, but let's grab those 5. And I've multi-selected those, and I can say let's throw those into a display folder called product detail. Press enter. Boom, we've got that new folder right there inside of our product lookup table containing those 5 fields. And that change carries through the entire platform. So jumping into the data view, there's that folder I just created. Let's go back to model, and then getting rid of it is just as simple. Right click, delete from model. It won't get rid of the component fields, it just gets rid of the folder containing them. So nice little organizational feature right there. Again, you can hide multiple fields from view in one sweeping pass, one go, instead of right-clicking each field individually like we used to have to do. And then you've got formatting options here as well. So data type, data format. Let's actually select a numerical field as well, like order quantity. You can see order quantity is a whole number. You can change the percentage or thousand separator formatting. And then you've got some advanced features as well, like sort by column, the data category, which is great for mapping. So you can set things like region or postal code to help Power BI map those geospatial fields more accurately. And you can change the summarization mode as well. So default to a sum, a count, an average, no summarization at all. And you can do this for any field here in your model. So those are the properties. They're pretty straightforward. I'd recommend kind of working through these, getting comfortable with your options here. And again, these are the same tools that we've talked about and that we'll continue to talk about here in the data view. If you go to the modeling tab, you've got field properties accessible right here in your toolbar as well. So again, these aren't brand new features. They're just making them a little bit more accessible and user-friendly here inside of the model view. Now, last thing that I want to quickly cover here is the fact that now we have tabs available at the bottom of the screen, which we didn't have before. And by default, you'll see this one tab called All Tables, which means you're viewing your entire model. Now, one common question is, how do I make this bigger or smaller? Sometimes you get to this view and you see something like this, which is totally ridiculous. You can't even read what your table names or fields are. They've put the little zoom bar, it's kind of hidden, but it's all the way down here on the right, and you can click the plus sign to make that view a bit bigger. But getting back to the concept of tabs, what these tabs allow you to do is create new views of your model that basically contain subsets of the tables. So if you've got a really complicated model with hundreds of tables and relationships, and you want to kind of zoom in on a specific component of your model to help users understand how it's built, you can create these different layouts. And check this out. If we want to create a layout containing our sales information, we can grab that sales table, just drag it right in the canvas there, and then if we want to show which related tables are connected to sales, we don't have to drag those in, we don't have to create new relationships again. We can just right click anywhere and say, let's add the related tables. Boom, with one click, there you go. It's pulled in calendar, product, territories, and customer tables with those relationships still intact. So again, we're looking at a subset of our all tables view, which is the entire model. We can go ahead and double click, call that something like sales, and then check it out. We'll do the same thing for returns. There we go. AW returns, right click, add related tables, pulls in product, calendar, and territories. Double click, call it returns, and there you go. So now we've created these very specific views to help users understand different slices or components of our full model. And then getting rid of those, it's as simple as just clicking that little X and confirming. So there you have it, kind of a quick 10,000 foot view or tour of this new model tab. Hopefully that helps. All right, we've officially reached the last topic of our data modeling section. Let's talk about best practices. First and foremost, focus on building a normalized model from the start. Remember, that means that each table in your model serves a single distinct purpose. You should be using relationships over merged tables whenever possible. At the end of the day, creating relationships between multiple long and narrow tables is better and more efficient than merging them together into a bunch of short and wide tables. Number 2, organize lookup tables above your data tables in the diagram view. This is not required. It has no impact to performance or calculations or anything like that. It really just serves as a visual reminder and a little cue that those filters do flow downstream from your lookups down to your data tables. Number 3, try to avoid complex cross-filtering unless absolutely necessary. So we talked about some of those warnings with two-way filters. So avoid using them unless you absolutely have to, and especially when a one-way filter will get the job done. Last but not least, hide fields from report view to prevent invalid filter context. My recommendation is to hide the foreign keys from data tables unless you need them, so that users aren't able to access invalid fields for filtering. So there you have it, my personal best practices for data modeling in Power BI. All right, congrats. You've made it to the end of the data modeling section of the course. Last item here is to cover the homework solution walkthrough, and then we'll move on to calculated fields with data analysis expressions or DAX. So let's jump right into question 1. We need to navigate to our relationships view. Here we are, and perform 2 different actions. First, we're going to right click to delete each relationship between AW sales, AW customer lookup, and AW calendar lookup, including both of these date fields. So let's go ahead one by one. Right click, delete, confirm, right click, delete, confirm, and you guessed it, right click, delete, confirm. So we had a nice, beautiful, fully functional data model, and now we are going to tear it to pieces. But don't worry, we're going to rebuild it. A big part of the reason we're doing this is to showcase just how easy it is to do that. So now I could continue on and right click each of the remaining relationships here, or if I'm doing a bulk action kind of like that, I like to use manage relationships in that case, where I can hold shift and select the last item to get all of the relationships selected. I can delete in one pass. There we go. When we confirm and close out, they all disappear at once. So a little bit more efficient approach. So that's question 1. Easy enough, pretty straightforward. Question 2, which you may have anticipated, is that we're going to now recreate those table relationships for ourselves from scratch. And we can use any method we choose here, whether it's the manage relationships option or the click and drag approach. I prefer click and drag, so I'm going to go ahead and take that approach. And I'm just going to start with sales, wire up the full sales model, and then move on to returns. So let's go ahead and get started. I'm going to go in order of the fields in my sales column. So order date to date, that defaults to my primary active relationship. Stock date to date, which comes in as an inactive relationship because we can't have two relationships, both active, from one table to the same primary key. So because I drag my order date first, that's the one that gets priority. That's the one that gets activated. Moving along to product key to the product lookup, customer key to the customer lookup, and territory key to the sales territory key. Same deal with returns. We're going to pull return date, connect it to calendar date, territory key to sales territory, product key to product key. And now let's go ahead and build out our little snowflake here, subcategory to the subcategory key, category to category key. So there you have it. It probably felt a little bit scary when we deleted all those relationships. It felt like a whole bunch of work kind of going down the drain. But look at that. In about a minute, we've completely rebuilt our entire model. So now that we've recreated the relationship, question 2 asks us to confirm a few things. So number 1, cardinality is one to many for all relationships. So I'm going to look at my lookups first, and I'm looking for that 1 icon. So that indicates that I'm connected to a primary key on this side of the relationship. Customers look good. Calendars look good. All 3 connections from there. Territories 1, 1. Product 1, 1. And then again, same thing with my snowflake. Each of these are serving as primary keys, and my product and subcategory tables are also serving as foreign keys as well. So I've got 1s on the lookup side of every single one of my tables, and I've got asterisks which indicate the many side of the relationship on both data tables. So that one checks out. Number 2, filters are all one way, no two-way filters here. So I'm looking at the arrows now, checking that A, the relationship points to the data table downstream, and B, it's only a single arrow, not a bi-directional arrow here. Looks good, looks good, looks good. Okay, number 2 checks out. 3, filter direction correctly flows downstream to the data tables. We just did that by checking the direction of the arrow. Data tables are not connected directly to one another. As you can see, both data tables are connected to each valid lookup, which makes sense. We did not try to force any sort of crazy many-to-many relationship between sales and returns. So that one checks out as well. That hits number 5, connected to all valid lookups. We can confirm that each of the foreign keys in our data tables is currently connected. Order date, stock date, product, customer, territory from sales, return, territory, product from returns. So all we have left are some of these numerical values. We've got an order number in the sales table that's not connected to anything, which is okay. We've got our order line item and our order quantity, as well as return quantity for returns. And then last little item in question number 2 is that our product related tables follow a snowflake schema, which as we can see, they do. We've got that lookup chain extending out from the data tables. So that wraps number 2. Let's go ahead and move on to number 3, which is returning to the report view. So let's go ahead and head back to our canvas. and we're going to edit our matrix visual to show return quantity by category name on rows from the AW product category lookup table. So in this case, we don't need order quantity yet, and we're not showing this by sales territory key. We've got return quantity here in our values, and we need category name from the product category table, which we can drag this pane a little bit out so that we can read it better. So category name on our rows. So there you have it. Which category saw the highest volume of returns and how many? Looks like accessories drove the highest volume at 1,130 total returns. Next up, we're going to replace this category name with year from our calendar table. So we'll delete that, drill into calendar. One note here, you can use the search bar as well, which gets really helpful if you have tons and tons of fields. We're going to be building out a number of new measures, so this field list is going to keep growing. So you can just simply search for a text string like year. You can see, okay, in my calendar lookup, I've got this year field, which is what I want in this case. I'm going to drag year into rows, and then you can just delete that search bar, take you back to the full list. So this part of the question asks, okay, how many returns do you see in 2015 versus 2016? In this case, I see a total of 86 returns in 2015, 770 in 2016. Last but not least, let's pull year out and drill into our customer lookup table. We need the full name column from here. We're going to drag that into our rows. So what do we see and why do we see it? Well, obviously what we see is a series of repeating identical return quantity values, 1,828, which also happens to be the grand total, not a coincidence. And the reason why we're seeing that is because we're trying to filter on a field from the customer lookup table. And because we don't have a relationship between the customer lookup and the return table, there's no way for that filter context to pass down to the data table to filter those values properly. And then last item for question 3, we're going to update this matrix to show both order quantity and returns by product key from the product lookup table. So let's go ahead down to our sales table, drill in, we need order quantity. I'm going to pull it in front of return quantity, doesn't really matter. And now instead of full name, we're going to drill into our AW product lookup table and grab the product key from there and drop that on rows. So here we go, orders and returns by product key from the lookup table. So what was the total order quantity for product number 338? Here it is. Got total order quantity of 50. So make sure you're seeing a total of 50 for product 338. Now moving on to question 4, what we need to do now is unhide the product key field from our returns table. And we can do that using either approach from the data view or the relationships view. We kind of go in order to data. We're in our returns table here. I could simply right click and click the hide and report view to uncheck that option. Now you can see it's no longer grayed out here. Again, we could have also done that from the relationships view by right clicking the field itself and choosing this second option. Now if we return to report and get rid of product key from the lookup, which yields correct values, go into returns, grab that version of the product key, which is now visible, and pull that into rows. Now we see that issue with our order quantity values. So that same grand total, 84,174 in every single row. And remember, the reason why that's the case, and sometimes it's helpful to visualize this, is that we created filter context by using product key out of this returns table. Since that filter context can't pass upstream against the direction of the arrow, it can't transmit up to the product lookup table and therefore has no possible way to get to the AW sales table, since that's the only possible path between returns and sales. So as a result, the data here in the sales table, the values of order quantity, have no idea that you just filtered anything in AW returns. Therefore, it knows nothing but to return that same grand total unfiltered value over and over and over again. So here's where things get a little bit interesting. Let's actually edit this relationship between AW returns and product lookup. And what it asks us to do here in the second part of question 4 is to change the cross filter direction from single to both. And when we press OK, we'll see the little arrow icon convert from a single arrow to a double arrow. Now we have a two-way relationship between returns and product. And now returning to our matrix, we see what appear to be correct versions of this order quantity field, or these values. So the reason why we no longer see duplicates here is because we've essentially enabled the filter context from filtering down here in the returns table to transmit up to the lookup, which is then able to pass down to sales. So now sales has some insight into what you just filtered in the returns table because we've kind of allowed that filter context to escape. It's no longer trapped in that returns table. We've given it an exit through this relationship to product lookup. But before we celebrate, let's talk about product 338 again, which if you remember in question 3, we saw that it generated 50 sales or 50 orders. So let's go down and look for 338. And as you can see, we jumped from 336 to 340. It's completely missing from the table. So what is going on here, right? And this gets back to our whole word of caution, word of warning about using two-way filters. So remember, when we created that filter context by filtering product keys in the returns table, we passed along that context to the AW product lookup table, but that context, that filter information, only included territories that appeared here in the returns table, only territories where a return was recorded in the data set. So as a result, product number 338 no longer exists because it's been filtered out as the context flowed up to the product lookup table. And as a result, as that context passes down to sales, product 338 is no longer even in the picture. So we've created a view that looks to be accurate, but it's invalid because we're missing some products that generated orders, generated sales, but did not show up in the return data set because they didn't generate any returns. So really fascinating stuff once you start to really dig in and understand what's going on. And that brings us to the final question in the homework. We've got to complete a few items for question number 5. And to do that, we're going to go back to relationships. First things first, we want to change this cross filter direction back to single or one way. So we can double click to edit, cross filter direction, single. Okay. And there you go. Now we've got our one way arrow. Next up, we want to hide the product key field in this returns table. I'm going to do it right here. Hide in report view. Boom, it's grayed out. We're done. Then update our matrix to show product key from the lookup table instead of the return table. Pull that out. And we've got our product table here, product key on rows. And we are done with the homework. So that wraps it up. That wraps up our data modeling section. I'd recommend that you do save some backup copies of this Power BI file elsewhere on your computer, but that just about does it. So next up, get ready to learn some DAX. All right, so we are in great shape so far. We've connected to our source data. We've wired up our entire data model. Now the only catch is that we're still pretty limited in terms of the metrics or quantitative values that we can analyze here. It's really just sales quantity and return quantity. So what we're going to focus on in this section is using Power BI's formula language, data analysis expressions, or DAX, to build out brand new calculated columns and measures. We have a lot to cover in this section, so let's dive in. All right, time to officially meet DAX. Now, DAX, otherwise known as data analysis expressions, is the formula language that drives Power BI. So with DAX, you can add calculated columns and measures to your model using pretty intuitive syntax, and you can go well beyond the capabilities of those traditional A1 style grid formulas that you may be used to in Excel, using these powerful and flexible functions that are built specifically to work with relational data models like we're showing here in the AdventureWorks project. So there are two key ways to use DAX. Number one is to create calculated columns that actually live inside of your tables. And two is to create measures, which are used in your visuals. So we're going to dive into each of these in turn, compare the two against each other, talk about exactly how they're operating, and then dive into a bunch of the most common and powerful DAX formulas. So a lot to cover. Let's go ahead and dive in. So I want to start with calculated columns because they're a bit more user-friendly, a bit more intuitive, especially for people coming from an Excel background. So simply put, calculated columns allow you to add new formula-based columns to the tables in your Power BI file. A couple important things to note. Number one, there's no A1 style references. You can't point to cell D16 or cell B5. Calculated columns refer to entire tables or columns. Next, calculated columns actually generate new values for each row in the table, and those values are actually visible within your tables in the data view of Power BI. And then third, calculated columns understand something called row context. What I mean by that is that they can see the information in each row in which they calculate, and so they're great for defining things like properties based on information in that row, but they're generally useless for things like aggregation, like sums or counts or averages. So important note here. As a rule of thumb, you're going to use calculated columns if you want to stamp static fixed values to each row in one of your tables. Or you can also use the tools in the query editor to do the same thing in many cases. What you don't want to do is use calculated columns for aggregation formulas or to try to calculate numerical values to use in the values area of a visualization. We'll be using measures for that instead. So pro tip, calculated columns are typically used for filtering data, giving you new fields that you can use to create those filters, rather than creating or defining new numerical values. So let's walk through a couple quick examples. Here we've got two different tables, and in each case we've created a new calculated column. Now you'll note the DAX formula in the formula bar at the top, right above the table preview. And here in this top example, we've created a new calculated column that we've named parent, which equals yes if the total children field in that table is greater than 0 and no otherwise. And when you read through this formula in the top left, you'll notice that it looks very, very similar to Excel. So that same kind of user-friendly syntax. Now remember, since this calculated column understands row context, a new value is calculated in each row based on the associated value in the total children column. So what we're doing is cycling row by row by row, looking at the row context and returning the proper value based on the formula. So this is a valid use of calculated columns. Creates a new row property that we can now use to filter or segment any related data within the model. So we can grab that parent field, pull it into a visual, and break down our numerical metrics or values to compare data for parents versus non-parents. In this second example here, we're actually trying to use an aggregation function, in this case a simple sum of the order quantity field, to create a new column named total quantity. But here's the thing, since calculated columns don't understand filter context, and we'll get into that a bit more, the same grand total is returned in every single row of the table. So it doesn't matter which row you're in, whether you're calculating the value in row 1, 2, 3, or 4, in every single case, the sum of the order quantity field is the same sum, the same total. So this is not a valid use of calculated columns. We've essentially just taken that grand total and we've stamped it into the table in every single row. And in doing so, we've created this static column of numbers that can't be filtered, sliced, or subdivided any way. So for something like this, teaser alert, we're going to be using measures, the other important application of data analysis expressions. So let's quickly hop into our Power BI file and run through a quick demo for ourselves. Okay, so once you've opened up your AdventureWorks report, head to your data view and click on the sales table. Got my order quantities. And if you'll remember that earlier in the course, when we covered the query editor, we used that conditional column tool to create a new column called quantity type that was based on the order quantity here. So any rows where the order quantity was greater than 1, quantity type took a value of multiple items. Otherwise, it took a value of single item. So I'm going to quickly show you how we could have created the exact same calculated column here using DAX, as opposed to using the tool within the query editor. So again, one of those common themes that we'll see time and time again, multiple approaches to solving the same problem in Power BI. So what I can do is right click, add a new column, and right up here in the formula bar is where I'm going to write some DAX. Don't worry about the syntax quite yet. We're going to dive into exactly how DAX formulas are written and then do a ton of demos with some of the most common functions. But for now, the focus is really just on when and why to use calculated columns instead of measures. So for the sake of example, we can name this quantity type equals, and now start typing our function. And in this case, we're going to use an if function. So if, and I'll start typing the name of the column. DAX uses something called IntelliSense, just like Excel formulas autocomplete. It provides a list of my options dynamically as I'm typing. In this case, I want AW sales order quantity. Just double click to lock it in. So if order quantity from my AW sales table is greater than 1, comma to my result if true, which is multiple items in quotes, comma again to my value if false, which is single item. Close the parenthesis, press enter, and that will lock in my new quantity type column here. So again, same exact logic that we used when we created this column in the query editor, except this time we've done it on our own using DAX. And if we scroll down, we see our single type items here, and then we've got some multiple type item categories where the order quantity is greater than 1. So it seems to check out. That is a valid use of a calculated column. Now, if we were to add another calculated column, new column, and this time name it something like total quantity, and give it an aggregation function like the sum, of AW sales order quantity, and enter that. Just like we showed before, we get that exact same duplicate total stamped on every single row, because in this case, the row context is meaningless, and the sum of that quantity column is always going to return that same grand total of 84,174. So again, let's delete it. This is not a valid use of calculated columns. What we want to use instead for something like that is a DAX measure, which we're going to talk about now. All right, next up we have the incredibly important topic of DAX measures. Now, by definition, measures are DAX formulas that are used to generate new calculated values. So a couple important things to note about measures. Like calculated columns, they reference entire tables or columns. So again, no A1 style or grid references like you would use in Excel. But unlike calculated columns, the measure values aren't actually visible in your tables. In fact, you can only see measure values within a visualization, like a chart or a matrix. So for those of you with Excel backgrounds, think of measures the same way you'd think about a calculated field in an Excel pivot. That calculated field doesn't exist anywhere else. You can't see it in tables. You only see it within that Excel pivot table itself. Now, measures in Power BI operate the same way. You can only see them when you drag them into the values field of a visualization. So while calculated columns were evaluated based on row context, measures are evaluated based on filter context. It's a little bit of a tricky concept to wrap your head around, but what I mean by that is that these measures, the values they take, constantly recalculate whenever the fields or filters around them change. So if you drag a new field or dimension into the row or column labels of a matrix, or if you apply new filters to your report, in each of those cases, you're changing the filter context and you're changing the value that that measure should return. So to summarize, as a rule of thumb, you're going to use measures, not calculated columns, when a single row isn't going to be able to give you an answer. In other words, when you need to aggregate. And a pro tip for remembering this, remember that measures are used to create numerical, calculated values that you can analyze in the values field of your report visuals. So if we actually look at the report pane in our AdventureWorks file, you'll see that we've actually already been using measures. We just didn't know we were using them quite yet. And the way we used measures was simply by dragging those fields into the values pane here. And you'll note that this little arrow tells us that we're looking at the sum of this particular numerical field, order quantity. And what we've done is actually create an implicit measure by doing that. So we're going to talk about implicit versus explicit measures in a bit, but check it out. You've already got a head start on understanding how measures work. So with that, we've done our intro to measures. We've done our intro to calculated columns. Let's take a minute to compare the two side by side and then move on and get a little bit deeper into how DAX really works. Let's take a minute and walk through a quick recap of calculated columns versus measures in one place. So on the calculated column side, these values are calculated based on information from each row of the table. They have row context. Measures are calculated based on information from filters in the report. They have filter context. Calculated columns actually append static values to each row in the table, and it stores them in those tables within your model. This increases the file size. Measures, on the other hand, don't create new data in the tables themselves. Therefore, they don't increase file size in your model. Calculated columns recalculate on data source refresh or whenever changes are made to the component columns in the calculation. Measures recalculate in response to any change to filters within the report. In other words, any time that filter context changes. And then calculated columns are primarily used for things like rows, columns, slicers, or filters. You often use them as dimensions to change the way you're viewing your data, whereas measures are almost always used within the values field of a visual. So when you create calculated columns, they live inside of the tables, and when you create measures, those measure values live within the visuals. So there you have it, quick cheat sheet for calculated columns versus DAX measures. So a quick note about adding calculated columns and measures to a Power BI file before we actually get our hands dirty and start creating some of our own. There are two options for adding columns and measures. Option 1 is to select either new measure or new column from the Modeling tab, and option 2 is to actually right-click from within the table in the data view or the field list, which is available in either the data or the report view, and choose to add a new measure or column from that menu. Now, there actually is an important difference between the two approaches. When you insert columns or measures using the Modeling tab option, they'll be assigned to whichever table is currently selected, or the first table in the field list by default. Now, when I say assigned to a table, I basically just mean this field that we're creating, it has to live somewhere. It has to be organized somewhere within our data model, so we can determine what its home table should be. So for instance, measures that are related to sales would likely go into our sales data table, whereas calculated columns related to customers might live in our customer lookup table. It's purely an organizational tool, no impact on actual functionality. Now, if you accidentally insert a measure from the Modeling tab and it gets placed or assigned to the wrong table, not a big deal at all. You can easily reassign those measures or columns to new home tables using the properties options within that Modeling tab. But going with option 2, actually right-clicking within the table or the field list, lets you be a little bit more deliberate about placing them. So that's the approach that I'm going to use and that I would recommend that you use as well. Now on the right side of the screen, you'll see a third option there called New Quick Measure. Now when you select the Quick Measure option, you'll see this big dialog box show up with a bunch of calculations and a new field list embedded in that dialog box. And what you've got here are basically like recipes with different calculations to perform different types of analyses. Average per category, weighted average per category, difference from filtered values, time intelligence, and so on and so forth. So the way I think about these is that they're basically pre-built formula templates that kind of help you drag and drop fields rather than actually writing any DAX from scratch. Now, if you've taken any of my other Excel courses, you've probably realized that I hate stuff like this. I feel like these types of tools, they can be helpful in certain instances, I'll give it that, but generally speaking, they kind of just encourage laziness. So they're almost like a crutch that people use to avoid actually learning and understanding the fundamentals of DAX. So if you're in this course learning from me, this is a no shortcut approach. We're just going to say no to quick measures from now on. So there's your summary for how to add columns or measures. Next up, we're going to compare implicit versus explicit measures and practice writing our first true measure in our AdventureWorks report. So I hinted at this a little bit earlier, but I want to take a minute to unpack this idea of implicit versus explicit measures. Now in Power BI, in the report view, implicit measures are created when you drag raw numerical fields like order quantity from our sales data table, into the values pane of a visual. Now what Power BI does is automatically select and apply an aggregation mode, usually a sum, so that you can view those numbers, those values, in a meaningful way. And that's exactly what's been going on with all of the values that we've been looking at in the matrix views that we've built. Now on the other hand, explicit measures are created by actually entering DAX functions, or which we're not going to do, quick measures, to explicitly define calculated columns or measures. So very important difference here. Implicit measures are only accessible within the specific visualization in which they're created. You can't reference that sum of order quantity anywhere else. Same exact idea as a calculated field in an Excel pivot table. It can only be accessed and analyzed in that place. But what's great about explicit measures is that they can be used anywhere in the report once you create them, and referenced within other DAX calculations to create more complex formulas, or something that we call measure trees. So for instance, if we wanted to take the sum of order quantity and then nest that within another function, like total orders minus total returns, to come up with net orders or something similar, we would have to create an explicit measure in order to access those component values. So let's jump into Power BI and I'll show you what I mean. All right, so we're back in the report pane of our Power BI AdventureWorks report, just like we left it. And here we're looking at order quantities and return quantities by product keys. And now again, if you look at the actual details, you'll see that it's defaulted to an aggregation mode of a sum in both of these cases. And that's kind of the standard behavior when you drag in a numerical field like this. So let's get rid of return quantity, but keep this version of order quantity in here. I'm just going to drag this closer. And now the idea is that I want to create a proper explicit measure to capture that same idea, that same sum of order quantity. But I then want to be able to use and access that sum in other measures and calculations down the line. So I'm going to show you a couple approaches like we talked about. Number one, I could go into modeling and click new measure. And you see what happened when I did that? It created a new line item, a new field for this measure, and it placed it in the AW calendar lookup table, since that's the first one in our field list. And I'm trying to create a measure related to the sum of order quantity. So it doesn't make any sense whatsoever for that measure to live in the calendar lookup, which is why I don't recommend using that approach, using the modeling tab to create your measures. So instead of even typing it in here, I'm going to go ahead and X out, which just cancels that. And instead, I'm going to right click on the sales table or anywhere within the sales table. And I'm going to choose new measure from that menu. Now it's added the measure, assigned it to the sales table where it makes a lot more sense to live. So to define this, I'm going to give it a name. Let's call it quantity sold. And it's okay to use spaces in measures. They're always going to be reflected in formulas surrounded by brackets. So in this case, spaces don't really have any negative impact. And in fact, they can often make them a bit more readable. So we're going to do quantity sold with a space equals the sum of the order quantity column. And again, this IntelliSense, this autocomplete functionality is really user-friendly. So I'm just going to literally start typing order. And I see that there are 4 columns within the AW sales table that begin with order. And we want order quantity. So I can either arrow down and tab, or I can click and then double click again to lock it in. So it's really as simple as that. The sum function has one argument, it's the column name. So I can close the parenthesis and press enter. And now looking over at our field list, it's created a new field here called quantity sold. Now let's grab that, pull it in right under our order quantity, and you'll see that it returns the exact same numbers, which is good. That's exactly what we want here. But again, the first version, the implicit version of this sum, cannot be accessed outside of this visual, whereas the measure version of the sum, which we've named quantity sold, can. And that's what makes it way more powerful and way more flexible. So one of the best practices that we're going to talk more about is to create explicit measures even for very simple things that you could define with the auto aggregation available implicitly. Getting in the habit of using explicit measures will only make things easier for you down the road. So there you go. That's a simple example of creating our first true explicit measure. If we did want to move or reassign that measure, this is where you do it. This little properties group in the modeling tab, you can just click the home table and assign it somewhere else. In this case, it makes sense to live in the sales table since we're aggregating a sales specific field. And you'll probably notice that you're seeing different kinds of icons next to the field in the field list. The one that we just created, the measure, has a little calculator icon next to it. That's always going to be your indication of a calculated measure, whereas the order quantity has that sigma symbol next to it because it's a raw numerical field. And you also have a different icon with a little FX, looks like a small table, that indicates a calculated column. So we have all three types here within our AW sales data. So there you go. That's your first explicit measure. Congratulations. All right, so we've talked quite a bit about filters in the context of our data model and how filter context can transmit through table relationships. But now we're going to talk about filter context and how it impacts DAX measures. So remember the definition of a measure. It's evaluated based on filter context, which means that those measures recalculate whenever the fields or filters around them change. So consider this matrix view on the left side of the screen. If we pinpoint one cell out of that matrix, we can understand exactly what filter context is being passed to that cell and therefore understand exactly how that measure is being calculated. So for this particular highlighted cell, we're calculating a measure called total orders, and it's evaluating based on the following filter context. The product name column from the product table is equal to touring tire tube because that's the filter context passed to this cell from the matrix row labels. So this is pretty intuitive on the surface. This allows the measure, the total orders measure, to return the order quantity for each product specifically, or whatever the matrix row and column labels dictate. That could be years, could be countries, product categories, customer names. So again, pretty straightforward, but what might not be quite so straightforward is the fact that total or grand total values are not simply calculated by summing the values above. They're calculated as their own unique measures with no filter context. So in this case, since we aren't calculating orders for a specific product in the total row, we're essentially taking that filter context of product name and ignoring it. So it's a nuanced concept, but a very important idea, which is that each measure in a report behaves like its own island and calculates according to its own unique filter context, even totals and grand totals values. So as I was learning about filter context for the first time and really digging in and trying to wrap my head around what it really meant, what was most helpful for me was working through a number of different variations of examples. So let's take a minute to do that right now. Here I've got a sample view of a dashboard. This is a piece of a dashboard that we're going to be building in the next section of the course. And obviously you've got a lot of information here. You've got a matrix on the left, you've got donut charts, combo charts, tree maps, etc. One thing to pay attention to is this report level filter in the lower right that says year is 2016 or 2017. We're going to talk all about what those filters mean and how they work, but for now, all you need to know is that this filter applies to every visual and every number that you see on this entire report. So from here, we can actually pinpoint individual measure values to understand what filter context is being passed to them. So for example, this first case in the top left, we're evaluating a measure named total revenue. The filter context is that year equals 2016 or 2017, and that the full name from the customer table equals Mr. Larry Munoz. So with that filter context in mind, the DAX calculation for the total revenue measure evaluates and spits out the result that we see here. In this case, it looks like about $10,852 of revenue. Let's look at another example here. Now we're not looking at an actual numerical value, we're looking at a component of a chart, which is built from a value. In this case, this is a donut chart that's tracking total orders by gender. So the measure driving this segment of the donut chart has filter context of year equals 2016 or 2017, because remember, all visuals, all charts, all numbers in this report will be subject to that report level filter. And then the second piece of the filter context is that gender equals F for female. Similar case here, we're evaluating total orders again. Got that same 2016, 2017 filter context. The only difference is that this chart is breaking down orders by occupation. So in this particular highlighted cell or segment of the donut, the second piece of filter context is that the occupation field in the customer table equals clerical. Moving down to the bottom left, here's an interesting one. In this case, we're looking at the total row for a measure called total orders. So even though this value lives in a matrix that's broken down by customer names, because this measure, this little island cell, needs to calculate the total, we're basically calculating orders in the absence of a filter, with the exception of that one page level filter that applies across the board. So that number, 22,534, reflects the total orders as defined by the measure formula for 2016 or 2017. Moving along to this trended view, where we've got columns capturing total orders and a line capturing total revenue by month. In this case, this highlighted column here, it's capturing total orders, years 2016 or 2017, and month from the calendar table is August 2016. So this one's a little bit interesting because you've got two different filters from the calendar table being applied. And in cases like this, it's the more specific filter that's going to take priority. Now, last example, looking at this card visual in the report. In this case, this number is acting almost like a grand total. There are no row labels or column labels or chart axes or visual level filters that would be impacting the value shown here. So what we're looking at is just the total revenue measure subject to those report level year filters. So hopefully these examples are helpful. I imagine that you're thinking to yourself, pretty straightforward, pretty intuitive. But the thing is, it does get a bit more complicated and a bit more interesting, to be honest, because these aren't static views. These are interactive, dynamic dashboards and visuals. And what I mean by that is that users can drill into components of this report and components of these visuals in order to drill in and explore this data in different ways. So you could drill in and isolate a specific row in a matrix, or drill in to filter down to a specific segment of a chart. And when that happens, more filter context is essentially being added to every single measure shown on the report. So what that means is that the context that we see here that we've listed out, this is just a snapshot at one particular point in time. But if this donut chart, for instance, that breaks down order by gender was configured to interact with all of the other visuals in this report page, then that means that a user could potentially click on the female segment and add a new context to every one of these other measures that we've called out, as well as every other measure in the entire page for customer gender equals female. And if that user then drills deeper into a particular income level segment, that adds another line of filter context to every measure on the page. So as you can see, it can get quite a bit more sophisticated and quite a bit more complicated. That's why it's really important for us to nail down these fundamentals and understand exactly what's going on. So we're going to talk through a number of examples when we start writing DAX functions in the second half of this section, and then this will come into play in a number of different ways in the final section of the course when we actually start building visuals and reports. So stay tuned, some great stuff ahead. All right, so we talked about filter context, and we talked about how measures evaluate based on that filter context. But it's time to take a peek under the hood and try to learn about how this actual engine works. How are these specific measure calculations happening? So let's consider a simple matrix view like this. In this case, we're evaluating a total returns measure based on category names. And what we want to figure out is how this particular cell, this accessories returns number of 1,115, is calculated. So what I'm about to show you all happens behind the scenes, and it happens instantly every time the filter context changes. So I like to think of it as a three-step process, where step one is when the filter context is detected and applied. So this is where Power BI looks at the filter context for that particular value and says, okay, I'm being asked to only care about rows where the category name in my product table equal accessories. As a result, that product table gets filtered down to the point where you're only left with accessories rows. And from there, we move into step two, which is where that filter context of category name equals accessories flows to all downstream related tables. So if you had a model like this, where that product table were connected to two data tables, sales and returns, you would see both of those data tables filter down accordingly to only the product IDs where the category equals accessories. So you end up with filtered down versions of both of those data tables as well. And that brings us to step three, which is when the measure formula actually evaluates against that filtered table. So the measure that we're looking at here, what it's essentially doing is it's counting the rows in that returns data table, but not the whole thing. It's counting the rows of the filtered down version where the product category is accessories. And as a result, the number of rows that exist after the filter context has been applied is 1,115. So I'd recommend keeping this on hand just as a helpful reference in those cases where your measures might not be calculating as you expect them to. So with that wraps up the high level kind of conceptual part of this section of the course. From here, we're going to move into DAX syntax, operators, common function categories, and then get hands-on with a bunch of different examples. Okay, time to shift gears a little bit and shift our focus towards understanding the language of DAX. And we're going to start with the core syntax. So consider a simple sum function like this. Let's break this down into its component parts, starting from the left. In gray, we have the measure name. And like I mentioned, measures will always be surrounded by brackets when referenced in formulas, so having spaces here is okay. Now the next component immediately following the equal sign is the function name. Now, interesting note here, calculated columns don't require functions, but measures do. So a calculated column could have what's called a naked reference, meaning it points to a column on its own, not an aggregated version of that column. And that's okay because calculated columns evaluate row by row by row, so you could create calculations for things like discount price, like we practiced in the query editor, where you're essentially taking the value from another column, like retail price, and applying some sort of operation against it. On the other hand, you can't do that with measures. If you try to define a measure with a naked column reference, like transactions quantity, Power BI will return an error since it doesn't know how to translate that into a single value. So you need some sort of aggregation there. And then the last two components here are the table name in orange and the column name in blue. And this particular example reflects what's called a fully qualified column, since it's preceded by the table name. And like we talked about when we were working with the query editor, table names with spaces have to be surrounded by single quotes. So here's an example of what that would look like with or without a space. One piece of advice, pro tip here, when you're referencing columns, get in the habit of using the fully qualified name. So table followed by column. But for measure references, just use the measure name itself. That's a nice, easy way to differentiate column references from measure references within your DAX formulas. And there are some cases where that may not always make sense, but for the most part, that's a pretty good practice to follow. So moving on, let's talk about some common DAX operators. And most of these are extremely straightforward. You've got your basic arithmetic operators, addition, subtraction, multiplication, division, and exponents. Those pretty much speak for themselves. You also have your comparison operators, equal to, greater than, less than, greater than or equal to, less than or equal to, or not equal to. And I've shown some examples here as well. And then where it gets a bit more interesting is with the text and logical operators. And these ones are a little bit different from other formula languages that you may be used to. So one of the consistent ones is using the ampersand as a concatenation tool, where you can combine values to produce a single text string. But some of the newer ones are the double ampersand, which is an AND condition, or the double pipe, which is the OR condition. And on most PCs, you can find that pipe icon by holding Shift and pressing the key right beneath the backspace. And the fourth example here is called IN, which creates a logical OR statement based on an entire list contained within curly brackets. So, little hint, if you're only going to pay attention to a couple pieces from this slide, pay attention to these two, because these are going to come up a few more times with some of the formulas that we'll be writing. So from here, we're going to outline some of the most common function categories, then begin to add some new calculated fields to our AdventureWorks report. All right, last note before we shift into DAX demo mode, I want to lay out the common function categories. And most of these should look familiar to Excel users. These map pretty closely with Excel function categories, especially math and stats, logicals, text, and date and time functions. One area that is quite a bit different in DAX is the filter function section, which we'll dive into later in the section. But basically what we've got here in the math and stats category, your basic aggregation functions, your sum, max, min, average, count, etc., plus some interesting DAX formulas called iterators, which actually evaluate row by row. Sometimes those are called X functions because they all end in an X. Sum X, average X, rank X, max X, etc. And for Excel users, those work just like a sum product. More on that to come. Next up, we've got logicals, basically returning information about values in a given conditional expression. So these are all based around those if statements, if, and, or, not. There's a new one called switch, which is interesting. Then you've got very familiar text functions. These manipulate text strings, can also be used to control formats for things like dates, times, or numbers. And these should look very familiar as well. Concatenate or ampersand, left, mid, right. You've got capitalization rules like the ones we practiced in the query editor with upper, lower, proper, and then some useful options like substitute and trim as well. Now, filter functions, this is where things feel a little bit foreign and unfamiliar. These include lookup style functions based on related tables and table relationships in your model, and filtering functions to create more dynamic types of calculations. So the most common example of all is a formula called calculate, which we'll spend some time focusing on. The other ones that will really hit here are filter, all, and related, but tons of other options here as well. And then in the date and time category, you've got your basic date and time functions, as well as some advanced time intelligence operations. So your basic ones should look pretty familiar. Date diff, year frac, your component functions like year, month, day, or hour, minute, second. You've got volatile functions like today and now. And then time intelligence, this is really interesting. We'll do some cool demos there, like dates year to date, dates quarter to date, date add, and dates in period. These let you do some really interesting things like calculate rolling averages, year to date totals, and other date specific comparisons. So big caveat here, this that you're looking at here is not a comprehensive list. There are many other DAX functions, some of which are more advanced, some of which are more specialized. There's trigonometry functions, parent-child functions, info functions. So the ones that we're going to cover here are some of the most common and some of the most powerful, but this will not be a fully comprehensive review of DAX. The plan here is to get you started with the basics and hopefully give you a deep enough understanding that you can begin to explore some more complicated, more advanced scenarios on your own. So with that, buckle up. It's time to start writing some DAX. All right, time to kick off our DAX demos. Now we're going to start by focusing on calculated columns first, since they're a bit more user-friendly, a bit more intuitive, and we're going to kick it off with basic date and time functions. So here's what we're going to be dealing with. Now, all you Excel users, this should look really, really familiar. These basic date time functions are very user-friendly, really simple syntax, so this should be a breeze. Starting with day, month, year, I call these component functions because they essentially point to a date and extract some specific component of that date, the day, the month, or the year. So syntax-wise, incredibly straightforward. You just point it to a column containing your dates and you're good to go. Same thing holds with hour, minute, second. The only real difference is that you have to point to a column with a date time component as well, because what these hour, minute, second functions do is they ignore the date and only focus on the hour, the minute, or the second of the timestamp component. Now, today and now, those are volatile functions, which means that they update or refresh every time there's a workbook change, and those two functions return the current date or the current exact time, respectively. Syntax-wise, literally could not be simpler. This function doesn't even take a single argument. You literally open and close the parentheses, and you're all set. Now, weekday and weeknum, two of my favorite date functions here. Weekday returns a weekday number by default from 1 to 7, representing Sunday to Saturday, and weeknum captures the week number of the year. So for syntax, first argument is the date column, second argument is the return type, and this is where you can tell Power BI exactly how you want your weeks to start, whether it's a Saturday, a Sunday, a Monday, etc. Now, EO month, another really helpful one. I believe it stands for end of month because it returns the last day of the month, plus or minus a specified number of months. So here's what the syntax for EO month looks like. You point to a start date, and then you specify that number of months. So if you use a 0 for the second argument here, the EO month function will essentially give you the last date of that current month. If you use a -1, it would give you the last date of the previous month, and vice versa. Now, a little pro tip here, even though it's a bit of a misnomer, you can use the EO month function to return the beginning or the first of the month as well. I don't believe Power BI or Excel have any first of month equivalent functions, but what you can do is set that month's argument to -1 and then simply add 1 day, so +1, at the very end of the function. That basically calculates the last day of the previous month and adds 1 more day to give you the first date of the current month. And then last but not least, we've got date diff, returns the difference between two dates, but not only that, but it allows you to select a specific interval as well. So date 1, your start date, date 2, your end date, and your interval, which gets as granular as seconds or as broad as years. So a really helpful function for calculating the difference between two dates. With that, let's open up our AdventureWorks file and start adding some new date and time columns to our model. All right, so once you've opened up your AdventureWorks report, let's navigate to the Data tab. This is going to be kind of our home base for the next few videos as we create these calculated columns and measures to our model. And now make sure you're following along because we're going to be creating new fields, new measures that are going to be important for us to analyze and visualize once we get to the next section of the course when we start building reports and dashboards. So pay close attention, try to follow along step by step. Now the first demo that I'm going to use is the weekday function. So I can right click anywhere inside this table, really doesn't matter where, select new column, and it'll just tack that column right to the end of the table. So let's go ahead and name this day of week, and we're going to use the weekday function here. So as we start typing, you'll see that not only does the formula or function name populate, but a description populates as well. So really helpful tooltips and IntelliSense functionality that Power BI offers here. So I could tab to lock that in, and it takes me right to the first argument, which is the date. So let's go ahead and start typing to find that field. You can either type date, which gives us the option there, or we can type calendar to navigate to the table. Either way, it helps us find it. And then again, I can tab or double click to select that field. And now with date field specifically, this additional list of options appears. .date, .day, .month, and so on all the way to .year. And this is Power BI being pretty slick. It's saying, okay, I see that you selected a date field because it knows that calendar lookup date is formatted as a date. And it's giving us the option to either use the actual date itself by default or to use some aggregated component of the date like the month or the quarter or the year, just like those day, month, year functions actually work. But it's kind of embedded in here, which is pretty clever. Now, I don't have to select any of these options, or if I select .date, it would be redundant, but basically the same thing. In this case, I want to reference the actual date itself, so I'm just going to press comma, and it takes me right to the next argument of the function. Now remember, this is the optional component. The return type, you can see that it's optional because it's shown in brackets in that tooltip. And my options are 1, 2, or 3, where 1 is a week starting Sunday, 2 is a week starting Monday, and 3 is another week starting Monday, but from 0 to 6 instead of 1 through 7. So I kind of like defining my weeks starting on Mondays. So let's enter the 2 here, close the function off with a closing parenthesis, and then press enter to lock that function in. And there you go. You see we get 1s through 7s, where 1s are my Monday rows, 7s are my Sunday rows. So there you have it, pretty straightforward demo of the weekday function. Next up, let's actually collapse the calendar and navigate to our customer table. I'm going to scroll all the way to the right here. And you'll remember we have this birth year column, which we had actually calculated within the query editor. So we don't see any kind of DAX formula here, even though that was technically a calculated column. So what I'd like to show you is how we can create that same birth year column using DAX and then remove the original. So again, right click anywhere in the table, new column. I'm going to name this one birth year underscore CC for calculated column, just so that we can compare the two side by side and differentiate them. So birth year CC equals the year of the customer lookup birth date column. So I'll tab to lock it in, close the parenthesis, and press enter. And now when I scroll over, there it is, birth year CC against the original birth year. It all lines up, which is good. And you may have been wondering, can't we use that shortcut Power BI tip that automatically extracts the year without even writing a function? Well, yes, you're very sharp. You sure can. Let's go ahead and edit this, and I'll show you how to do this exact same calculation using a different type of approach. So instead of using the year function explicitly, what if we just point to the birth date field and then use Power BI's tip and say, just give us the birth date dot year, or just the year component of that date field. Press enter, scroll on over, and what do you know, gave us the exact same correct values. So it's technically a third way to accomplish the same thing, calculating the birth year using the query editor or using both of those DAX or function approaches. Now, I want to show you one other interesting thing, which is obviously we don't need 2 birth years here in this table. So watch what happens when I right click and delete the birth year column. Okay, so remember that birth year column that I just deleted, that column was added, it was calculated in the query editor. So there was an applied step that added that calculated column to the table. So now what you might be wondering is, every time we refresh this customer table, isn't that birth year column just going to keep appearing and appearing and appearing? And the answer, luckily, is no, because Power BI is very smart. Let me go to Edit Queries and navigate to that customer table, and check it out. It removed the birth year column as a new applied step so that it's not going to keep recreating that column. It knows that we just deleted it from the table itself in the Data tab, and so it saved us the trouble of having to delete it over and over and over. Now, the last date time demo that I want to show you, a formula to calculate the current age of our customers. So let's stick right here in our customer table, and for this one, let's practice the date diff function. So let's right click, new column, We're going to name this one current age equals, and we're going to start with the date diff. I'm going to arrow down and tab that one in. And now remember, 3 arguments: date 1, start date; date 2, the end date; and interval. So our starting date is the customer's birth date. So there it is, customer lookup birth date. I don't need any of these time components here. And then the date 2, the end date, is going to be the current date. So I'm going to use the today function, open close parentheses for that one, and then comma to my last component, the interval. And this says, okay, by default, I'm going to return the number of days between the 2 date arguments, the start date and the end date. In this case, we're looking for the current age in years, so we can just scroll right down to year, press tab to enter it, close the parenthesis, and press enter. And we scroll on over. There you have it. We've got current ages, 70, 69, 67, and so on and so forth. So great way to use the date diff function in that example. And now just for fun, I'm curious, if we change that last interval component, I wonder how many seconds old these people are. So you can close it off, change year to second. And there you go. It looks like our first customer here, Blake Flores, is just under 2.2 billion seconds old, which is not very helpful for the purposes of our analysis. And I don't think our AdventureWorks clients are going to care much about that, but kind of interesting to see. So let's go ahead and change that back to year, close it off, press enter, and now we have more appropriate ages there. So there you have it, just a little sampling of some of those basic date and time functions. We practiced weekday, today, and date diff. Next up, we're going to talk about logical operators and some conditional if, and or statements. Stay tuned. Next up, we've got basic logical functions. These are your if, and or types of statements. We're going to be looking at 4 of them here. Now, starting with the if statement checks if a given condition or logical test is met and returns one value if that condition is true, another value if the condition is false. So the syntax looks like this. There are 3 arguments, starting with the logical test. This is any Boolean test, meaning anything that results in a true or a false. It could be text-based, like country equals USA, or it could be numerical, like weekday equals 1, or retail price is greater than 10. All of those are valid logical tests because they all evaluate to either a true or a false. Now from there, our second argument of the if statement basically says if that logical test is true, what value would you like to return? And then that optional third argument allows you to customize the result if that logical test is false. Otherwise, those rows will just show up as blanks. Next up, if error. This one evaluates a value or an expression and returns a value that you specify if the expression returns an error. Otherwise, go ahead and evaluate the expression just like you normally would. So it's a little bit wordy, sounds more confusing than it really is, but basically all you're doing is you're saying, if you get an error when you run this value or expression, instead of showing or displaying that error, display some custom value instead. Keep in mind that those errors can be very helpful and tell you some important information, so use it cautiously, but can be a great tool. Next up, we've got and it kind of speaks for itself. It checks whether 2 arguments are both true and returns true if that's the case, otherwise false. So syntax looks like this. You just plug in 2 arguments, 2 logical statements. Or is very similar, except instead of checking whether both arguments are true, it checks whether one of the 2 arguments is true. So same syntax, just using or instead of and. Now, important note about these two, I told you this was going to come up again. If you use the and or the or functions, you're limited to 2 logical statements. If you want to compare more than 2 statements or 2 conditions, you'll have to use either the double ampersand in place of and or the double pipe in place of or. Now, My tip for you is that using those symbols, the double ampersand, the double pipe, not only gives you more flexibility to work with more than two logical statements, but it's also a bit more readable when used in the middle of a function. I'm going to show you exactly what I mean in just a second. So that's actually a nice segue. Let's go ahead and pop into our AdventureWorks file and try writing some of these logical functions. All right, so once you have your file open, make sure that you're in the data view. And first things first, we're going to go into our customer lookup table, which I'm in right now. And the first thing we're going to calculate, just like the demo we saw earlier in the course, is a parent column. And the parent column will be a logical or conditional statement that looks at this total children field. And it says, all right, does this customer in this row have children? In other words, is the value in that column greater than 0? If so, we're going to call this person a parent. Otherwise, we're not. So great opportunity to use a simple if statement for that column. Let's go ahead and right click and add that new column. And let's actually just name it parent. This will be kind of a yes/no binary flag. And parent is going to start with an if. So if, and we're looking for a field with the word children. There it is, total children. Tab it in. So if the total children column from the customer lookup table is greater than 0, that's a valid logical test because it evaluates to only true or only false. Then I'll comma to my result if true. This means they have children, which means they are parents. So I can type yes in quotes because it's text, and then comma to my result if false. Remember, if I leave this blank, I'll see only yeses or blanks in the parent column. But instead of that, I'd like to use a no for the result if false and close the parenthesis. So when we hit enter to lock that in, you see that it's calculated. We scroll to the right, and there we go. We've got our parent field here. And if we scroll down, there's some no's where total children equals 0. So all looks good. There's your simple if statement. Next up, I want to calculate a column in our calendar lookup table. So let's head over there. And now the column that I'd like to add here in our calendar table is a column for weekend, which identifies weekends based on the days of the week. So we're going to use an if statement again, but now we need to integrate or as well, because a weekend is defined by day of week equal to 6 for Saturday or 7 for Sunday. So let's go ahead and see what that would look like. Right click, new column. We're going to name this weekend. And I'm going to start with the if or combination first. So we're going to lead with if, open the parenthesis, and now the logical test is where my or statement comes in because I have two conditions that I'm testing for. And syntax-wise, it reads a little bit strange, but instead of writing condition 1 and then the word or and then condition 2, I have to actually lead with the or here as well. So if or, and the same thing works with if and, where you now enter both of your logicals just separated by a comma. So if or, now my two logicals. The first one is looking for day of the week. So AW calendar lookup day of week equal to 6. No need for quotes there because 6 is a value, not text. And then comma to my second logical statement. Same idea. Calendar lookup day of week equal to 7. And my or statement is now complete. I've entered both logicals there. So I close the parenthesis to close out my or statement. And now I'm back in my if function. So I'll need to comma over to my result if true. So if either of these two logicals is true, day of week is 6, day of week is 7, then what value do I want my weekend column to take? Let's call it weekend. And then comma to the last statement, result if false. Rather than having non-weekend days show up as blank in this column, I'd like them to be labeled as weekday. Close quote, close parenthesis. You can see that it's highlighted my first parenthesis to tell me that I've closed out my whole statement, and that formula should be good. So let's press enter. And there we go. We see weekday, weekend for day 6, 7, Saturday, Sunday, all checks out. So that worked out pretty well. Now, just for the sake of demonstration, and because I actually prefer this approach over the one I just showed you, let's replace the if-or approach with the double pipe or instead. And so I'm actually going to delete this and write it from scratch just so we get a little bit more practice. So we're back to just our if. And this time I can actually write it in a readable way. So first logical test, if calendar lookup day of week equals 6. And now one thing to note, you can add spaces throughout the formula. So if that helps to space out the arguments or components, feel free to use those. And I'll try to do that just to make it as user-friendly as I can. So that's logical test 1. And now I'm going to hold shift and press that pipe under my backspace key and use 2 pipes in a row, which basically does the same thing. It serves the same purpose as an or statement, but I can insert it right in line between 2 logicals, or 3 or 4 or 5, etc. So if the day of week equals 6, or lookup day of week equals 7, and I can just comma since I didn't open up a new parenthesis with an or statement. Now I'm in my result if true as part of my if function. So if either one of these is true, weekend, otherwise result if false, weekday. Close quote, close parenthesis, enter, and there you go. Just refreshed, no values changed, we didn't expect them to. Which approach you use is totally up to you. If you're more comfortable with if or, that's fine. If you like using the double pipe, that's cool too. And just note the same exact logic applies if you're using and statements here. You could write it as if and, or you could write it with the double ampersand, just like we use the double pipe. So there you have it, calculated columns with basic logical functions. Next up, we've got text functions. Now, this is another set of functions that looks and feels almost identical between DAX and Excel. So those same left, mid, right functions, those same upper, lower, proper capitalization functions, same substitute, same search. So hopefully many of you are already pretty comfortable with these formulas. So let's quickly kind of breeze through these. Starting with length, returns the number of characters in a string. Simply point it to a column containing text and you're done. Concatenate joins 2 text strings into one. Note 2 and only 2. This behaves very much like the and or statements that can only take in 2 logicals. When you write out concatenate as a full function, you're limited to just those 2 text inputs, which is kind of silly and obviously restrictive, especially after going through all the trouble of typing that full concatenate function. So just like you can use the double ampersand to replace an and statement and give you more flexibility with logical statements, you can use the single ampersand to replace concatenate and allow you to combine many more than 2 strings. So when you think about it that way, I don't know why anyone would ever use the traditional concatenate function, because it's inconvenient to write and it's extremely restrictive. So best practice, just use the ampersand if you need to concatenate strings. Next, we've got some of my favorites, left, mid, and right. These allow you to return a number of characters from either the start, the middle, or the end of a string. Pretty simple syntax here. For left and right, you point to a text column and then indicate a number of characters. Note that that's an optional argument. If you don't put anything there, it will return 1. So 1 is the default number of characters. For mid, there's an extra argument. You point to the text. You say, I want to start in character position 4 or 5 or whatever position you want, and then extend or return a specified number of characters from there. Upper, lower, proper, all capitalization stuff. Upper is all uppercase, lower is all lowercase, proper is the first letter capitalized. Simple syntax, just point to a text column. Then substitute, this one's kind of fun. You can replace an instance of existing text with any new text that you choose within a string. So this one has a few more arguments here. You start by pointing to a text column. you indicate the old text, or the text that currently exists within that string, and then the new text is what you want to replace that with. And then you also have this fourth optional argument for instance number, where you can tell Power BI, okay, I want to substitute my underscores with a dash, but I want to skip the first one. In that case, you can specifically target only the second underscore, or only the third or fourth. So a lot of flexibility with that substitute function. And then last but not least, you've got search, which returns the position where a specified string or character is found. And by default, Power BI is going to read from left to right. So when you type this function, you're going to say, okay, I'm searching for this particular text string. That's the find text argument. And then within text is where you're looking for it. Generally, that's a column containing the original text values. And now those are the only two required arguments. So you may be wondering, okay, you're searching for certain characters or text within a string, but then if that's the end of the function, what is it going to return? And the result that the search function yields is a number, and that number indicates the position of the text if it finds it. So if, for instance, you said search for the word house within the text doghouse, that function would return a 4, since it found house starting in the fourth character of that larger string. Now you have two optional arguments as well. The start position, so you can indicate if you don't want to start at the very beginning of the string, you could, for instance, start 5 or 10 or 20 characters in. And then last but not least, you can indicate a value to return in cases where the characters or text that you're looking for isn't found. So let's jump back to our report and quickly try a couple of these out. All right, so in the report, head to your data view, as always, and let's go ahead and jump into our customer lookup table. Now, the first thing I want to demo is that concatenate function, and a great opportunity to do that is to replicate the full name, just like we created right here in the full name column using the query editing tools. This will be a good opportunity to show that we can do the exact same thing using a calculated column with DAX. So right click, you know the drill by now, new column, and let's name this one full name underscore CC for calculated column equals, and now remember the deal with concatenate. If I were to type out that full concatenate function, I would be limiting myself to only 2 inputs. And since I'm looking to concatenate or combine 3 fields here, the prefix, the first name, and the last name, concatenate is not an option. So I'm forced to use the ampersand, which is good news because I'd prefer to use it anyway. So all we're going to do is search for the first field we want, prefix, ampersand for concatenate. Now keep in mind, if I go ahead and just reference the first name right now, in fact, I'm going to do it as a demo, and then add another ampersand and reference the last name, and press enter. When I scroll over, it worked, did exactly what we asked it to do, but the problem is that all the names are just blended together. So we really need some spaces in there as well. So it's an easy fix. Jump back into our formula bar, and now we'll say, okay, prefix, and then before we go and add the first name, let's add a space. So open quote, space, another quote, and then another ampersand. We're going to do the same thing between first name and last name. So first name and a space. Whoops, sorry about that. And our last name. Press enter. And scrolling over. There you go. Full name CC matches with our original full name column. Another good example of 2 ways to do the same thing. Now I'm going to show you one more demo, and for this one we're going to go back to calendar, and what I'd like us to do here is come up with a way to return a short version of the month name. So sometimes people shorten or abbreviate the month name with just the first 3 characters. So this is a great way to use one of those text functions, in this case like left. So let's go ahead and try that. New column. I'm going to call it short month. And that's going to be as simple as left, because we want characters starting from the left of a string, and the text column that we're pointing to is the AW calendar lookup month name. And then comma to my second argument. Again, the default would be one character. In this case, we want 3. So type a 3, close the parenthesis, press enter, and there you go. We get Jan, Feb, March, June, Aug. Looks good. But now it turns out that our AdventureWorks client hates lowercase short months. It's his pet peeve. He just can't stand it. So he insists that these month abbreviations have to be all caps. So lucky for us, we've got an easy function to help us do that. That's the upper function, one of those great capitalization functions. So all we need to do here is essentially wrap this whole function that we just created that yields these lowercase, or in this case, proper case, short months, just wraps them in an upper statement and capitalizes everything. So I'm going to insert my cursor right before the left. I'm going to type upper, open the parenthesis, leave the entire formula as my text reference because it yields a text value that I can then convert to uppercase, close the parenthesis, press enter, and voila. Now we've got all capitalized short months, and AdventureWorks is going to be very excited to see that. So there you have it. A couple of quick demos of how to use text functions in calculated columns. So at this point, you may be wondering, why all the hype around DAX? All of these calculated column formulas that we've been playing with so far, the basic date and time, the logicals, the text functions, they're all pretty intuitive, pretty straightforward, and remarkably consistent with their Excel versions as well. So now that we've covered those basics, some of those fundamentals, it's time to start exploring some more interesting DAX functions. We're going to talk about one called related now. And in this context, I'm going to show you how to use related as a calculated column. And then later in the section, we're going to revisit this related function by nesting it within a SUMX measure, which is a really cool, really powerful iterator function in DAX. So this is where things are going to start to get a little more interesting and start to pick up pretty quickly. So related is a very simple function on its own. It just returns related values in each row of a table based on a relationship with another table. So syntax-wise, it's as simple as it gets. You literally just point related to a column name in another table that contains the values you want to retrieve. Could be a product name column, could be a retail price column, a country column, whatever it might be, as long as a valid relationship exists to that table where you'd like to retrieve the values. So tip here, related works basically exactly like a VLOOKUP function. It uses that relationship between the tables, which we've defined by our primary and foreign keys, to just reach into another table and grab the values it needs and pull them into a new column of another table. But the thing is, it works like VLOOKUP, but it's even simpler than a VLOOKUP because we don't need to define the lookup value or the match type or those other arguments that we need to include if we were writing a lookup in Excel. And the reason we don't have to define a lookup value explicitly is because Power BI already knows what your lookup value is because it understands the connection between your two tables. And that's why all you have to do is input the column name. Whereas in Excel, you're essentially defining what your primary key is within the VLOOKUP function. So here with related, because we've done all our data modeling already, that step is not necessary. One other note about related, this function does require row context because it needs to pull the correct value for each row of the table. So you'll only see related being used either as a calculated column, which I'm going to show you now, or as part of an iterator function that's designed to cycle through tables row by row. Things like filter, SUMX, MaxX, etc. Now, pro tip here, you may be thinking, okay, this concept makes sense, but isn't this kind of going against the normalization standards where we said we don't want to create redundant data like this? And yes, you're correct. Related does technically create redundant data, So it's important not to go overboard with related. You don't want to use this function to kind of hack your way into a huge merged table, but using it strategically to make certain fields more accessible is a valid approach as long as you're not bumping against file size or capacity limitations. That said, in many cases, you can actually replace the calculated column version of related by nesting it within a measure like filter or SumX. And I'm going to show you that with SumX in the iterator lecture, which is a really, really interesting one. So with that, let's pop back into our AdventureWorks file and try adding a new calculated column using the related function. All right, so when you open up your AdventureWorks report, head to your data view, and let's navigate to our sales table here. Now you may be realizing that so far we've been pretty limited as far as the numerical kind of quantitative values that we're able to analyze here. Really, order quantity and return quantity are the two most meaningful ones that we have access to right now. But we do have a means of creating many more interesting fields. And we're going to do that using related and using some of the measures that we'll talk about in the upcoming lectures. So for now, what I want to do is try to pull the retail price of these product keys into my sales table. And I can do that because related will allow me to access fields from any related table. And if we jump to our relationships view as a refresher, we know that sales has valid relationships to customer, to calendar, to territory, and to each of these product lookups as well. So what that means is that related is going to allow us to access any field from those lookup tables and pull it directly into a new column right here in my sales table. So that's what we're going to do here using retail price as an example. So let's right click, new column. Let's name the column retail price. You can add a space or not, up to you. And it's going to be as simple as related, and then point to the column name. And remember, I'm going to point to that column that lives in a related table. So the table that I'm looking for is going to be the product lookup. And here I can kind of just arrow down to look through my list of fields in that product lookup table. And the one we want is product price. So let's tab it in, close the parenthesis. That's the only argument. So we press enter and we're good. So there you go. We've got retail price. Right now it's not formatted properly. We can fix that in the modeling tab here. And we've got our formatting options. Don't have to go to the query editor. We can format right here in our data view. So instead of general, let's go ahead and choose currency, English United States, and that looks good. So as a quick QA, if we want to make sure that these prices map up to the retail prices in the product table, one quick way to do that, we could use a matrix view in the report, or we could do something like sort our product key here, ascending. So 214 has a retail price of $34.99. It looks like 215 has a retail price of $33.64. And now if we actually jump to our product lookup table and sort the product key ascending as well, now we can just make that comparison. The first row is product key 214, $34.99, 215, $33.64. So it checks out. And that's a nice little way to just do a quick spot check and make sure that related function is working properly. So back to sales. Now remember, we've essentially just pasted this data or replicated this data in a new place. It's nothing brand new, but this will allow us to now create some interesting new fields. For example, revenue. Let's right click, add a new column, name this one revenue. And now that within this table, we have quantities, we have prices, price times quantity equals revenue. So it's as simple as just multiplying those two columns together. So AW sales retail price times AW sales order quantity. We can press enter, and there you go. We've got our revenue. Looks like these are all quantities of 1, so the revenue is just equal to the retail price. And we can do a similar kind of spot check here and sort our order quantities. Let's actually sort descending. And there you go, 3 orders of a product that costs $23.55 yields a revenue of $70.65. So that looks good. This all kind of checks out. Let's go ahead and just for the sake of being consistent, let's format revenue as the same currency format as well. So there you go. We've used the related function to basically reach into the product table, grab the retail price, and pull it into a new column right here in our sales table. And from there, we use the values in that column to create a brand new field called revenue. So from here, we're going to shift gears a bit into measure mode, start with some basic math and stats aggregator functions, and then dive into some of the filtering tools that really set DAX apart. All right, so we've covered some of the core calculated columns with DAX. Now it's time to talk measures. And the natural place to start is with these basic math and stats aggregator functions. So usual suspects here, you'll see your sum, average, max, min, and a new one called divide, which I'll talk about in just a second. But these, for the most part, speak for themselves. Very straightforward. The sum evaluates the sum of a column. Syntax-wise, all you have to do is point to a column name containing values. Similar story with average, just returns the arithmetic mean of all the numbers in a column. Same syntax. Now for max, obviously returns the largest value, but you don't have to just point to a column. You could also feed a max function a list of scalar or specific values, and max will return the largest within that list. Same goes for min, exact same syntax, just returns the smallest value. And then divide, it performs division, but it also includes this alternate result, which is kind of like your value if error, kind of baked right into the formula. So numerator, denominator, alternate result. So really no surprises here. Let's spend most of our time in Power BI practicing some of these hands-on. All right, so I'm back in my AdventureWorks report, and keep in mind you can add measures in a number of different places. I could add them here in the report view, in the calculations grouping. I can add them anywhere I can see the field list, either report view or data view. Really doesn't matter where you add them. I generally like to add them in the report view because since measures won't actually be visible in our tables, the best way to QA and explore the values that our measures produce is using visuals like the matrix visual here. So let's get in the habit of creating our measures here in the reporting canvas. And like I mentioned earlier, rather than using the modeling tab, which sometimes assigns your measures to tables that you didn't mean to, we're going to also get in the habit of actually right-clicking the table itself or field within the table itself to deliberately organize where these measures are going to live. So to kick it off, I'm going to use the basic sum first, and there are two different measures that I want to create. The first is the quantity returned, or the sum of the return quantity from my returns table. So just like we calculated the quantity sold here in our sales table, we're going to calculate quantity returned in our return table. So again, I'm going to right click the returns table, this time new measure instead of a new column, and it basically just adds a placeholder right here in the formula bar that says measure equals. So this one will be named quantity returned, and it's going to be quite simple, just your basic sum. I'll start typing return. So there we go. AW returns return quantity. That's the numerical field that we would like to sum. And it's as simple as that. Close the parenthesis, press enter, and there you go. You'll notice that all it's done is create a new field assigned to my returns table with that measure. But the only way to see the result of that measure is to visualize it. Pull it into the values field of some sort of a visualization, whether it's a matrix or a chart. So for instance, if I wanted to add a third column here in the matrix we've got, I can just grab quantity returned and pull it in as a third column of values here. And because we're breaking down the data by product key, which our returns table is connected to, then this is a valid view. Now let's do a very similar example, except this time let's add one to our sales table. Right click, new measure, and we've got this raw revenue field, these revenue values in that new column that we created using related in the last lecture. So basically I just want to sum those up. I'm going to call it total revenue equals the sum of that AW sales revenue column, and press enter. So as a reminder here, you might be wondering, isn't that kind of a redundant step? Is that really necessary? Because I could pull total revenue into this matrix view, right? Or I could pull the raw revenue values from my table into that view as well and get the same answer. So was that measure calculation just an extra unnecessary step? And again, it comes down to this idea of implicit versus explicit measures. And what I just showed you in the second example with those raw revenue values, that was an implicit measure which can't be used anywhere else. Whereas my total revenue measure now can plug into other sorts of DAX calculations, like profit, for instance. So you'll note that it's not formatted as currency here. You can access formatting tools here as well, just by clicking the measure itself and then accessing those formatting tools here in the modeling tab, which you saw was also accessible through the data view. So instead of general, this revenue is going to be English United States currency. And there you have it. So we just used sum to create two new measures, two new numerical values that we can analyze in our model, quantity returned and total revenue. And now that we have quantity sold and quantity returned, those two pieces could serve as interesting components to another new value like return rate. So I think that's something that AdventureWorks might be interested in seeing, not only the raw volume of sales and returns for their different products and territories and categories, but the actual return rate as well. So are accessories returned more frequently than bicycles? Are there certain territories where return rates are unusually or concerningly high? By creating these new numerical values with measures, we're giving ourselves, or we're creating for ourselves, these tools that we can use to answer those types of analytical questions. So let's try creating that return rate column, and we can assign it to any table we want. I think it makes sense to either go in sales or returns because it's going to contain a component of both. We're going to be using the quantity sold measure in the sales table and the quantity returned measure in the returns table. Now, since this is more of a return specific measure, let's go ahead and assign it to the AW returns table. So right click that header, press new measure, and we're going to name this one return rate. And two ways to do this. You can either use the division operator or the divide function. Both are valid. Again, the divide function just gives you that optional third argument. Now, this is also a good point in time to remind you about the difference between columns and measures, and the fact that measures can't reference naked column types or columns that don't have some sort of an aggregator assigned to them. So for sake of example, what if we tried to calculate return rate as just the order quantity column from the sales table divided by the return quantity column from the returns table? If I try to start typing, it's not even allowing me to access that column because Power BI knows that I need some other piece of information here. I need some sort of aggregation, whether I'm defining aggregation here in the function, like the sum of the return quantity or order quantity, which is valid, or a measure like quantity returned or quantity sold, which is built from an aggregation. So in this case, our return rate, we're going to define it in a pretty simple way, just the quantity returned, and I'm using the measure that we've already created, divided by quantity sold. So we're just coming up with a simple ratio here, and this is what I'm talking about with measure trees. We're using individual measures as components nested within new measures like this one, return rate. So I could press enter, and that should work just fine. You can go ahead and pull return rate into this same matrix view as well. And if we want to format this, let's make it a percentage here. And it's going to default to 2 decimal points, which looks good. And again, this is the operator version of the function. We could also use the divide just to see what that looks like. Equals divide, and then numerator, comma, denominator, comma, alternate result. So my numerator, again, is quantity returned, my denominator is quantity sold, and then the alternate result, so in cases where we get an error, that's going to be a div 0, and it's going to happen in cases where I have no quantity sold values. In this case, that shouldn't be an issue because we won't see returns in cases where there were no products sold, but just to cover our bases, we could do something like no sales as our alternate result. So in some case that we happen to run into a div 0 error with this divide function, we would just assign that label of no sales instead of the error message itself. So that should be good, and when we press enter, produce the exact same values. There you go, it just refreshed, nothing's changed. So that looks good. And now let's simplify this view a little bit. I want to explore things just for a second. Let's pull order quantity out. Let's pull total revenue out. So now we're just looking at sales, returns, and the return rate. And instead of breaking this down by product key, which is really granular, let's remove that. And let's actually look at product categories at kind of a higher level. So category name in our rows instead. This is starting to give us some interesting insight already. This tells us that the product category that's returned least often are accessories, and most often are bikes. And then you can see clothing kind of falls somewhere in between at 2.16%. So already, just by using some pretty simple measures like sum and divide, we're able to take our analysis to an entirely new level. And to be honest, we are just getting started. Now, the last basic math and stats demo that I want to walk through is the average function. And so to use average, let's say we want to create a field to calculate the average retail price. Now, since retail price is an attribute of my products, I'm going to access that field within my product lookup. There it is, product price. I'm going to add a new measure right here within the table. You can see I can right click anywhere inside the table. It doesn't have to be the header. Choose new measure. And let's call this measure average AVG retail price. And super simple, we're just going to use the average function, and I'm going to type price to search for it. Product lookup, product price, close it off, and press enter. So it's created that new measure, that new field in my table for average retail price. And let's go ahead and pull that field into our matrix. Now, one thing you'll notice is that now we're seeing average retail prices even for categories or products that weren't even sold in the data set. And that's because even though they don't exist in the sales or the returns records, they do exist in our product tables because they're part of the product lookup. And because we do have retail prices associated with every product key, then we are still able to calculate the average even with no sales. So let's go ahead and format this one as a currency as well. There you go. And now one last little teaser that I want to show you, just one of the reasons why these visuals in Power BI are so cool, is that so far we've just been looking at individual row labels, in this case category name. But what you can do is some interesting things like pull in another field, let's say subcategory name, drag it in under category name. You'll see the view didn't change, but what we can do now is use these drill buttons to actually go to a different level in the data. So we've just drilled up from category name, down into subcategories, and we could stack or nest additional ones in here as well, like products, actual product name as a third level, and then drill even deeper. It's giving users the ability to kind of self-discover and explore the data and drill in and out at different levels. Or you could use this last button here to show your deeper levels within the same view, like so. So we're going to talk a lot more about exactly how these visuals work and some of the other incredibly useful tools available in this report pane, but more on that to come. So there you have it, creating measures using those basic math and stats functions. The next group of measures that we're going to talk about are the counting measures. These are really helpful. We're going to talk about 4 different count functions Here, count, count A, distinct count, and count rows, they all work in a very similar way. They just count slightly different things. So starting with count, count is designed to find cells in a column that contain numbers specifically. So all you do is write the count function, point it to a column containing values, and you're good to go. Count A, very similar, but this counts the number of non-empty cells in a column. That could include numerical or text-based values. Syntax-wise, same deal, single argument for the column name. Now, distinct count, this is one of my favorites because historically it's been something that's unusually difficult to do in Excel. There hasn't been the same equivalent function on the Excel side to do something like this. And this is where DAX really stands out. You can easily count the number of distinct or unique values in a column using that distinct count function. Again, one argument for the column name. And then last but not least, we have count rows. This one's slightly different because this actually points to a whole table or a table defined by an expression like filter or all and counts the number of total rows in that table. So pretty clear, pretty straightforward. Let's practice a couple of these in our AdventureWorks file. Okay, so go ahead and open up your AdventureWorks report, head to the report view, and what we're going to do here is add two new measures practicing these count functions. And the first measure that I'd like to add is related to returns. Now, note that we've already created a measure for quantity returned, which is the sum of the return quantity field. But in this case, I want to return the value of total returns. So very similar concept, but the difference is that if a customer came in and returned 2 items, that would count twice in the quantity returned column, but I only want that to count once as a return. And since this AW returns table includes a record or row for every single return, what I can simply do here is count the number of rows to give me that total returns value. So to do that, we're going to use a count function, right click, new measure. Let's call it total returns. And we're going to set that equal to count rows and just point to that table, returns. So we're counting the rows in the AW returns table. As simple as that. Press enter. It's added my measure here. I can select the matrix, drag total returns into the values, and you'll note that they're very, very similar to the quantity returned, but a little bit lower. What that tells me is that the vast majority of returns, in this case, were from single items, but there were a handful of multiple items returned, which is why the total number is slightly lower than the quantity of returns itself. Now, let's go back to that concept I mentioned earlier about each row or record in that return table representing a return. I want to actually look at the table for a minute. So we're in our return table here, and you'll note that in every single case, we've got a return date, we've got a territory key assigned to it, product key assigned to it, and a return quantity assigned. So there should be no blanks anywhere in this table. And again, each row represents a return. So what that means, if I go back and revisit that measure, that means that I could theoretically calculate this same total returns measure in a few other ways. For instance, instead of count rows, I could calculate a simple count of any column in that returns table that includes values. So let's start typing returns. We could technically use any one of these, any of our keys. We could use the count of the quantities or the return dates. They should all return the same thing, again, because there are no blank values in that returns table. So let's calculate the count of return quantity. Tab it in, close the parenthesis, and press enter. And you'll see that these total return values refreshed and remained exactly the same, which is what we'd expect to see. And then same story holds if we use count A as well, because again, very similar function, except count A also accounts for non-numerical values like text. And that shouldn't make any difference in our case, but let's just confirm by pressing enter. There you go, they've refreshed again, same values. So there you go, 3 different count options or counting approaches to evaluate the same total returns measure. Now up to you which version you'd like to use. In this case, I'll just keep it as count A for now. And the next measure I'd like to add is a very similar one, but looking at the sales table, I'd like to add a comparable measure here for total orders. And same story kind of holds here. We already have a quantity sold measure, which sums up the order quantities, but I'm not interested in the total quantity. I'm interested in the total volume of orders as a whole. Now, to figure out how we're going to calculate this, it's helpful to go and take a look at that sales table for ourselves. And looking at the sales table, one thing that's interesting is that we've got this order line item column, which means that if I placed a single order but purchased two different products, that will show up as one order number with order line item 1 followed by order line item 2, which means that there are duplicate values in here because there are multiple line items for any order containing multiple products. And the reason we're digging into this is because I can't use a function like count or count A against any column in this sales table, like order number, because it won't respect the duplicates, and I'll be double counting and inflating my order totals. So this is a great opportunity to use that distinct count function because I want the count of unique order numbers, and that's going to give me my measure for total orders. So let's go back to our reporting canvas, right-click the sales table, add that measure, and you guessed it, we're going to name it total orders, and that's going to equal the distinct count of my order number column in my sales table. So AW sales, order number, tab it in, close the parenthesis, and press enter. And now just to demonstrate, let's grab that total orders. I'm going to put it in right next to quantity sold. And there you go. Kind of the same type of comparison we just made with quantity returned and total returns. We have quantity sold and total orders. So as you can see, a number of sales, a number of orders contained multiple line items or multiple products or multiple quantities of the same product. So this is a great use case for when something like distinct count can really come in handy. And it's really as simple as that. Those are your basic counting functions in DAX. All right, now before we move on to the next DAX function, calculate, I want to take a moment and pause here to address a really important but nuanced point. And it has to do with the values that we've produced here in our matrix view. Now you'll notice my screen looks a little bit different. That's just because Power BI has gone through some updates since recording the last version of this course. So you'll see the light mode here, a new filters pane. Don't worry about those differences. Functionally, everything will operate exactly the same. And if there are major changes, I'll address those as we get to them. But what I want to focus on right now are the values here. Now, if you haven't already, I want you to take a minute, pause the video, and let me know if you see anything a little bit strange or unexpected about some of these values. All right, did you find it? By now you've probably realized that this total orders column is a little bit strange because the total, 25,164, does not equal the sum of its component rows. In fact, if we were to add up the accessories orders, bikes orders, and clothing orders, we'd end up with something closer to 38,000, not 25. So what's going on here? Well, this is a perfect opportunity to talk about exactly how DAX is working and also how the data that we're working with is really structured. So two things I want to call out here right off the bat. First, this value here in the total row is not calculated as a sum of the rows above. This field is calculated as an island, and it has no awareness or visibility into the values around it. In fact, this is calculated by evaluating the total orders measure without any filter context applied. That's why it's a totals row. Whereas a number like 6976 is evaluating the total orders measure with the filter context category name equals clothing. So it might not seem like a big difference, but it's a critical, fundamental idea to help you understand how DAX really operates. So that's the first thing. The second thing that we need to call out here is how this total orders measure is actually working. So let's go ahead and find it here in our field list. Total orders. Remember, we defined the total orders measure as a distinct count of order numbers inside of our sales table. So let's take a closer look. Let's jump into data. We're going to drill right here into our sales table. And what I want you to do is actually sort your order numbers descending. And what you'll notice right off the bat is that the same order number can appear multiple times. So there can be multiple instances of the same order. In this case, right here at the top, SO74147, that order number appears 3 times. So the order took place on June 30th, and it actually contained 3 different products or 3 different order line items. Okay, so this customer, when they made this purchase, they bought 1 quantity of product 490, 1 quantity of product 605, and 2 product 538. And because we're calculating a distinct count, that only counts as 1 order number, even though it contained 3 different products. So following this kind of chain of investigation, let's think about what these products actually represent. We can do that by following our relationships in our data model to understand what is product 490 and what category does it fall into. So let's start there, 490. We're going to go into our product lookup table. Make sure you're sorted on product keys, and we can scroll right to 490. Here it is. So this is a short sleeve classic jersey, and the product subcategory that this falls into is 21. So same logic. Let's go into product subcategory, find subcategory key 21, jerseys. That makes sense, and that falls into category 3. So last but not least, jump into product category. Category 3 is clothing. So product 490 should be labeled or categorized as clothing. Now I won't go through that same process for each of them. You can if you want for practice, but I'll tell you right now, product 538 is a road tire, which falls into the accessories category, and product 605 is a road bike. It's the Road 750 black bike, which falls into the bikes category. So as you're starting to realize, this 1 order number contains products that fall into 3 different categories: clothing, accessories, and bikes. So when we jump back to our report view, think about how this total orders measure is evaluating. When we're filtering down to our accessories categories, we're seeing 1 order from that particular order number that contains an accessory product, right? When we filter down on bikes, we see another order, and clothing, we see a 3rd. So we're adding 1, or we're counting 1 order for each of these 3 categories. But then when we evaluate the total, we're looking at the unfiltered total sales table, just like this. And because we're using a distinct count, we're not counting that as 3, we're counting it as 1. So kind of tough to wrap your head around, but that's exactly how this is working here. And one way to kind of interpret this or read the numbers from this matrix is that accessories, or products in the accessories category, appear in 16,983 orders. Products that fall into the bikes category appear in 13,929 orders, and so on and so forth. So again, it's a little bit of a nuanced point, but a really critical one to understand as you're learning this DAX language. Hopefully that helps. All right, important lecture coming at you. We're going to talk about the DAX calculate function. Now, calculate is arguably one of the most important DAX functions of all, because not only does it do pretty powerful things on its own, but it also serves as a container for much more sophisticated and complex DAX formulas. So let's break this down. Calculate on its own, pretty straightforward. It evaluates an expression or formula under a set of defined filters. So here's what it looks like. You've got your expression argument first. This could be the name of a measure, or it could be a DAX formula that could create a valid measure. So you could plug in your total orders measure there, or a sum function of the return quantity from your returns data table, both totally valid options. And then the second component of the function is this set of filters this list of simple Boolean, meaning true false, filter expressions. Now, important thing to note here, these must be simple expressions with fixed values. So column name on the left and some sort of a value or text string on the right, separated by an equals, a greater than, a less than, etc. So some examples could be country column from territory lookup equals USA, or the year column from the calendar table greater than 1998. What you cannot do here is insert more complex filters or even use filters that reference measures. So again, column name and some criteria, either value or text. So pro tip here, the way that I've kind of wrapped my head around calculate as I learned it for the first time was to think of it in Excel formula terms. I'm obviously an Excel guy, that's my background. I think like Excel, so anytime that I can relate it to something comparable in Excel, that usually helps me kind of wrap my head around it and understand what's really going on. So calculate works very much like a SUMIF or a COUNTIF or an AVERAGEIF function in Excel, in which case you're evaluating a sum or a count or an average if certain filters or criteria are met. The difference is that calculate can evaluate measures based on any sort of calculation, not just those restrictive sums, counts, averages, etc. So you can almost think of this as like a calculate if, which is much more flexible because you can define really rich, really complicated measures and plug those into the expression argument here in the calculate function. So I want to jump to Power BI, do a simple demo, and then return to the slides to dig a little bit deeper into how this is really working. All right, back in AdventureWorks report, let's try creating our first ever calculate measure. And this measure is going to be related to my sales. And what I want to do here is calculate a measure that captures bulk orders. So in other words, I'm going to evaluate the total orders measure that I've already created, but only under the filter expression where order quantity is greater than 1. So this is a good candidate for calculate. Let's right click, add the new measure. And I'd like to name this one bulk orders, even though realistically an order size of 2, you could argue isn't really bulk, but let's not worry about that. So bulk orders equals calculate. First argument is my expression. So what am I calculating here? Well, I'm calculating my total orders measure that I've already defined. And then comma over to my filter statements, my filter expressions. And in this case, I'm looking for cases where my order quantity, which is AW sales order quantity, is greater than 1. Close the parenthesis. So this should check out because I'm evaluating a measure called total orders, and I'm calculating that measure, but only if my order quantity value is greater than 1. So we can press enter to lock it in. We see our bulk orders measure now defined. And let's go ahead and select our matrix here. I'm going to pull out our return fields. And I'll pull out average retail price as well, so that I've just got quantity sold, total orders, and now bulk orders as well. So it's interesting because you see a lot of bulk orders as a percentage of total for things like accessories and to a lesser extent clothing, but you see no bulk orders for bikes, which makes sense. If bikes are a much more high ticket item, you generally won't have customers coming in and purchasing multiple. So that looks good. That's our bulk orders calculate function. Now let's return back to the slides and drill in a little bit deeper into how this function's working. So let's look at a different example of calculate here. In this case, we've defined a new measure. We're calling it bike returns, which uses calculate to evaluate the total returns measure, but only when the category name from the product table is equal to bikes. And when you visualize this bike returns measure against your total returns, broken down by category names, you see something interesting taking place here, which is that you see the same repeating values in every single row for every single category name within that matrix. So you may be wondering, shouldn't those cells have different filter contexts in the other rows, for the clothing row, for the components row, And this leads me to a very important point, which is that what calculate is actually doing here is it's modifying and overruling any competing filter context. Now let that sink in for a minute. Let's pay attention to the clothing row, for instance. That clothing row in the matrix has filter context of category name equals clothing, which is defined by the row label, and it also has filter context for category name equals bikes, defined by the calculate function. And since both can't be true at the same time, the clothing filter is overwritten and the bikes filter from calculate takes priority. So think of calculate as kind of the bully function or the bully filter, which says, I don't care if I'm sitting here in a matrix row that says it should be calculating accessories or clothing or components. I'm the boss. I'm going to step in and say, we need to calculate for category name equals bikes, period. And that's why you see the same total row after row after row, even for lines like components, which didn't generate sales or returns. Now, it may be helpful to revisit the step-by-step measure calculation that we walked through earlier in this section. So remember, there were 3 steps there to every measure calculation. It started with the filter context being detected and applied. So in this case, we're looking at the accessories row in that same example. So Power BI says, okay, we're in the accessories row. The matrix row labels have passed us filter context that says product category name should equal accessories. So go ahead, head to the product table and filter that down to just accessories rows. Here's where things change. Before we move to step 2, where normally that filter context would pass down to any related data tables, there's an intermediate step, which is that the filters get modified by calculate. So anytime the measure being evaluated, in this case bike returns, contains a calculate function, that filter context gets overwritten right here between step 1 and step 2. So what's happening is that even though we originally filtered down that product table to accessories, between step 1 and 2, the calculate function butts in and says, nope, we're actually going to filter based on category name equals bikes. And then that new filter context passes over to step 2, and the process continues as it normally would. So now the filter context is for product rows where the category equals bikes, and that context passes to any downstream connected data tables, and from there, the measure is evaluated. In this case, the total returns, which is the count of rows from that final filtered returns data. So the point here is that no matter what that initial filter context was in step 1, defined by the matrix row labels, accessories, bikes, clothing, or components, regardless of what it is, it's going to get overwritten with bikes, and then everything from step 2 onward yields the same end result of 342. And that's why you see the repeating values. So definitely a tricky, pretty technical concept, but let's head back to our report and create a function like this so that we can kind of see it working for ourselves. Okay, back in the report, first thing I want to do is actually jump to data quickly, and I want to create a measure to capture weekend orders. It sounds like our AdventureWorks clients are really interested in sales trends between weekends and weekdays. You know, maybe they're looking to see if they need to run more offers on weekends to promote sales, or if weekends tend to be stronger than weekdays. So to help them answer those types of questions, let's use a calculate function to evaluate our orders measure, but only for weekends. So we're going to be basing that off of this weekend column that we created with our if and or statements here in the calendar table. So let's hop back to our report view. And again, this is going to be a sales related measure. So I'm going to right click, add the new measure, and let's name this weekend orders and set that measure equal to calculate function. And we're calculating total orders, our measure, where the filter is that the date is a weekend. So we can search for that weekend field. There it is. And the 2 values that weekend can take are weekday or weekend. So in this case, my filter will be weekend and close it out. So we've got our simple filter, column name criteria. And I think that should just about do it. So when I press enter here, created our new measure for weekend orders. I'm going to select my matrix, pull weekend orders in, and to clean things up a little bit, let's pull quantity sold out, bulk orders out, and let's clear all of these product related fields as well. So we should just be looking at two numbers, total orders and weekend orders, which is calculating the total orders measure, but only in cases where the date falls on a weekend. So just like I showed you in the slide, let's go into our calendar lookup, grab that weekend dimension, pull it into our rows, and this is exactly what you see. That same repeating weekend order number over and over and over again. Now you might be wondering, what's the point of calculating a weekend order specific measure when you have access to this weekend field that you can pull in, to break down your orders exactly like we see here? Well, the answer is that if we weren't filtering on this weekend field, pull that out of our rows and pull in any of these other fields like category name, for instance, we're still able to see the weekend specific orders broken down in a completely different way by category without having to have that weekend dimension pulled into my matrix view. And not only that, but just like any other measure, this weekend orders measure can now serve as an input and be nested into other calculated measures from here. So it gives me a lot more flexibility than I would have if I were simply pulling in a dimension like weekend and breaking down a basic total orders measure that way. So that's your primer on the calculate function. In the next few lectures, I'm going to talk about how to make this calculate function even more flexible and even more powerful by nesting other filter functions like filter and all. Stay tuned. The next DAX function that I want to talk about is all. Now the all function either returns all of the rows in a table or all of the values in a column, completely ignoring any filter context. So here's what it looks like. Your first argument of the function is either the table name or the column name that you want to clear filters on. So you could point to the entire sales or transactions table here, or a specific column like product category from your products table. And keep in mind here that all does not return a single number. It returns a table or a subset of a table. So you'll almost never use all by itself. Instead, you'll use it as a component of other functions, most commonly calculate. Now, the second optional set of parameters or arguments here are column names. So if you've selected a column in your first argument as opposed to a table, you do have the option to list additional columns here that you'd like to clear filters on. The catch is that all of these columns must be fully qualified and include the table name, and they must all come from the same table. So, pro tip, instead of adding filter context or changing it like calculate does, all removes it. And that sounds a little confusing and counterintuitive at first until you realize what it's commonly used for, which is when you need unfiltered values that you don't want to react to changes in filter context. Great example, which we're going to practice, is a percent of total calculation, where your denominator, your grand total, needs to always remain fixed. So let's head to Power BI and give this a shot. All right, here in my report view, I want to practice adding two new measures using that all function. But again, we're not going to use all on its own. We're going to use it as part of a calculate function. And the first one that I think we should add is a measure to capture the grand total orders, or all orders across the board. That way we can take our existing measure, the total orders measure, and take a ratio to calculate something like the percent of grand total. So let me show you what I mean by that. This is going to be assigned to our sales table, since this is a sales related metric. I'm going to add a new measure, and let's name this all orders. I'm going to make all kind of all caps just so that it sticks out and reminds us that we're using the all function as part of this measure. And so the way that we're going to calculate all orders, which is essentially the grand total of orders, is to start with our calculate. we're going to calculate our existing total orders measure. So here's where things get a little bit strange, because the calculate is now asking for the filter argument in our function. So this is where we would normally add filter context, like country equals USA or quantity is greater than 1. Instead, in this particular case, we want to strip filters out. And anytime you want to remove filters, you know you need to use the all function. So we're going to type the all right here in the filter argument of our calculate. And we're going to just input the table name of our sales table, because the sales table contains the order information that we're using to calculate our total orders measure. So we can just type AW underscore sales and we'll get the entire table. This icon looks a little bit different because it's the whole table, not an individual column. Tab it in, close the parenthesis, and then close one more parenthesis at the end. So to recap, give me the total orders calculation applied to the entire AW sales table, no matter what. So let's press enter, lock that in. And there we go, it's added it into our AW sales table. And now what if we just select our matrix here and grab all orders and drag that into values? So check this out. We've got our total orders column, which is the measure that we're calculating. Now this all measure that we just created, this all orders measure, even in rows where the filter contexts are trying to tell it to filter down to different categories, accessories, bikes, clothing, the all statement that we added in the filter argument of our calculate is saying ignore all that and just return the grand total no matter what, no matter how this view, this matrix, this report page changes. So this field alone is not that helpful. As you can see, there's no real circumstance where we'd want to drag this field in or analyze it by itself, but where it does become useful is serving as an input for something like percent of all orders. So let's go ahead and add another measure, new measure, and let's call it actually, just like I said, percent of all orders. And what we're going to do here is basically just calculate the ratio of our original total orders measure divided by that brand new all orders measure. So that denominator, which is defined by the all function in the calculate, will never change. It's always the grand total. But the numerator, total orders, can change in reaction to different filter contexts, as you can see right here. So when we go ahead and lock that in, drag it into our matrix visual, we can go ahead and enter the modeling tab to format it as a percentage. And look at this, it totals to 100%, which is correct. And now we can see really interesting insight, like what percentage of the total orders do accessories account for? In this case, about 2/3. What about bikes? Just over half. Clothing, about 28%. Now a little added bonus to this, even though all orders is a component of this percent of all orders calculation, it's the denominator, it does not need to live here in the matrix for us to calculate our percent of total. So let's remove that, and there you go. It still functions exactly like you'd expect, and it can still be filtered and segmented in any way you can imagine. So that's a great, very common example of how to combine calculate and all to create these percent of total fields. Now, one more quick demo here. I'd like to add one more measure, this time to our product lookup table. So I'm going to right click, add a measure within product lookup. And for this one, I'd like to calculate the average retail price or the average product price across the entire table, which will essentially give me a single number that captures the average price across the entire product set. So let's name this overall average price, okay? And remember, we've already calculated an average retail price just using that basic average function on its own. So now what we can do is calculate that measure, average retail price. And since we don't want our overall average price to change in reaction to filter context, we always want the same overall average number to be returned. That means we need the all statement here again. And this time, the table that we're going to reference is not the sales table, it's not the returns table, it's the AW product lookup table right here. Close out two parentheses, and to recap, we're evaluating our original average retail price, which is the average of the product price column values, and we're evaluating it based on the entire AW product lookup table every single time. Press enter to lock it in. And now to see how that's working, we can go back to our matrix here. We've got our original average retail price, which we'll pull in. And then we've got our overall average retail price, which we can pull in second. And there you go. You can see that our overall average, which used the all function, gives us that same total average, that same overall average every single time. So while we're here, let's go ahead and make that currency $English. And there you go. So now we can see interesting things like the average price for accessories is well below the average. Bikes is clearly pulling the average up. Clothing average is about $51. Components $432. And when you blend all of that together, the overall average is about $714. So we're going to be using this overall average price measure as a way to demo another function that's commonly nested with calculate, which is called the filter function. So stay tuned, that one's coming up next. All right, so we've talked about a few DAX filter functions already, namely calculate and all. Now I want to talk about a third called filter. Now filter by definition returns a table that represents a subset of another table as defined by some filter expression. So very simple syntax. First argument is the table that you'd like to filter. Might be a lookup, might be a data table, doesn't matter, any table. And the second piece, or the second argument, is the filter expression, a Boolean true-false filter expression to be evaluated for every single row of the referenced table. Now, a couple of very important things to call out here. Number one, filter can accommodate more complex filter expressions than a standard calculate. One great example is that you can actually integrate measures into your filter expressions within a filter function. Like this last example here, product price is greater than a measure named overall average price. And the other important thing to note is that filter is what's called an iterator function, meaning that it iterates row by row by row by row through an entire table, testing that filter expression, that true-false statement. And for every row where that expression returns true, that row is preserved. Any row where that filter expression is false, that row gets chopped out. So as a result, it's going row by row and chopping out any rows that don't meet the filter expression. And then by the time it's gone through the whole table, you end up with this subset, a smaller table containing fewer rows and only the rows that meet the filter expression. So this is different from how a calculate works. Calculate is not an iterator, meaning it doesn't actually eliminate rows from the table. It just identifies filter context and modifies it. Filter, as an iterator, is actually producing a new table as a subset of the original table based on whatever filter expression you're using. So, important point, filter is used to add new filter context, and it can handle more complex filter expressions than calculate, like we just said by referencing measures, for example. And since filter spits out an entire table, you won't use it by itself. It's almost always used as an input to other functions like calculate or sumx, just like we saw with the all function as well. So little tip here, since filter is an iterator function, it can be slow and it can be pretty processor intensive. Not a big deal at all if you're working with manageable file sizes, but as a best practice, don't use filter if a standard calculate function will get the job done. So let's open up our AdventureWorks file and practice creating a brand new measure using this filter function. All right, once you're back in your AdventureWorks report, remember that we added this overall average price column by combining calculate and all. And now using that column, I want to create some sort of measure that will calculate our total orders, but only for products that are greater than the average price. So I want to see sales for higher than average priced items. And I want to name that measure something like high ticket orders. So let's go and right click our sales table and add a new measure. And we're going to name this measure high ticket orders. And again, we're going to start by calculating our existing total orders measure. And now for the filter statement, let's step back and think about this for a minute. So to recap, what we're trying to do is we're trying to return a measure that's going to capture the volume of orders, but only for high-priced products, or products with a retail price greater than the overall average, which we know is $714.44. So the first thing you might be inclined to try is to say, okay, in our filter argument of our calculate, let's find that product price field, product lookup, product price, tab that in, and say, okay, so if the product price is greater than the overall average price measure that we created, and then close the parenthesis, right? So we're calculating total orders in cases where the product price in the product lookup table is greater than the overall average. Press enter, we get an error. And the error message is not very helpful. It says a function calculate has been used in a true-false expression that is used as a table filter expression. This is not allowed. So classic Microsoft writing a very wordy, very confusing error message when they should have just said, hey, you can't use a measure in your filter argument of a calculate. That's really what's going on here. That's what it has a problem with. So if we edit this and delete the reference to our measure, our overall average price measure, what we could do if we were lazy is just type the average, right? 714.44, because this now becomes a simple filter expression, column criteria. And if I press enter, that will go through just fine. It added a measure for high ticket orders. And let's select the matrix. And why don't we grab it and pull it right after total orders. So as you can see, high ticket orders populated on the bikes row. That's the only product category that's generating sales for products priced over $714, which makes sense. So we see overall about 11,312 orders were categorized as high ticket out of 25,164 overall. But the fact that we had to hard code that number is unsettling to me, and it's not scalable because it won't change as our product list evolves or if we need to refresh data in the future. So it's kind of sloppy analytics, and I don't like it. So let's go back to that measure, and what we're going to do here is use our new friend filter to accommodate this more complex filtering rule. So let's go ahead and clear out the filter argument of our calculate. And just like we added all, we're going to add a filter here. And this is where we're going to define that product price greater than overall average price filter. And here we can reference that measure since filter can handle some of these more complex expressions. So the table that we want to filter is our product lookup table. AW product lookup, because that's the table that contains the product prices that we're testing. And now the filter expression is that the product lookup product price is greater than that measure that we use to calculate overall average price. So kind of a lot going on here. Looking at the filter statement on its own, it's saying, all right, look at the entire AW product lookup table, that list of all our product keys and all those attributes about those products. Go row by row, check the product price, and compare it against our overall average price measure, which we know is $714.44 based on the data we currently have. If the price is greater than $714, we're going to keep the row from product lookup. If it's less than or equal to that average price, we're going to chop that row right out of the table. And then we repeat the process row by row by row until it's gone through the entire product lookup table and hacked it down to a smaller table containing only the products that meet this expression that we just wrote. And then that table as a whole gets passed to the calculate function so that the total orders measure can evaluate against it. So a lot going on there, but you see how this can start to enable some really advanced, really complex stuff. So it looks like we just need to add one more closing parenthesis, and then we should be good to go. So what we're going to watch is this high ticket orders number. And if we've done our jobs, when we hit enter, this shouldn't change at all. So drum roll, please. Enter. There we go. So it refreshed, gave us the correct number that we got when we hard coded the number in there into our basic calculate. But when we replaced that hard coded number with the full filter function, we continue to get the correct number. So that's great news. Now, obviously, that's just one example of how filter and calculate can be combined, but hopefully a good example of how these functions can work together to do some really sophisticated things. So that's your crash course on filter. Next up, we've got iterator functions and SUMX. Next up, I want to take a quick look at iterator functions, otherwise known as X functions, in DAX. And in a nutshell, what these iterators do is they loop through a given calculation or expression for each row of a table and then apply some sort of aggregation to the results. Now, here's an example of what a SUMX function looks like. And in this particular case, the aggregation mode is a sum, but the same syntax applies to other X functions like countX, averageX, rankX, etc. So the first argument of the function is the table in which you want the expression to be evaluated. This could be an explicit table reference like sales, or it could be a filter or all function that produces a table. And then the final argument of the function, the expression, is basically what's the calculation that you're trying to evaluate row by row by row. So it might be a measure like total orders, or it might be a mathematical operation like the values in one column times the values in another. And this took a little while to sink in, at least for me. But what kind of helped was to equate it to a sum product in Excel. And a great example that's kind of tangible and hands-on is calculating something like price times quantity, right? So imagine a price column, a quantity column, and you run a sum product, which basically calculates price times quantity in row 1, price times quantity in row 2, over and over and over and over until it gets to the last row in the table. And then it takes the results of each of those multiplication expressions and sums them up. So it might be helpful to think about these iterator functions, adding a temporary column at the end of the table where it stores the results of each of these expressions for every single row as it works through the table. And then once it reaches the end, the final row in the table, it aggregates the values in that temporary column based on whatever function it is. If it's a SUMX, it takes the sum of those results. If it's a countX, it counts the results. If it's a rankX, it determines ranks based on those results, and so on. So that's how these iterators are really working. And to show you an example, what I'd like to do is head back to our AdventureWorks report and try to recreate that revenue column that we had generated with calculated columns and see if we can convert that into a measure using this SUMX function. All right, so open up your Power BI report and head to the Data tab. You want to head to your sales table specifically, and you should see this retail price and revenue column. And these columns were created during the calculated column demos. For retail price, we used related, and for revenue, we simply multiplied the values in the retail price column by the order quantity column. Then as a result, we were able to create a measure for total revenue that equals the sum of that new revenue column. So there's nothing wrong with that. It's not incorrect. We're getting the proper values and it's working just fine. Our table and our data set is small enough that really there's no noticeable impact whatsoever to file size or to speed or anything like that. But if we were perfectionists and we were trying to build the leanest, most efficient possible model that we could, we would try to replicate both of these columns as a measure so that we're not actually stamping redundant data here in the table. So let's see if we can make that happen. I'm going to go back to the report view, so we're going to play with our matrix a little bit. And to set up our view, let's keep this view showing category names, but let's just show the quantity sold and the total revenue. So I'm going to get rid of a bunch of these for now and pull in quantity sold, which is a measure, and that total revenue measure as well by product category. Now let's go ahead and add a new measure in our sales table. And let's name that measure total revenue underscore measure, because I want to keep the original so we can compare against it. And let's think about how the original version of total revenue was calculated. We were taking the values from the order quantity column, multiplying by the values of the product price, which we had pulled into the sales table using related. So maybe the instinct is to start with something like that. Maybe we reference the quantity field, and you'll notice that I can't. It doesn't let me. I can only get to measures here. Same thing with product price. If I try to type price, it's only giving me measure options. And that's DAX reminding us that we can't just reference blanket columns like this. We need to aggregate, because DAX doesn't know what to do with a full column of values and no further instruction. So what if we try to indicate or add the aggregation right here in the formula? So instead of just the quantity column, maybe the sum of the quantity. So sum of AW sales order quantity. It lets us do that, so that's a good start. And let's multiply that maybe by the sum of the product price. You know, if we have to identify some sort of aggregation, maybe that would make sense. So press enter and lock that in, and it seemed to calculate fine. So let's grab this second version, total revenue, pull it into our matrix, and things look totally out of control here. This is telling us that products in the clothing category were sold 12,436 times, total quantity sold, and that generated a revenue of over $22 million, which, just doing the math, means that the average price for a piece of clothing is almost $1,775. So something seems a little bit off there. And as you look at the formula, it's pretty clear that the issue is with our product price field, because we are summing product prices together, which doesn't make any sense at all. We could try to change this to something like an average and probably get a little bit closer. Press enter. So we're at least in the realm of something reasonable, but these numbers are not correct. They're relatively close, but this is not a valid revenue function. So we've got to just chop this down and start over. So if only there were some function that could evaluate an expression for each row in a table and iterate through the whole table and apply an aggregation to the result, that would be exactly what we need here. I think you see where I'm going with this. SumX is going to be a great fit for something like this. So let's start typing it and then walk through. So the first argument of the SumX function is the table, which table contains the rows that we'll be cycling through evaluating these expressions. Well, it's the sales table, AW sales. And the expression, what calculation are we going to be running for each of those rows? It's the calculation for revenue, price times quantity. So we can type quantity, and there you go. Now we can access the actual column itself, order quantity, times the AW sales retail price. Now, one thing you'll note is that I only type price, and there's another price column in the product lookup table. Note that that's not even an option here, and that's because we're performing these row level calculations within the AW sales table. So DAX is telling me I've got to grab columns from within this table. So that's the one I want, AW sales retail price, and close the parenthesis. Now some of you may be wondering, how am I using blanket column references here? AW sales order quantity, AW sales retail price. when we couldn't do that before. The reason is because this is an expression argument of a SUMX. And the way a SUMX works is that this expression only runs on one row at a time. So I'll never need to aggregate because I'm only looking at a single value from each of those columns each time. Now when we go ahead and press enter, there we go. Everything adjusted. Our new total revenue measure matches the original total revenue measure, and we've done it using a SUMX function. So in the spirit of making our model more efficient and reducing redundant data, that means we can now go back to our data, we can right click and delete that revenue column, go back to report. We're going to get an error because that old total revenue measure was built off of the column we just deleted. So we can pull that out of the visual, find it right here in our field list. You can see it's got a little caution exclamation point. You can right click, delete it, and there you go. Our total revenue measure using SUMX is still here, still correct, still fully functional, and we've eliminated an entire column of extra data. And now if you want to get really crazy, we can eliminate one more column as well. And I'm going to give you a hint at how we can do that. Looking back at our data sheet, this retail price, remember we pulled this in with related? We can follow this same logic, but embed it or nest it inside of that SUMX that we just wrote, instead of pulling the column in here and then referencing it from within the sales table. So let's go back. I'll show you what that looks like. Total revenue measure, which we can now just call total revenue because the other one's gone. And so SUMX, AW sales, order quantity. Now I told you that we had to pull columns from within that sales table, but I kind of lied. We can access columns from other tables, but the only way to do it is to use the related function. So just like we pulled a related field into the table itself, we can access values from a related field inside of a SUMX. And that related field is the product price. So again, same exact logic as when we used related in the calculated column, except this time we're just embedding it within this SUMX function. And we press enter, values still hold. Let's go ahead and format those as currency. Perfect. And now the last little step here is to go back to our sales table, and you know it, we can delete this related column as well because we don't even need it anymore. All of the information we need is now built into this single SUMX iterator function. So bottom line, we just chopped out 2 entire columns worth of data without actually losing anything, because we essentially just transitioned the calculations out of columns and into measures. So that's SUMX. The other X functions work in a very similar way. The only difference is the actual aggregation step that happens at the end. But hopefully this inspires you to go and play with some of these iterator functions on your own. Next up, we're going to take a look at an area where DAX really shines, which is time intelligence functions. All right, so I've saved some of the best stuff for last. The final topic that we're going to hit for our DAX demos is time intelligence. Now, time intelligence functions allow you to easily calculate common time comparisons. Now, these are all built on the DAX calculate function, and they're all extremely flexible and easy to use. So the first one that we're going to talk about is performance to date. So it's going to start with that calculate function. We're going to be calculating some measure, whatever you choose. Could be orders, could be revenue, returns, profit, whatever it might be. And then we're going to use the dates YTD function in here and point to a date field in a calendar table. Now, dates YTD calculates a year-to-date total, but you can swap in other variations like dates QTD for quarter-to-date or dates MTD for month-to-date. The second time intelligence formula that we'll look at is the previous period. So again, starts with calculate, measure. In this case, we're going to use a date add function, point to a calendar date field, and then add 2 additional arguments at the end of the function. An interval type Could be day, month, quarter, or year, and the number of intervals that you'd like to compare. So the example we're looking at here is basically calculating the measure for the previous month. So in this case, if you're calculating a revenue measure and you wanted to change this from previous month's revenue to yesterday's revenue, you would simply change that month interval to day and you're done. And the third one that we're going to look at is a running total. And this one just has one additional function built in, starts with calculate. We're going to use the dates in period function, point to a date field, and then it just has one additional argument for that max function, followed by the same two final arguments, the interval type and the number of intervals. So the version shown here is a 10-day running total. You could change it to -6 and month to create a 6-month running total. And little pro tip, you can easily convert running totals into moving averages by taking that entire running total function and then dividing by that same number of intervals that you're using. So all of these are extremely flexible. They make it very easy to build out many different variations of time intelligence fields with very little effort. Now, my recommendation is not to worry so much about memorizing all of these. It can be really hard to keep track of whether you're going to use dates in period or date add and so on and so forth. To be honest, I have this sheet printed out. I refer back to this slide all the time. So it can be helpful to almost think of these as recipes that you consult when you need to build out these time intelligence formulas. So let's head over to the AdventureWorks file and build out some of these for ourselves. All right, so once you're in your AdventureWorks report, we're on the report pane, and let's edit our matrix. I want to set up a view that's going to be helpful to see these time intelligence functions. So I don't want to view the data by category anymore. Let's get rid of that. And we don't need quantity. We'll keep total revenue, and let's navigate to our calendar lookup and grab start of month and drop it into rows. Now what you'll notice is that it's created this hierarchy automatically, and it's trying to be helpful. It's kind of collapsed it into years by default. If you don't want that, click the little down arrow and just say, don't give me the hierarchy, just give me the original field, start of month. And that will show me monthly level data through my whole sample. So there we go, monthly revenue. It's a good starting point to start working with these time intelligence functions. So let's go ahead and just kick things off. In our sales data table, I'm going to right click, add a new measure, and let's start this one with year-to-date revenue. So we're going to name it something like YTD revenue. It's going to start with calculate, they all do. And the measure that we're evaluating is our total revenue measure. And now for the year-to-date time intelligence function, we use the dates YTD function. And we'll just point it to our calendar lookup date field. And remember, it gives me these options if I want to aggregate. In this case, I don't. So all I need to do is close out two parentheses and press enter. And now watch this. My matrix, I'm going to grab YTD revenue here at the bottom of my field list, the end of my sales table since it's alphabetical. I'm going to drag it right beneath total revenue in the matrix. And now you can see that it seems to be working properly. First month of the year, total and year to date are the same. Second month, year to date is adding the first two together. And then it builds and builds and builds until the final month of the year and then resets the next year. Now, a little teaser for one of the topics we're going to talk about in the next section, the whole data viz section, is a little formatting tool. If we click into this format pane, conditional formatting, I want to format the year-to-date revenue field with data bars. So check this out. This really visualizes how this year-to-date function is working. It builds and builds and builds and then resets. Builds, 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 resets. So if we changed our formula to month-to-date revenue and broke this down by day or week, you'd see that same trend just at a more granular level. So pretty cool stuff there. Let's go ahead and keep cruising ahead, add another measure, and this time I want previous month. So prev month revenue. Starts with calculate. And again, total revenue is the measure we care about. And for this one, we use date add. Open parenthesis, point to our calendar, date field, and then I'm just going to comma right over to get to my last two arguments of this function, the number of intervals and the interval type. So starting with the number of intervals, I'm looking to evaluate that measure for 1 month in the past. So since it's only one period and it's in the past, my number of intervals is -1. And my interval can be day, month, quarter, or year. So I'm just going to select month, tab it in, close out two parentheses, and that should just about do it. So you can see how easy it would be if I changed my mind and said, okay, instead of previous month, our AdventureWorks clients really want to see year-over-year trending. So we need this to actually be previous year. All we would have to do is literally change this last argument from month to year, and we're done. It's that simple. So in this case, I'm happy with previous month revenue. Press enter to lock that one in. And let's go back to our fields pane here. And let's pull year to date out and grab that previous month revenue field that we just created and drop it in. So as you can see, because it's the previous month, it's just basically offset 1 month from the total revenue column, which is exactly what we'd expect. Now, this alone can be pretty helpful, but for our purposes, it's even more helpful because AdventureWorks has given us a pretty aggressive goal. And I don't know if you've heard yet, but they want us to maintain 10% revenue growth every single month moving forward. In other words, that's our revenue target, previous month plus 10%. Now, calculating a dynamic measure like previous month revenue is the perfect starting point for something like that, because now all we need to do is right-click to add a new measure and create something like revenue target equals that previous month revenue that I just created times 1.1. 110% of last month's revenue is my current target. We can enter that in. We can pull it into our matrix to take a look, and 110% of 585,000 is 643,844. So that adds up. And there we go. Now we have revenue target fields based on previous month revenue. Now, last demo here, let's right click, add a new measure. This time we're going to practice the rolling total, and let's do a 10-day rolling revenue. And that's going to use another one of our time intelligence functions, starting with calculate and total revenue, just like all the others. Now for this one, you remember, it starts with that dates in period function. Open it up, point to our date field, calendar date, and then this one has that extra argument for the start date, which is going to take a max function, and it's just the max of our calendar date. There we go. Close that parenthesis out for the max function, and then we comma over to those same two arguments that we had in our previous month revenue formula, the number of intervals and the type of interval. So because we're looking for 10-day rolling, you guessed it, the number of intervals is 10. And because we're looking at previous periods, that's a negative, so -10, and the interval type is day. So -10 for the number, and the interval itself, day. Two parentheses to close it out. I know I'm moving pretty quickly, so feel free to kind of pause the screen, slow down the audio. These time intelligence functions really just take practice before you start to feel natural. But there you have it. That's 10-day rolling revenue. Press enter to lock that measure in. And now because I'm looking at months, it's a little bit too high level here. So I'm going to pull out my previous month and revenue target. And instead of start of month, let's go up to our calendar and actually pull in the date itself. And again, it's going to automatically bucket things and roll them up. I only want the date. So there you go, total revenue by day. Now if we grab our 10-day rolling, drop it in under total revenue, you'll see that the first date is the same as total revenue. The second date adds the first two, third adds the first three, until you get to the first 10-day window. And then basically that 10-day rolling history just shifts right along, and you can track how you're performing over that 10-day window tracked over time. So a really helpful kind of trending analysis that we can use to keep a pulse on how AdventureWorks revenue is doing. So that wraps up time intelligence, and that actually wraps up all of our DAX demos for the course. Remember, this was just a sampling of some of the most common DAX functions. Things can get much deeper and much more complicated from here, but hopefully this has helped to lay the groundwork and create a great foundation for you to start from. With that, we're going to quickly talk about DAX best practices and speed and performance considerations, and then it's off to visualizing data with reports. All right, let's take this DAX section to the finish line with some best practices. First, don't use calculated columns when measures will do the trick. So only use calculated columns when you're looking to create new data and actually stamp static fixed values to each row in a table. On the other hand, use measures when aggregation is necessary or to create dynamic values to use in a report or a visual. Next, get in the habit of writing measures for even the simplest calculations, like the sum of orders or the sum of sales. Once you create a measure, you can use it anywhere in the report, as well as an input to other more complex calculations, which we've seen many times at this point. So a rule of thumb, try to avoid using implicit measures by simply dragging those raw fields into a visual. Next up, as you're learning DAX, try to break down measures into simple component parts. DAX is a unique language, and it's a very difficult one to get a grasp of. So focus on practicing and understanding the simplest components at first, and then work on assembling them into more advanced formulas. Finally, I'd recommend referencing your columns with the table name and your measures by themselves. So using those fully qualified column references not only helps make your formulas more readable and intuitive, but it helps to differentiate them from your measure references. Now, last but not least, I want to cover some quick speed and performance considerations as well. Now, these will come into play especially if you're dealing with very large or complex data sets. So number one, aim to eliminate redundant columns and keep your data tables narrow. Your data tables really should ideally only contain quantitative values and foreign keys. If you have extra descriptive columns in those data tables, those can usually live in a related lookup table. Next, imported columns are generally better than calculated columns. So if you have a means to do so, creating calculated columns at the source, like in SQL or Access if you're dealing with a database source, is more efficient than creating those calculations either in the query editor or in your data model. And then last but not least, try to minimize iterator functions whenever possible. These functions like filter, sumx, averagex, etc. that cycle through each row in a table are expensive, meaning that they take time and they consume processing power, especially if they're cycling through very, very large tables. So if you're experiencing performance lags with your model, that might be a good first place to check. So that officially wraps up the DAX section. Next up, we've got some homework exercises, and from there we'll shift gears, start getting creative, and work on visualizing our data with Power BI reports. All right, time for the DAX homework walkthrough. Now I'm going to go through this very, very quickly. I'll try to include some timestamps in the instructions themselves so that you can jump to specific spots if you get stuck. If you still have trouble following along after I work through these, feel free to reach out and I'll try to help you. So we've got two main buckets of questions. First, we're going to create a bunch of calculated columns, and then we're going to shift to report view and create a bunch of measures. So starting with our calculated columns, we're going to start in the customer lookup table. There we are. And we're going to add a new column called customer priority. So new column, customer priority. And the way we're defining this is that it's going to equal priority for anyone who's under 50 and has an income of greater than 100,000, otherwise standard. So know we need to use an if and an and statement here. So I'm going to start with the if. Current age is less than 50. And now I didn't use the if and version. I'm going to use the double ampersand operator so that I can just separate my logical tests kind of in readable order. So if current age is less than 50 and the annual income is greater than 100,000, comment to my result if true, priority, value of false, standard, close it out, press enter, and we'll see that it's added here. If we scroll down, I believe there should be some priority customers. There they are. So that looks good. That's number one. Next up, we're going to move to our product lookup table. Here we go. And add a new column called price point. Add a new column called price point. And basically we're looking at the product price column. If it's greater than 500, price point's high. Between 100 and 500, price point's mid-range. And then anything under that is low. So rather than using and statements in here for the in-between values, since Power BI, just like Excel, is going to be reading from left to right, I'm just going to start with my highest value and then add a second if, and we should be good. So I'll show you what I mean. So if the product price is greater than 500, then the result, if true, is it's a high price point. And now a little shortcut here. I'm going to grab that whole statement, copy it, paste it as my second if statement. So if the product isn't high, then what am I testing for? Well, then I'm testing if it's greater than 100. And in that case, it's going to be mid-range. And the value of false at the very end, I don't have to add a third statement here, because if a product isn't greater than 500, and if it isn't also greater than 100, then it's got to be under 100 bucks. So that's my catch-all low statement. So if the price is over 500, high. If it's less than or equal to 500, but greater than 100, mid-range, otherwise low. So you can enter that in, scroll to the right, low, mid-range, high. These align with the prices, so that looks good as well. Next up, we're moving to our calendar table. We're going to add a new column called short day. And that short day is essentially going to extract the 3 first letters from the day name and capitalize them. So I'll do it in 2 steps just to show you. I'm going to start with just the left. So the left of the day name column, I want the 3 characters. That returns fry, sat, sun. Looks good. The only other step is to capitalize by wrapping this whole function in an upper statement. There you go, just like we created the short month column during the lectures. And then the last calculated column that we're going to work with is back in our product lookup table. Here we go. We're going to add a new column, and it's going to be called SKU category. And the first part of the question is very simple. It's just the left 2 characters from the product SKU field. So left product SKU, 2 characters, press enter. This is very similar to what we practiced in the query editor, and that seemed to work just fine. Now the bonus is to modify this to return any number of characters up to that first dash. So basically make that 2 something more dynamic. If there were 5 characters or 10 or even 1,000 characters before the first dash, they would be returned here in the SKU category field. And to do that, little hint, you may need to search long and hard. We're going to use a search function here. So the number of characters returned is going to be a function of searching for the dash within that SKU field, right? And we don't need the optional arguments at the end. So I'm going to close out 2 parentheses, and let's try that. So when we scroll over, you'll see we're very close, but it added a dash at the end. That's because the search found the dash in the 3rd position of the string. Therefore, it fed a 3 into the character length argument of the left function, where we just want a 2. So a little tip between the 2 parentheses, I'm going to just literally subtract 1 from the result of my search function, and that will return everything up to just before it finds the character, the dash, and we're good to go. So those are your calculated columns, all pretty straightforward. You can consult the solution file if you have any questions about those. Next up, we're going to jump to report view, and here we're going to create 10 different measures. Now I've included spot checks so that you can actually play with the matrix visuals and confirm that you're getting the correct results. I'm not going to create all of the matrix views to produce those spot check values. It would take too long. So I'm going to show you how to write the measures so that you can make sure you're defining them properly, and then make sure that you do confirm those spot check values so that you're good to go moving forward. So first up, we need a new measure named product models. So this is going to live in our product table. Let's collapse some of these. Right click new measure in the product table, and it's called product models. And product models needs to calculate the number of unique model product names. So every time you hear the word unique or distinct, you know you want the distinct count here. So we want the distinct count of model name from the product table. There you go. You should see 119 unique models in this file. Next up, create a measure called all returns that calculates the grand total number of returns regardless of the filter context. So let's drop this one in our returns table since it's obviously return related. We're going to name it all returns, very similar to the all orders measure that we created as well. So because we need to calculate our returns measure, that tells me I need to lead with calculate. Where is it? Total, there it is, total returns measure. And because we don't want it to respond to filter context, that means we need an all function here. And what we want to do is calculate that based on the entire total returns table. So we're calculating the total returns measure based on the entire AW returns table every single time. Press enter to lock that one in. You should see a total of 1,809 returns. And that should map to the grand total no matter how you filter out those values. Next up, we're going to use what we just created to create a new measure to calculate percent of all returns. So again, we're living in this return table. I'm going to name it percent of all returns, and that's simply going to equal our original total returns measure divided by our new all returns measure. That's going to give us a ratio, a percentage, that we can then use to analyze return rates or return proportions filtered out in different ways. So there you go, that's percent of all returns. Next up, bike returns specifically. Again, new measure in our returns table. I'm going to name it bike returns. And for this one, we're going to use the calculate function because we're calculating the total returns measure like usual. Now the filter context that we're going to add here is where the product category name specifically, equals bikes, in quotes. Press enter. Now when you run your spot check, you should see 427 total bike returns. And next up, we need a measure for total cost. And so total cost, this is actually going to go in my sales table. New measure, total cost. And actually, I'll tell you what, before I do this, rather than starting from scratch, I'm just going to X out of this one I just created. Total cost is going to be an iterator calculation that multiplies order quantities by product cost. And it's going to work exactly how we created the revenue measure by multiplying order quantities by product prices. So rather than reinvent the wheel, let's look at our total revenue measure, which is a SumX that used that related function. I'm going to literally grab that whole thing, copy it, and now add a new measure so that I can start with the total revenue and simply change this to total cost. And I still want to perform a SumX because I want row level calculations. I still want order quantity. This time, instead of pulling the product price from the product table, all I need to do is change that to product cost, and we're good to go. So we'll lock that one in as well. And when you pull that into a matrix, you should see a total cost of $14,456,986. Now from here, we can very easily create a measure for total profit that's as simple as the total revenue minus our total cost. Revenue minus cost equals profit. When you lock that in, you should see a total profit of $10,457,580.86. And now next up, we're going to start working with some time intelligence. First up is previous month orders. So orders are going to live in our sales table. I'm going to name it prev month orders. And basically for previous month, we're going to start with calculate like all of our time intelligence. The measure we're going to calculate in this case is total orders. And for previous, we're going to use the date add function. Point to our date field in our calendar lookup. And since we want the previous month, we're going to do -1 month, and the interval is a month interval. So close out 2 parentheses. We're calculating total orders, and the date add allows us to calculate for the previous period, and our periods are months. So press enter, and we've got previous month orders, good to go. Now, based on that previous month orders, just like we did previous month revenue and a revenue target, we're going to create another measure called order target that's calculated the same way, which is simply that previous month orders measure times 1.1, since our target here is a 10% lift month over month. So we need 10% over the previous month to define our order target. And we're going to be using this in some of the visuals in the next section of the course. Next up, previous month returns. So same process here. We're just going to add previous month time intelligence function in the returns table. Prev month returns. You know the drill. I could have just copied the other one too, but let's do it from scratch. This time we're calculating the total returns measure using the date add, pointing to our calendar date lookup as usual. And then we're going to say number of intervals, -1. Interval is month, 2 parentheses. Calculating total returns using that date add time intelligence function for the previous month. That one looks good. And now our final measure that we need to create is a 90-day rolling profit. And I'm going to put profit here in my sales table. New measure, 90-day rolling profit, which creates basically a running total with a time frame of 90 days. And for this one, as always, we'll start with calculate, and then this time total profit is the measure that we're evaluating, and we're going to use the dates in period option here. Point to our calendar lookup date field, and then the next component, this is the only one that has this 4th argument here, the start date. And for that one, we're going to use the max of our calendar lookup date, just like we practiced in the demos. And then the number of intervals, in this case, 90 intervals. And our interval period is a day, so -90 days. Close out 2 parentheses, press enter, and you are good to go. So I know that was a fast and furious run through of all those measures. Make sure that you play with the matrix visuals, pull these in and out, confirm the spot check values in the homework file, because we're going to be using a lot of these measures in the data viz section coming up next. So with that, you've officially wrapped the DAX section. So get excited, because now we're going to start building some incredible reports and dashboards. All right, time to take this AdventureWorks project to the finish line. We've done all of the data engineering that we can do. We built a nice, clean, and flexible data model. Now it's time to actually bring this data to life and explore some of Power BI's visualization tools. Now we're going to look at matrix visuals, slicers, maps, KPI cards, forecasting tools. We're going to cover it all. We're almost there. Let's do this. All right, so by this point, we've put a ton of work into this. We've spent a lot of time connecting to our data sources, tying them together with a proper normalized data model, and then building out a ton of powerful calculated fields and measures to add new metrics like rolling profit, return rates, order targets. A lot of really great stuff that we've done, but the thing is, it all means nothing until we can actually communicate it and visualize it and allow users to interact with it. So that brings us to the final phase of the business intelligence workflow, which is actually visualizing the data with reports and dashboards. So let's kick off this section with a quick walkthrough of the Power BI report view. Now, we spent some time in here already working with those matrix visuals, but we were really only using those to check our measure values, nothing else. And I think you've probably realized there's a huge amount of functionality and a huge library of tools that we haven't even touched yet. So that's what I want to spend our time focusing on in this section, is working through each of these panes and toolbars and options to see exactly what we can do in this report view. So let's walk through some of them. First up at the top in our View tab, you've got some basic view options. We're going to talk about phone versus desktop layout. You can show grid lines. You can allow your objects and charts to snap to a grid for alignment. And you can also activate other panes like the bookmarks and selection pane. Down at the bottom of the screen, you'll see report pages. Now these look just like Excel tabs and they function the same way. Think of each page as its own blank reporting canvas. So a single report can be made up of multiple individual pages. In this example we're looking at here, and the example that we're going to build together, we're going to have an executive summary page, a product detail page, and a customer detail page. On the right side, you've got two primary panes. These are like mission control for reporting, visualizations and fields. So starting with visualizations, this shows you all of the chart templates that you have to work with. Charts, slicers, matrices like we've been working with, different types of maps, etc. And just keep in mind that for the purposes of this course, we're working with the standard kind of default set, none of the preview options, but it's very, very easy by clicking those three dots in the lower right to import either new preview visuals or to import custom visuals. Now on the right, you've got your field list. We've seen this before. It's accessible in the data view as well. This is simply where you can access all of the fields and all of the measures and columns across all of your tables. Now right beneath the visualizations box, you'll see a pane that includes fields, format, and analytics. So there are actually three panes embedded within this. Now by default, you're going to start in the fields pane, which is what we're seeing here, because that's where you drag in your metrics. It's how you actually tell Power BI what you want that visual to be showing. So in the matrix view, we had rows and columns and values. In this example, we've got a KPI visual that needs an indicator, a trend axis, and a target goal. So what you'll notice is that these panes are completely dynamic. You'll see different options depending on what type of visualization you're using and what fields and objects you have selected. So the fields view within this pane is where you drag those columns or dimensions and values. The next tab, the little paintbrush, contains all of your formatting options, which we'll dig into. And the third, the little magnifying glass, that's called the analytics view, and that includes options to do some interesting things like trend lines and forecasts. Now the last thing to note here is the filters pane, which includes 4 different types of filters: visual level, page level, report level, and drill through. We're going to talk about those and practice them in a later lecture, but for now, just remember that those impact the specific scope of data that gets filtered. So let's quickly jump into our report view and take a look for ourselves. All right, here we are in our AdventureWorks report, right where we left it at the end of the DAX section. What we can actually do here is go ahead and delete this matrix visual. So now I've got a fully clean canvas, clean slate to work with. And now you'll notice those view tabs we talked about. You can show the grid lines. You can enable the snap to grid if you want to make sure you're working with clean alignment. You can activate your bookmarks pane or your selection pane, which just pops up next to visuals. And then let's uncheck grid lines. Down at the bottom, see we've defaulted to page 1. You can easily add a new page or delete it, just like Excel tabs. And then here's our command center, visualizations, and fields. So these can be collapsed if you want to save space, but these will always live here on the right side of your view. And as always, we've got access to all of our fields here. And then as soon as we drag in a visual, we'll have access to the fields options as well as the formatting options in this pane. So with that, let's go ahead and get started by adding our first objects to our report. All right, so let's kick things off pretty simple with inserting objects in basic charts. Now, there are at least two ways to do this in Power BI. One way is to either click on the visual icon itself from the visualizations pane, or head to the Home tab. You'll see this Insert grouping of tools, and from there you can add new visuals, as well as text boxes, images, shapes, and buttons. Now, the other way to add a visual is to grab a field directly from your field list and drop it onto the canvas. And that will automatically generate a new visual, and typically it's a column or bar chart by default. So super simple. I think you'll find throughout this section of the course that a lot of these tools are very easy, very intuitive, and user-friendly. So let's go ahead and add our first object. All right, so it's officially time to start building our AdventureWorks dashboard. Hope you're excited. We're going to start very simple, about as simple as it gets, and simply drag in or import the AdventureWorks logo. So to do that, in our Home tab, we're going to look at this Insert group of tools and simply click Image here. Now, I have a folder on my desktop called AdventureWorks. It's where I stash the data as well. I also have an AdventureWorks logo PNG file, which is available in the course resources. Go ahead and double click, and it just drops it right here on my canvas. So you can click and drag to move it around and reposition it. You can click and hover over the edges or the corners to resize, however you'd like. And we're going to be moving and tweaking this stuff quite a bit as we polish the design and layout. But for now, I want it somewhere right up here in the upper left corner of the dashboard. Now, taking a peek at some of these view tools, you can show the grid lines. And again, this is just a point of reference if you want to align your objects to horizontal or vertical lines. For now, I don't want that. We can snap our object to the grid. And that means when you move this around, it'll move kind of a chunky way. And it's chunking or snapping to an underlying grid. Again, another tool to help with alignment. So up to you if you want to enable or disable that one. And then lock objects is helpful. See, I can't even drag it and move it. And you'll see this can actually come into play once you have a number of different visuals on the same page. It can get very tough to kind of navigate through things without accidentally selecting and dragging your visuals. So that's the lock objects view. We're going to talk about the phone layout versus the desktop layout later on. And then page view, you can choose whatever option you want. Right now we're at fit to page, which will work just fine. Now, last item here, we've defaulted to page 1. Just double click to rename that page. And we're going to name this one Exec Summary and press enter. And there you go. Step 1 of our AdventureWorks dashboard is complete. All right, the time has come to officially add some true, proper visualizations to this dashboard. Now remember, there are a few ways to do it. Number 1, from the Home menu, click New Visual. As you can see, it's defaulted in this case to a stacked column. That's not what I want, so I'll press Delete. Instead of going with the Home menu route, I generally choose my visualizations straight from the visualizations pane. So in this case, I'd like a stacked bar chart specifically. And when you click and select a chart template, a few things happen. First, you'll see that it drops a template or placeholder for that chart right there on your canvas. And second, it populates these fields as well as formats that are specific to the chart type that you're using. So again, this pane is dynamic. Right now it's telling me that a stacked bar chart can take in an axis, a legend, values, color saturation, and tooltips. But if we change this chart type to something else, like a stacked area, you'll see these values change, or funnel, or scatter. So these are all dynamic, and they're all tied to the specific chart type. So let's jump back to our stacked bar and start actually populating this. Remember, we're always going to start here in fields because this tells Power BI what data we want to visualize, and exactly how we want to visualize it. So what I'd like to visualize here is total orders, that measure we created in our sales table. So let's go ahead and grab that measure. And the first option is to click, hold, and drag it into value and drop it there. And as you can see, it's populated the chart with a single series of values, total orders, with the grand total, just one bar. Now remember that if you want to format a field, you can do that here. Select total orders, modeling. In this case, let's add a comma to it. And now as you hover over, you'll see that the format has changed. So this is nice, but not very helpful. It just shows a single bar. So the idea here is that it will be helpful to break this data down and analyze the total orders in some interesting ways. And I know that AdventureWorks is very interested in their subcategory level performance. So let's go ahead and break down this chart by product subcategory name. And now remember how we clicked and dragged the values field? You can also try clicking the box, and Power BI will say, okay, what's the most appropriate place where I can populate that field that you just checked? In this case, it puts it on my axis of the bar chart, which is actually exactly what I want. It breaks down my total orders, and now I've got a field or a dimension for subcategory on each row. And it's automatically defaulted to sorting descending. Tells me that tires and tubes is the highest order driving subcategory, followed by road bikes, helmets, mountain bikes, etc. But just to get a sense of what these other options could do, what if we took subcategory name and instead of dragging it to axis, we dropped it on the legend? Well, that completely changes the visual, and it basically shows the grand total segmented out with a different legend value for each of the subcategories. So not the proper chart type here. I mean, it's kind of nice to look at, but it's not very helpful. So we're going to take that legend, drag it back to axis, because that's what we want. Now we know what values do. Values is almost always where you're going to pull your measures in. And now what about color saturation? If you're curious about what that does, honestly, the best way to learn this stuff is to just try it out and see how it looks. So let's grab our total revenue measure here, drag it into color saturation, and look at that. The chart itself is still showing the same data, but now as you hover over, it's giving you an additional piece of information, which is the actual revenue in addition to the orders. And not only that, but it's visualized in a subtle but very effective way the relative revenue of each of these subcategories. So they're still ordered by the order volume, but now you see these darker blue lines represent the subcategories driving the most revenue. In this case, road bikes drove 11.3 million in revenue, mountain bikes 8.6, touring bikes 3.8, and then these lighter shades are smaller amounts. So that's color saturation, which is a really nice way to add an additional level of data without making the chart overwhelmingly busy. And now we also have this option called tooltips here. And to show you what that does, let's grab total profit and drag it into tooltips. And you'll notice that nothing changes except the title now reflects total orders, total revenue, and total profit, which is the tooltip field that we just added. Now all it does is add a third piece of information to this box that pops up when you hover over. That's what Power BI calls a tooltip. So now by simply hovering over and interacting with this chart, I'm getting information about order volume, about revenue, and about profit broken down at the subcategory level. So very, very little effort, and we've already created a lot of very interesting insight with one simple visual. And trust me, it's only going to get better from here. All right, so in the last video, we talked about inserting and modifying basic visuals. We added our nice little bar chart here, talked about some features like color saturation and tooltips. But the thing is, Power BI has changed quite a bit since the course was originally recorded. We still have all the same functionality. It's just that some of these tools live in different places now. And I added an overlay to the last video to help people find these new features, specifically color saturation. But I still get a lot of questions about it, and I've realized that it's really hard to find those options. So what I want to do is just put together this very quick video, and we're going to rebuild that same chart using the current version of Power BI. So I'm in the, you'll see the light mode here. I'm in the 2020 January release. I'm going to insert a bar chart here, grab subcategory name, drop it on axis. I'm going to look for my orders, drop that on values. And there we go. We've got kind of our basic version of the bar chart. And now here's how we get to the color saturation option. Remember, originally it existed right here in the main fields pane. Now we have to navigate to format, which is the second pane here, drill into the data colors well, and you won't see any obvious color saturation or conditional formatting options right here. What you have to do is hover the cursor over the default color line until you see this ellipsis, the 3 dots. Click that, and there are the conditional formatting options. Don't ask me, I don't know why they buried this feature like that, especially given how popular and powerful conditional formatting is, but that's where you'll find it now that you know. You should be able to get there quite easily. So this menu should look pretty familiar. Let's go ahead and just drop a very light pale blue on our lowest value. We'll keep our highest value with this darker teal. And check this out. We can update which field we're actually formatting based on. So in this case, to match our demo, we wanted to do a color saturation format on total revenue. There we go. Press OK. And boom, we've replicated our original chart. Now, the only other catch was that we had the tooltips option in the fields list, which you'll still see here. When we dropped our revenue field into color saturation in the last demo, it automatically added revenue into our tooltips. Now, in the new version of Power BI, we need to manually make that change. So let's go ahead and grab the revenue field, drop it into tooltips, and there we go. We see it listed in the third line of our tooltips. So there you go. Hope that was helpful. Color saturation in the current versions of Power BI. Next up, we're going to talk about Power BI report formatting options. Now, this is all about customizing the look and feel of your visuals. The fact is, there are a ton of different formatting options, and they vary pretty drastically between chart types. So rather than show you every single option for every chart type, which wouldn't be a very effective use of time, I'm going to demonstrate what some of these sets of formatting options look like for different types of charts. And then we're going to go into Power BI and practice customizing the format for our stacked bar chart. So here we have 3 very different types of visuals. We've got a combo chart on the left, which is a line and column. We've got a matrix visual in the center and a donut chart on the right. Now, looking at formatting options for the line and column combo chart, you've got a number of different categories there: general, legend formatting, X and Y axis, data colors and labels, shapes, plot area, title background, lock aspect, and border. And within each of those, you have additional options. So just within the X-axis formatting options, for instance, you can change the type, the scale type, you can fix a starting or ending value, update the color, text size, font, and display mode. So these menus are packed with options, and those options, like everything else, dynamically update based on what you're working with. Now for the matrix view, you'll see a slightly different set of options here. Now you've got matrix style options, grid options, column and row headers, subtotals, grand totals, conditional formats. So that conditional formatting field is one of the more interesting ones here. That allows you to do things like add colored backgrounds, or change the font color, or add data bars dynamically to draw attention to high or low values as a visual indicator, similar to how we used the color saturation option in our bar chart. And then looking at donut chart options, again, it's got its own totally different set of options here. And drilling into some of these, you've got detail labels, where you can change the style and text and font settings, and then a title, which you can align and customize as you see fit. So again, thousands and thousands and thousands of different combinations of formatting rules that you could apply. But the good news is that A, Power BI's default styles and formats are actually pretty thoughtful and polished, more so than with other tools that I've used in the past. And B, It's all extremely user-friendly. So by simply poking around and testing out different combinations and variations, you'll pretty quickly get a grasp on what these options mean and how they all work. So with that, let's head back into Power BI, and we're going to explore some of the formatting options for the bar chart that we've added. Okay, so we're back on our canvas. You'll note that when I don't have the chart selected, I don't see my options here for either fields or formatting. So make sure that you select the chart that you're interested in, and now you'll see those fields populate. This time we're interested in the second tab of this pane called Format. And as you can see, we've got all of these categories of options, each of which includes sub-options for us to customize the look and feel of this chart. So I'm going to quickly pass through each of these, maybe touch upon a couple of the key concepts, but I'd recommend that you take some time to explore these menus on your own as well. So general, basically this is about height, width, positioning. Typically you won't really touch the general options. Y-axis has a bunch of options here. So this is everything related to the Y-axis of our chart. I'm going to drag it closer just so that it's side by side. So you can turn the entire axis on and off first and foremost. And when you turn it off, obviously those options are now inactive. But let's keep the Y-axis because I want to see those titles, those labels for each subcategory. You can change it from the left side to the right. You can change the color, the text size, even the font family. And then if we expand this out a bit so we can read, minimum category width, literally just give it a shot and see what happens. Just changes the actual width, in this case, almost like the height of each bar. Maximum size changes kind of the length of each bar. And then inner padding is if you don't want that blank space between bars, you can eliminate that entirely. Let's make this a little bit bigger. And then the last option here on the Y-axis is the title. So an axis title assigned to your Y. Keep that off. So let's say we've made some changes and now we've changed our mind and we actually don't like the updates we made. Every one of these menus has a yellow revert to default option on the bottom. And when you click, it takes me right back to where I started. So really helpful feature there. So those are Y-axis options. Very similar tools for the X-axis. So now I'm dealing with this horizontal axis down at the bottom. Some certain chart types will have different scales. In this case, it's just linear. That's the only option. Start and end will default to auto, but these basically say, do you want to customize the minimum and maximum values along that axis? So you could say, sure, instead of 10,000, let's have it go all the way to 30,000. And it essentially shrinks these bars down because my max is now 3 times larger. You can simply delete that to go back to auto. And again, we've got color, text, font, display the units in different ways, thousands, millions, decimal places, turn the X-axis title on and off, turn the grid lines on and off, change the grid line style. In this case, maybe we go with dashed and change them a little bit darker, like so. And those are our X-axis options. Now, data colors, you can see because we have a color saturation applied here, it gives us the option to customize this gradient that we're looking at here. Diverging basically just adds a third center point. You can see how it makes the middle values kind of this light, almost white color. We could customize this if we choose and say, let's make the minimum red, center maybe yellow, and the maximum this kind of greenish blue, almost like a rainbow. And then say, okay, never mind, we don't want that. Let's revert to default. And you're back to where you started. Data labels, this might be helpful here. So you can activate the labels and you'll see them populate here in your chart. Let's change the color to make them a little bit lighter. Let's go one more dark than that. There we go. And then those same number tools, display units, decimal places. You can position them inside of the bars, outside, automatic, change how they react to overflow when the chart's resized, and then change the text size, font, and background will basically just put a little bar behind it. So I think this is good. They're light, they're very subtle, but they're there if you need them. Let's go one size up to 9. And those are the data label options there. plot area, not much to do here. You can add an image behind the chart. Since there's nothing behind it, transparency is not going to do anything. Chart title, this is one that I do want to update here because it defaults, auto-populates based on the fields you've dragged in. So right now the title is kind of awkward. It's total orders, total revenue, and total profit by subcategory name. So let's simplify that a little bit because we're really just focusing on total orders by subcategory. There we go. And there you go. It's updated the title. And what I'd like to do, you can add a background and a font color. So I'm going to add kind of a darker gray and a light font color. Kind of make that title pop a little bit. I'm going to align the title in the center and let's make it bigger to a size 12. And again, you can change font family. You can follow along exactly how I'm doing this, or you can format using your own style. Totally up to you. So those are the title changes that I'd like to make. Background, you can turn on or off. Just sets basically a background color, like so, and a level of transparency. In this case, I don't want the background. Lock aspect ratio. This just says when you resize the chart, do you want to keep the exact proportions? So this fixes the proportions. When that's off, now you can kind of resize however you want. And then our last option here is the border, on or off. That one's a simple one. So let's keep the border off unless you choose to keep it. Totally up to you. So that was a lot of options, a lot of formatting tools, but we've made a couple tweaks here. We've added data labels. We tweaked our X grid lines, made them dashed, and then updated our title here as well. So again, you'll come across some other formatting options when you start dealing with other types of visuals, but for the most part, they're as simple as those ones that we just walked through. So there you have it, chart formatting options. All right, next up, we're going to talk about the incredibly powerful filtering options of Power BI reporting. Now, within the filters view of the report pane, you'll see 4 primary filter types. First, you have visual level filters. Now, these are the most narrow of scope. They apply only to the specific visual in which they are defined. Next up, you have page level filters, and any filters applied at the page level will impact any visuals on that specific page or tab of the report. So they're broader than visual level filters, but more narrow than the third type, which is a report level filter. Report level filters are the broadest of all. They apply to all visuals across all pages of the report. So this is where you'd use a blanket filter that you want to just apply universally. Now keep in mind that DAX filter measures, like all or filter, can still change and overwrite the context created by report level filter. So there's a lot of interplay here between filter context being created in different types of ways, and we'll talk more about that throughout the section. The fourth type of filter is a drill through. This one's a little bit different, and we're going to dedicate an entire video just to drill through filters, but basically they apply to pages, so it's similar level as a page level filter, but they dynamically change based on user click paths. So they're really useful tools and certainly worth a video of their own. Now, across all filters, you have a number of different settings. You've got your basic options, which are like checkboxes. You can select one, all, or multiple items. You've got top end filtering, which lets you say, filter down this visual or this page or this report to the top number of items based on some quantitative value. In this example here, we're filtering down to just the top 2 items based on total orders, which is a measure. And then you have advanced options, which look a little bit different, whether you're dealing with a value field or a text field. But this is basically the same idea as those value or label filters that you would find in Excel or in a pivot table or in other tools. So if you're dealing with values, you've got logicals like less than, greater than or equal to, etc. And for text, you have contains, does not contain, starts with, is not, is blank, etc. So let's jump back to our report and see exactly how these things work. All right, so check this out. what I want to do is add another bar chart to help demonstrate how these filters work. But instead of creating a new one from scratch and then having to recreate my formatting, I can select my existing one, press Ctrl C to copy, and then Ctrl V to paste another version of it right here on the canvas. And now for this one, instead of showing subcategory, I want to display this chart by category, so a little higher level. Now I can just go ahead and find the product category lookup, and instead of removing subcategory, I'm just going to take category name and drag it in above subcategory. And what it does is it shows me the highest level data, which is category, but now allows me to drill down with this button in the top left, the double down arrow, to take me down to the next level. And this works just like the matrix view worked as we were QAing and spot checking our measures, but now we're able to do this same thing with a visual representation. So I do want to make a couple tweaks to this category level view. For one, I'm going to remove the color saturation here so that it's one solid color. Then I'm going to go into the formatting, and I do need to change the title since it still says orders by subcategory. So I'm going to just change that to orders by category. And there we go. Now, as far as filtering in a report is concerned, the simplest way to filter has nothing to do with the filter pane. I don't have to drag any fields or do anything except click into my charts. And you see what's going on here? As I click into my category chart, my subcategory chart updates as well. And that's not just because I copied and pasted a second version of this chart. Even if I created a brand new one from scratch, that interaction would still take place by default. So what's happening here in technical terms is that my selection, like when I select the bikes category, for instance, is creating filter context that's impacting everything on this report page, in this case, including my subcategory chart. So with a simple click of the mouse, I'm already able to drill in and explore and see trends in this data that otherwise might be very difficult to see. And to make it even more visible, I'm going to go ahead and pull the color saturation off of my subcategory chart as well. And now you can see very clearly which subcategories fall into certain categories. So bikes, clothing, and accessories. Now to show you how the actual filter pane works, I'm going to copy this category level chart that we created, and let's go ahead and add a page and paste it right here on this page. Now returning to our exec summary, I'm going to select the category chart and scroll down to my filters pane right here. And you can see by default, it's pulled in all of the fields and dimensions that are currently part of my chart. And you can go ahead and drill in and see your filtering options right there for each. And by default, these are placed in the visual level filters window of that filters pane. So for instance, I could say, I only want this chart or this visual to show bikes, or only bikes and clothing. And you see how those changes are only being impacted in this chart. They're only reflected here. My subcategories still show all of my subcategories across all categories. So this filter is essentially constricted to the universe of just this visual. So those are my basic filtering options. Let's quickly take a look at some of the others. I could say, show me the top N items, which are categories in this case. Let's say top 2, since we only have 3 to work with. And the by value is basically how are you defining top 2? How are you defining those ranks? So we could say, let's show us the top 2 by profit. And we click apply. We get accessories and bikes. Clothing disappears because clothing did not make the top 2 as far as profit driving categories are concerned. So we change our mind. You can click this little eraser icon to clear that filter. And then you've got your advanced options here, which really aren't that advanced. They're just those text or label specific fields like contains, does not contain, start with. These are pretty straightforward. So I added a filter for categories starting with B and applied it. There you go. I only see bikes. Now if I say does not contain bikes and apply it, now I see accessories and clothing. So these are all very user-friendly, very straightforward. The most important thing to remember is the scope in which your filter is applied. So everything we just did was visual level. It only impacted this chart. Now let's practice a page level filter. So what I'll need to do is grab a product category name again. I'm going to drop it into page level, and now watch what happens when I select bikes. See how both charts on the page were impacted? Same thing if I add clothing and then add components. Well, components weren't sold, so if we add accessories, there you go. Now we're back to 100%. So we're using the same filtering tools, except now instead of just impacting one chart, it's impacting our second chart and potentially any other charts that might exist on this page. Now the important thing to note, let's go ahead and select bikes alone again, is that if we jump to page 2, this visual is on a different page, so it's not impacted by a page level filter that was implemented on the exec summary tab. Only visuals on this tab, on this page, will be impacted by a page level filter. So let's go ahead and clear that one. And again, we're going to cover drill throughs in its own separate deep dive. But what I'm going to do is grab another copy of category name and pull it into the report level filters. And now, very similar idea, select bikes, filter down, and click to page 1. This one's filtered down as well. So as you can see, report level filters are the universal filters that impact everything in the entire file. So let's go ahead and clear these. I'll erase that. Don't need a page level filter here. So now a little bit of formatting, rearranging here. I'm just going to make these a little bit skinnier. And like I said, we're going to keep kind of tweaking and adjusting as we go. You can follow along exactly if you'd like, or you can kind of follow along loosely or not follow along at all. It's totally up to you. So I'm going to start kind of with something like this. And again, we could snap to grid if we wanted it to be exact and perfect. But this looks good for now. We're going to tweak some things a little bit more as we go. So those are the filter settings and the core types of filters in the Power BI report view. So as you can see, they're really, really powerful, and they're going to allow us to do some really interesting and pretty advanced things. So now that we've covered the field options, the formatting options, and the filtering options, the next phase of this section is going to be demo mode. So from here, we're just going to play with all different types of visuals. We're going to add matrix views, slicers, timelines, KPIs, text cards, maps, tree maps, gauges, and so on and so forth. We're going to add a whole bunch of visuals to build out this dashboard. And then from there, we'll start exploring some of the more advanced or nuanced concepts, like adding drill through filters, customizing visual interactions, adding bookmarks, parameters, and some other really interesting tools. So there you have it. Those are your Power BI report filter options. So at this point in the course, it's time to shift gears into demo mode. So no more slides for a little while, no more broad concepts. It's time to roll up our sleeves, stick right here in our reporting pane in Power BI, and focus on individual chart types and visualizations that we can use to build out this report view. So looking at what we have here, we've got orders by category, got order info by subcategory as well. We know that our AdventureWorks client really cares about product level performance too, not only in terms of orders, but in terms of how frequently certain products are being returned. So I need to capture some of that data here in our executive summary. And what I'd suggest that we do is use a matrix, which you're already familiar with. We use this quite a bit in the DAX section of the course. And this is a great way to show a lot of information without it being overwhelming. So we'll use some of the drill through capability here and some conditional formatting to make the numbers really pop. Now the data that I want to show lives in the sales table. So let's go ahead and grab total orders. We're going to pull that into values. And let's also pull return rate from our returns table as well. So we've got two columns of values, and the level at which we want to view these values, or the row labels that we want to use to segment them, will come from the product lookup table. And we actually want the product name. So I'll drag that into rows, expand this down a bit. So now we're looking at total orders and return rates at the product level. And one thing that's cool about these matrix views is that you can just click on the header and it will sort. So we can default to sort the products that drove the most orders. So in this case, we see that water bottle, 30-ounce water bottle drove the most orders, followed by the patch kit and then tire tubes. Now this is good. It's a lot of information here, but one thing that I think we can do to really make this come to life a bit more is add some conditional formatting. So we can go ahead and navigate to the format pane. And obviously you've got matrix specific formatting here. You can change different kind of matrix styles if you want. And again, you can always revert to the default. And generally speaking, the default is actually going to serve our purposes pretty well in most of these cases. So I'm not going to mess with tons of different formatting options as we build this out. But what I will do here is go all the way down to conditional formatting. And it lets you format each series individually. So starting with total orders, for this one, I want to add data bars. And you can see what each of these looks like. So those are data bars. That's the font color. And this is the background. So font color and background work same kind of way. It's just you're either updating just the font itself or the whole background of the cell. So for this total orders column, because it's a volume column, I kind of like using data bars. And that will really draw attention to the difference between some of our top drivers and some of our lower driver products in terms of orders. So I can stay right here in the formatting pane and format return rate. And instead of data bars for the return rate, because they're going to be kind of all over the place, what I'd rather do here is kind of a subtle background conditional format. So this is not subtle, this is very loud and aggressive. What I can do is drill into my advanced controls here and determine exactly what this gradient for my conditional format should look like. And in this case, instead of this crazy green to red scale, for something like return rate, which is a negative metric, what I'm going to do is reverse this first of all, because high values of return rate, that's a bad thing, not a good thing. And I'm going to adjust the colors themselves to make them a little bit more muted. So the maximum, meaning for bad return rates, I want this kind of pale red. And for the minimum, I want a white. So this basically means that products with an okay return rate or relatively low return rate will show up as white. There won't be huge negative attention drawn to them. And only the ones that really start to have some of the higher levels of return rates will start to pop with this red shading. So let's press OK there. And as you can see, it's pretty subtle, but in this case, it does get the job done. So you can see certain cases where individual products are popping a little bit more, like this Rhodes 650, whereas the other ones with kind of average or decent below average return rates, those kind of just fade in with this white background. So feel free to make your own adjustments, but that's kind of my personal style. Keep it a little bit more muted while still drawing attention to the key trends. Now, last thing that I want to do with this matrix view is go back to fields, and instead of only showing the data by product, just like I showed you before, let's go ahead and grab the subcategory, which is beneath my product lookup. Bring the subcategory name in, as well as the category name. And then you know the drill, no pun intended. You can drill all the way back down. So now I'm seeing that same product level view, but I've just given the user the option to aggregate if they choose to do so. And one last note here, that little forked arrow, the third option, that will expand down all the way one by one until you're seeing not only the lowest level, the products, but you're also seeing them grouped into subcategories and then into categories. This is very much like the outline table layout in a pivot table in Excel. So just go ahead and drill back up and then back down to get back to where we started. So I love these matrix views. I think they're incredibly useful and insightful. They pack a ton of information, and these conditional formatting tools are great ways to to really bring some of that data to life and expose some interesting patterns. So there you go. That's your report matrix view. All right, next up, let's talk about slicers. And you'll see the slicer icon. For me, it's in the lower corner. It looks like a little table with a funnel on top of it. And basically, a slicer is a fancy word for a visual filter. So it behaves just like any other filter, and it applies filter context just like any other type of visualization. And it's a very simple object. It only takes one input, which is some field. So if we were to take something from territories, for instance, and drag country in, it just creates a list of checkboxes. And again, these pass filter context, just like any other filter or visual. You can clear them like this. You can also format this as a dropdown, which behaves exactly the same way, just a little bit of a stylistic difference. So nothing special about regular slicers. They act just like slicers in a pivot table in Excel as well, but where they get really interesting is when you pull in a date field. So let's go into our calendar, grab date, and swap that in place of country. And you might be thinking, okay, well, what's so great about that? It's the same exact thing. You're just listing hundreds and hundreds of dates. Well, the thing is, we've got additional options now. Check this out. So between is actually my personal favorite. Between allows a user to set a start date and an end date by dragging these handles on a timeline and customizing the exact date range that you're looking at. You can also type fields and use this calendar pop-up, which is really, really slick, in each of these input boxes. So that's the before option. The between option. Before basically just gives you the end date to play with. After only gives you the start date. And then you can do the normal list or drop down. The last one that's really interesting is relative. And so this allows you to choose things like show me the data from the last 30 days, right? Or the next, or this week, or this year, whatever it could be, any combination of these fields. Now you might be wondering, why did everything blank out when it shows 30 days? Well, look at the date range. This is current data. It's based on actual real-time information, not the data in my data model's calendar. So that particular option is really great when you have current real-time data. You could use this relative option. For now, I think between is going to be our best bet so that we'll have full customization over the window of data that we look at. Now, stylistically, only a couple changes that I think we should make to this formatting. Go into Format tab. I don't want the header, it's just redundant. It's pretty clear that we're looking at dates here. And for the date input formatting, let's just give it kind of a light gray background to make those numbers jump off the page a little bit more. And there we go. So let's kind of position this up here. We can resize it. I like putting my main controls kind of at the top to make it clear, that these are impacting everything you're seeing on this page. Now, already this date slicer is going to be useful because see what happens when we start looking at 2015 dates alone. All we have are bike category sales, and because we only have bikes being sold, there's only a handful of subcategories, in this case road bikes and mountain bikes, and obviously all of our products are bike-related products. So something changed in AdventureWorks' sales strategy or their corporate structure where they didn't start selling other items until it looks like later in 2016. So turns out that they're not really interested in analyzing the data from 2015. It was kind of a different world. They were just a little bike shop back then. So good opportunity to use a report level filter here. And what I'll do is, I'm not selecting any specific visual. I'm going to go and grab that year column from my calendar, drop it into report level filters. And then what we can do is set a basic filter type and select 2016 and 2017. And you see that it basically just summarized what I'm doing here. Year is 2016 or 2017. And now everything in here now reflects that report level filter. Even the timeline itself, I can no longer extend my start date before January 1st, 2016. So now I can be sure that the date ranges that we're looking at here, with the exception of some early dates in 2016, should reflect all of the categories that AdventureWorks is selling. Now, a little tease into one of the more advanced concepts here called syncing slicers. You may have noticed on the View tab, there's this option here in the Show group that says Sync Slicers. That opens up a menu that allows me to determine basically the scope of impact that this slicer has, because generally these visuals are going to impact other visuals on the same page. In other words, their filter context will apply to visuals on that same page. But slicers, if you want kind of a more universal control, in a similar way that you would set a report level filter, you can allow a slicer to sync with other pages and therefore control the data and the visuals without having to duplicate and have two different versions of the same slicer operating on two different wavelengths. So right now it's showing me that I have two pages in my report, exec summary and page 1. If I show the filter and sync it on both the exec summary and the page 1 sheet, what this is going to do is create a copy of this timeline, and it's going to put one right here on page 1. And not only that, but when I make a change to one of them, like to 7.1, the other changes as well. So these are now synced together, and both the slicer and the reports or the visuals on those pages are adjusting accordingly. So that's a great way to make your kind of controls apply not only to the current page and not only to the entire report, but potentially to only specific pages or combinations of pages. So in this case, I don't actually want to sync that. We can close the sync slicers view. And in fact, we don't even need this page 1 anymore. It's kind of just scrap anyway. So let's delete that page. And there we go. We've got our date slicer here, our matrix, our bar charts. Things are coming along pretty nicely. Next up, we're going to dig into cards and KPIs. All right, I'm really excited about this next demo. I'm going to talk to you about cards. And it doesn't sound that exciting, but trust me, it's pretty cool. So we've got 3 types of cards that you'll find in here. Single row or regular card, looks like a 1, 2, 3 icon. A multi-row card, and my personal favorite, the KPI card. So these are all great ways to draw a lot of attention to very big or very important numbers, or KPIs, key performance indicators. And let's start with our basic card, and it's a very simple object, requires 1 field input. Okay, so let's go into sales, and if our focus right now is on revenue, let's go ahead and bring revenue into the fields box. And there you go. You have literally just created a card. That's it. 1 step and you're done. There aren't even really many formatting options for cards as well. You can give it a little background, change the font, but for all intents and purposes, that's it as far as cards are concerned. Now, instead of deleting this and adding a new visual, with the card selected, I can change the visual type to a multi-row card. And it changes the format, the look and feel a little bit. And more importantly, it now allows me to drag in additional fields, like total orders, for instance, and kind of show them side by side. If you resize, they'll stack differently. So again, it's a nice way to just literally draw attention to individual numbers in your report. So cards and multi-row cards are fine, and we'll use them in a couple different cases. But in this lecture, I really want to focus on KPIs. So we're going to insert this KPI. It's got the up green arrow and the down red arrow. And this is not only going to allow us to show a big important number, but it's also going to integrate elements of trending and of positive or negative performance all within the same view in a really nice, clean, visual way. So let me show you what I mean by that. We're going to focus on revenue as a key number here. So I'm going to take total revenue. I'm going to drag it into this field that says indicator, okay? And it doesn't do anything just yet because the KPI card needs some more inputs. In fact, it says right here, it needs a value and a trend axis. So what does that mean by trend axis? Well, it means that you care about total revenue, but instead of just showing the overall total revenue number, in which case you'd use a regular card, What time period are we interested in? At what level do we want to show the trending performance? And what current period do we want to be reflected in this card? So we're going to need a date-related field. Let's drill into our calendar. And this will just determine the level of granularity that we want to show revenue trending within the card. Now, I think month is probably a good level. It's not too granular, it's not too broad. So I'm going to take start of month and drop it into the trend axis. And check that out. Without even doing anything else, it's already given me a really insightful view here, showing that revenue trend in the background over time, month by month, as well as the current month revenue total, big and bold right in the center of the card. So remember, that trend axis not only determined that trending area in the background, it also determined what time period this number reflects. And since we're trending at the monthly level, this revenue shows current month. And to validate that, we can actually insert a matrix just for a little QA. I actually find myself doing this kind of thing quite a bit. And we can pull in total revenue to the values and that same start of month into our rows. And remember how it kind of automatically creates that hierarchy. Just want start of month. And there you go. So you can see that the latest month drove $1.8 million of revenue, which is reflected here. So far so good, but you'll notice that the KPI card takes one more field. It's optional, but it takes it. It's called the target goals field. And what this will do is add one more layer of insight here and indicate whether this 1.83 million monthly revenue figure is good or bad. And how we define good or bad is a function of whatever we use for the target goal. Now, there are two options that I can think of off the top of my head that would be valid choices for a target goal. Number one is our revenue target that we actually defined. And if you recall, looking at the DAX, it's our previous month times 1.1, basically a 10% lift over previous month. Now, we're going to be using these targets for both orders and revenues on the product specific page a little bit later on. So I'm going to hold off on that one for now. And in this case, for this KPI card, what I'm going to use as my target goal is just the previous month's revenue. So when we drag it in and drop it into target, we get that nice little check mark. It all formats to a nice green. And it also shows me the value of that target goal, which is previous month revenue, 1.77 million, which again, we can confirm and validate here in our little matrix view. So that's a KPI card. Fantastic way to draw a lot of attention to the most important numbers for your business. And since AdventureWorks is very much interested in their revenue, in their order volume, and in their returns, I think it would make sense for us to create cards to capture those three KPIs. So no need to reinvent the wheel. Let's copy this one, paste another version down here, and instead of revenue, we're going to basically go through the same process for total orders. So swap in orders instead of revenue. Instead of the target goal being previous month revenue, we want previous month orders. And there you go. We can also pull orders into our matrix to help QA that field as well. Total orders. Okay, so current month total orders 2146, which is correct. And it's just barely down, less than 1% compared to last month, 2165. So essentially flat, but a little bit down month over month here. So now one more, we're going to copy the order one, paste it one more time. And this time I want to show a KPI card for returns. So you know the drill at this point. We're going to go into our returns table this time, grab our total returns, swap them in for total orders, get rid of the order target, and pull in previous month returns. Now wait, we got fewer returns and it's formatting red as if that's a bad thing. And the fact is fewer returns is good. We want to see a drop in returns month over month. So no fear, there's actually a very easy way to change that. And that's to go right into our formatting options, color coding, direction. See how it says high is good? Just change it right to low is good. And now if it's a drop month over month, that's a good trend. So there you go. Now we've got KPI cards for revenue, for orders, for returns. We can go ahead and get rid of our matrix here. And last thing, probably should have done this first, but let's go ahead and just change the titles here. Instead of this wordy total revenue and previous month revenue, let's just call this monthly revenue. Let's name this one monthly orders. And finally, monthly returns. And the final step is just to arrange things in a way that looks nice. I think in this case, I'm going to try to create some room here. And I really want to focus on revenue as the number one most important KPI. So I want this one to be kind of larger. And then maybe we put orders up here in the top right and returns in here. I'm obviously squishing things in because we've got more visuals that we'll be adding shortly. And again, you can kind of adjust this as you see fit. But for now, I think something like this will do just fine. So there you go. We've created this pretty simple yet pretty impactful way to show the most important business metrics for AdventureWorks: revenue, returns, and orders. So there you go. Great demo of how to use KPI cards with goals to draw attention to the most important metrics for the business. All of the demos that we just walked through with cards, multi-row cards, and KPI cards were based on quantitative or numerical values: revenue, orders, returns. But cards can actually serve another important purpose, and that's to visualize text-based fields. So to show you how that works, let's go ahead and grab the standard card. And now instead of pulling a numerical column or measure into our fields option here, I'm going to grab a text-based field from my product table. In this case, I want the product name. I'm going to drag it in. So you'll see that it automatically populates a value, all-purpose bike stand, and it says this is the first product name. So what exactly does that mean, and why did it choose all-purpose bike stand to visualize here? Because we haven't really given it any context or any conditions to work from. So in the fields list, you'll see this little drop down, and it gives me options here: first, last, distinct count, or count. Since that's really all I can do with text fields, I can't sum them or average them or do any other sort of aggregation to them. So it's defaulting to first, which you may have realized by now, that's first alphabetically. So if we change it to last, you'll see women's tights, small. Now, neither last nor first is very helpful in this case because, what's the point of a card in a dashboard that just simply returns the first product name alphabetically, right? So this is where our filters are going to come into play, and specifically that top N filter that we hinted at earlier in the section. So if we take a look at our filters pane here, you'll see by default it's dragged a copy of our first product name field here in the visual level filters, but we don't have all of the options that we need here. All we have is a contains filter here, which isn't going to really do the trick. So what we can do is actually grab another instance of product name and drag it underneath, and that will give us access to the additional filtering options, the advanced filtering and the top N filtering. So in this case, what we're looking for is top N, and that way we can define which item is returned based on some numerical field. So one thing that I think might be helpful for us to show in this report for AdventureWorks is the top product in terms of order quantity, and perhaps also the top product in terms of revenue or profit. So that's pretty simple when you're able to use these top N filters. We can say show the top one item by a certain value, and let's start with our sales table. Let's make this one the top product by order quantity. So we'll grab total orders, drag it in, and apply. So then we get water bottle, 30-ounce water bottle, and in our matrix here, we already have the view set up to show products ranked by total orders, and that is indeed the top item on the list. And this, just like any other visual, will change dynamically as you adjust different filters in the report. So now we're filtered on bikes. The top selling or top ordered bike is the Mountain 200 Black size 46. So pretty helpful to have that text insight held here in the card visual. Now, a couple formatting tweaks I'd like to make. We don't need the category label because it says first product name. We could customize that, but rather than use category labels, let's actually turn on the title. And we can give this a title like top product, and then in parentheses, orders. There you go, it pops it in right there. Let's make that pop a little bit more, kind of using a similar theme that we used with our bar charts on the left. And I'll center it here, maybe bump it up to size 9 or 10. And that's good for the title. Maybe we give it a little bit of a background so that it doesn't completely blend into the page. Maybe kind of this light yellow shade here. And then last thing, if we wanted to change the actual data label itself, maybe the font, maybe make it a little bit bold. Something like that looks nice. So top product based on orders is that 30-ounce water bottle. And now let's copy that, paste another one. And all we're going to do here is, instead of filtering top one product by orders, this time why don't we show the top product by profit? Just swap it in and apply. Head into our formatting and just tweak the title so that instead of saying orders, we say profit. There we go. Top product based on orders, top product based on profit. And we can align these. Speaking of alignment, one thing I forgot to mention that can be really helpful for formatting and tweaking and polish. These charts and graphs and tables, these work just like any other object in many other tools, where you can control click to select multiple ones. And from your formatting tab here, you have options that you'd see in tools like PowerPoint, where you can align things. In this case, I just aligned all of those shapes along this left edge. You can bring things forward, push them back. Really helpful tools just to get that polish just right. And it's as simple as that. Good example of how to use cards to visualize text-based fields. All right, I want to take a minute to talk about Power BI's map tools. Now, I've used mapping software in a lot of different places, a lot of different tools, and I can honestly say that Power BI has done it better than anyone else. It's powerful, it's flexible, and most importantly, it's incredibly user-friendly. You don't need to find data at the latitude and longitude level. You don't need to look up coordinates. If you have any sort of geospatial indicator, a town name, a zip code, a country, a continent, chances are Power BI will be able to very smoothly integrate it into its map visuals. So let's take a look at how that works. If you look at your visualizations pane, you'll actually see 3 different mapping options. This plain white globe is the standard map option. You also have a filled map option, as well as the ArcGIS maps for Power BI. Now they all work in a very similar way. They all take very similar fields, but they each have kind of their own flavor. And I'll show you a couple comparisons. But we're going to start with the basic map, and it's going to drop it right in here, right in the slot that we have left. And you can see by the fields list, it's going to ask for some sort of a location indicator. And lucky for us, we've got a territory lookup with continent and country, which we had already categorized in the datasheet as countries and continents. So they've got that little globe icon. That means we know Power BI is going to be able to handle these fields. Let's grab country and drop it into location. And immediately we get some sort of mapping happening. And what's going on, there's no data being visualized yet. There's no legend, no values, just kind of points that are pinpointing the different countries: Germany, France, UK, US, Canada. So it's a good start, but we're not quite there yet. we need to give it some sort of values to actually compare and visualize for us. So if we want to show country level performance by something like orders, which is one of our KPIs, we could grab total orders, and there are a couple places to put it, either size or color saturation. So I'll show you color saturation first because it's very, very subtle. You see that the size of the bubbles stayed exactly the same. They just got a little bit lighter, and they're actually so small that they're almost impossible to see. So I don't think that's going to be a very good option for us. Let's drag it over to size instead, and that's a little better. So you see larger bubbles now for the US at 7,851 orders. Australia's a little bit lower, 5,212, and then the European countries are in the 2000s. So to compare the other map types here, I'll show you what these look like. I can just switch the type to a filled map. It's very similar, but now it just kind of fills in the outline of the countries as opposed to putting bubbles or dots over them. So if you prefer this style, you can go ahead and stick with it. That's totally fine. Notice that the size option disappears and our total orders field has been shifted into the color saturation option, since that's the only place where values make sense here, aside from tooltips. So pretty interesting. You also have the ArcGIS option, which is a little bit more sophisticated. It's also a little bit slower and a little bit clunkier. You can see it's kind of dynamic as far as highlighting country outlines and shapes are concerned. But again, kind of slow, a little bit clunky to load. So I'm going to stick back to our original map option. And now, because viewing this at a global level isn't really that insightful, I'd like to have easy controls to drill in at least to specific continents. And that will help kind of narrow the focus or the view of this map to give us something a little bit more user-friendly. So before we do anything else, let's make a couple formatting tweaks. We actually don't need this title here, so we'll turn the title off, drag it down a bit. And one last adjustment, we're showing the bubble size by total orders, but we can also pack a lot more information for each country using the tooltips. So let's go ahead and pull total revenue as well as total profit into those tooltips. And remember, you don't see those up front, they just get embedded. So now hovering over these areas shows you not only the orders, but also the revenue and profit. So a lot of information kind of tucked away in this map. Now, in order to give the users a means of drilling into more specific areas, what we can do is add a slicer. And instead of a date slicer, like we practiced the first time, this time I want to use the continent field and just drop it in. But instead of a vertical list of checkboxes or a drop down, there's another style that's actually going to work really, really well for this layout. And that's the horizontal style with buttons. And I can access that through the formatting tools, and it's actually in the general category. And where it says orientation vertical, we're going to change that to horizontal, and we're going to resize this to fit really nicely right into this little space above the map. And one other thing that we can change while we're in the formatting here is it's only got single selection options for Pacific, North America, and Europe. But if we drill into selection controls, we can add a select all option, which adds one more button here. And we can delete that header or deactivate that header that says continent. And I think that should just about do it. We'll resize a little bit, kind of fit it nicely in here. So now when you select an individual continent, the map will go ahead and zoom in to that particular area, which makes it a bit more readable and a bit easier to interact with these different types of tooltips. So remember, one of the key criteria that our AdventureWorks clients needed to see was performance by sales territory. And by creating this map and these user-friendly slicers, we're able to provide an entire view focused on each core sales territory. So let's go ahead and select all. And there you have it. That just about fills out our executive summary. We've packed a lot of information in here, but kept things relatively clean and organized and tight. We used the matrix views, bar charts, KPI cards, text cards, maps, and a date slicer, and we are only just getting started. Next up, we're going to take a quick look at the tree map visuals and then start building out an entirely new product-focused page. All right, next up, I want to do a quick demo of what I feel is one of the most underrated chart types, the tree map. And you'll find the tree map right here in the visuals pane. Looks like a little box split up into smaller boxes, which is exactly what the visual is going to look like. And obviously we're a little tight on space. I don't want to squeeze it in here, try to resize anything we already have. So I think it would be a good idea to modify our total orders by category bar chart here, because the way we're showing data in this view actually lends itself very, very well to a tree map visual. And I'll show you what I mean right now. With one click, we can convert that from a bar into a tree map. And basically a tree map is designed to show composition. So in this case, we're seeing how the total order volume breaks down into different categories and segments, in this case, product categories. So without even looking at the data labels themselves, you can get a very clear, very quick picture of relative volume and proportion here. So you can see that accessories drove the largest order share, followed by bikes, followed by clothing, by simply comparing the size of the rectangles that they make up. And in fact, one thing that I really like about tree map visuals is that they can be extremely effective without showing a single number at all. So to show you that, let's actually go into labels, and I'm going to turn off the data labels entirely. So now we're not seeing a single number, yet we're still communicating a very clear story about how those order volumes break down by product category. And of course, we still have our tooltips, which kind of embeds deeper information if the user chooses to access it. Otherwise, it's a very simple, very clean, yet very effective visual. And now remember, because we also have subcategory built in here as well into the fields list, that means we have access to our drill down capabilities. So check it out. Here's a tree map by subcategory. And the way to read this, again, is just by looking at the relative sizes of the rectangles for each subcategory. So you've got tires and tubes starting in the upper left, helmets, road bikes, bottles and cages, mountain bikes, and then you start getting into smaller and smaller and smaller fractions of that total order volume until you're down here at bike stands, which is the lowest volume, which you see is reflected right here in the bar chart as well. So obviously our title might need to change if we're allowing viewers to see this tree map by either category or subcategory. But let's drill back up. We'll default to showing it by category. And there you have it. I think that gives us kind of a nice balance. We've got some visuals that are very dense, very information heavy. We've got others that are designed to really just draw attention to key business metrics. We've got purely visual designs as well, plus user controls so that our clients can completely customize the view that they're looking at. So I'm really happy with this executive summary view. I think it serves its purpose. Next up, we're going to continue to dig into a few different visual types, start exploring some more advanced tools, and build out a new tab to really dig deep into product-specific performance. All right, so our exec summary is a wrap. It looks great. Time to add a new page to our report. So just click that plus sign, double click to give it a new name. We're going to call it Product Detail. Now, if you hadn't guessed by the title, this page is going to be all about products. And we know that AdventureWorks wants the ability to drill down to individual product performance. And not only that, but be able to track things like order volume against targets, see how revenue has paced over time, understand forecasted future profits, and they even want to see the impact that various pricing adjustments would have on their company's profit. So it all sounds very complicated, but what we're going to do is break down those questions piece by piece and build a view that can answer all of them and more. So first things first, can't create a report page without a logo. So let's copy that AdventureWorks logo, drop it in here. And now what you may have noticed about our exec summary is that it provides a ton of information, but what it does not provide is a clear sense of trending. So we can see at this current point in time, how are we doing? how's our proportion of order volume, what are my top products by orders and profit, and so on and so forth. You can, of course, change the date slider to get a sense of trending, but it's very manual and it's kind of embedded into the view. So what we're going to do in our product detail right off the bat is create some trending insight using line and area charts, which are designed for that. So let's grab a line chart first. It's right here in the top left, and kind of stretch it out. Now, what we're going to show here is profit trending. So it's in my sales table. We're going to go down to our total profit measure here, drag it into values. And when we do that, we don't really get anything helpful. We get a single point with the total profit. So to make this line chart meaningful, we need to provide or define an x-axis. And we're going to do that by picking a date field to determine the granularity that we want to track profit over time. So let's head to our calendar lookup up here at the top. And we've been doing a lot of monthly views. Let's get a little bit more specific, a little bit more detailed, and grab start of week. And we're going to drop that into the axis window. And we don't want these weeks rolled up. We actually just want the start of week. And there you go. So we're seeing a very clear pattern and trend of weekly profit over time, all the way to our current week, which is the end of June. So that's a great start. Formatting looks nice. Don't need to change anything with my y-axis or x-axis labels. What I will do is tweak the title in my formatting pane. So let's drill into title and just name it weekly profit. And there you go. We just built a line chart. Super simple. Now to show you an area, I want to copy this line chart, Control V to paste it. I'm going to drag it right here underneath. And in this case, we're going to visualize returns. So head into our field list here. We're going to need to drill into our returns table. Grab that total returns measure, drop that one in, and we'll pull profit out. Now, first things first, we'll need to change our title. Instead of weekly profit, now we're looking at weekly return volume. There we go. And to stick with our theme of representing negative metrics like returns in red, let's go ahead and adjust the data colors while we're in here as well. So I'm going to make it kind of a mid-red like that. And now let's change this from a line to an area. And basically the only difference between a simple line chart and a simple area chart when you're viewing one series of data is that the area chart is filled. So think of it like a line with fill underneath it. So didn't really add much value here by changing it from a line to an area. Generally speaking, where area charts really shine is when you're comparing multiple series. So to give you a little demo, we'll head back to fields and you'll want to drag something into the legend. And this is basically what categories do you want to use to break down your data, your return data. And for something like this, you want to use a category that doesn't have many unique values because things can get overwhelming pretty quickly with area charts. So a good candidate here would be our product category, which only has 3 active category names. So when we drag category name into the legend, you'll see that it's created all 3 series kind of overlapping each other. So you've got the red series, which is clothing. You've got the green series, which is accessories, and the gray kind of behind here, which is bikes. So some people really like the default overlapping area chart. I actually prefer a variation of the area called the stacked area chart, which takes those same series and it literally stacks them on top of each other. So there's no overlap whatsoever. Now you can clearly see both composition as well as trending. In other words, by tracking the top line of this list, you can see the total return volume over time. And then by analyzing individual slices, you can get a sense of how many of the orders for that given week came from accessories versus bikes versus clothing. So that's a quick kind of crash course in areas and stacked areas. In this case, because we're going to be looking at individual products here, there's no need for a legend field. There's no need to break down the returns any deeper. So I'm going to get rid of the category name here. And we can use either stacked or standard. As you can see, one series, meaning it doesn't really make any difference. And I'm going to leave it just as it is here. So this is just a start. We're going to continue to evolve this view add more visuals, explore some more features. But for now, this looks good. So there you go, line charts and area charts. So in the last lecture, we built out this line chart and this area chart on our product detail page. But I feel like our line chart is kind of sad. It's showing profit by week, which is helpful, but I think we can pack some more information in here. And one way to do that is to use the tooltips like we've practiced already. So let's go ahead and grab some important measures like revenue and orders into our tooltips. That way all three of those metrics are now visible at the weekly level without having to chart three separate series on the same graph, which would certainly be feasible, but not the best visual since those metrics are on very, very different scales. Instead, what I want to do is explore a pane that we haven't touched yet, which is this third option for analytics. Now, this pane will only be accessible for certain visuals, and for many, these options will be quite limited, but the line chart is one type of visualization that has very rich, very robust analytics options. So we're going to play with a couple of these here, starting with the trend line. Now, all we have to do is add a trend line, and it essentially fits a line to our series over time to give you an overall kind of smoothed out trend of where things are headed. So if I'm AdventureWorks, this is a great trend because I'm seeing profit on a nice upward slope over the last year and a half or so. Now, like everything else, the look and feel is completely customizable. In this case, that black line is pretty overpowering. So I'm going to pull that down to about 75% transparency. That's a little bit more subtle, which I like. You can change the style to solid or dotted or dashed. I think I actually prefer the dashed here. And then these default options will do just fine. These come into play if you're dealing with multiple series. So that's our trend line, easy enough. We have very similar options for a constant line, a min, a max, an average, median, or percentile. All of these essentially add lines, horizontal lines to our chart, and they kind of speak for themselves. Constant allows you to define a value, like 100,000 for instance, and I typed a million. There you go, 100,000, and plot that horizontal line on your chart. That's nice if you have like a fixed goal or something like that. You can also plot the minimum line, which finds the smallest or lowest value in the window of time and applies a horizontal line based on that minimum. Same story holds for max up at the top. Kind of gives you a good sense of the range of values that you're looking at over this period. And then average, median, percentile, they all work exactly the same way. I don't want really any of those. We could add them, but I feel like it's just going to make things a little bit too busy in this case, especially because I want to play with one more tool, which is the forecast down here at the bottom. And this is how we're going to address that question for AdventureWorks about how is my profit expected or anticipated to look for the next X weeks or periods or months. So Power BI makes it very user-friendly to create forecast views like that. And all we're going to do is add a forecast. By default, it's created a forecast of 10 points, and points are basically date fields, and a point is the default unit of date that you're looking at. So in this case, it's 10 weeks out. And if you want to get totally wacky, you could do something like, show me a forecast for 10 years. And it's very ridiculous because you very quickly lose confidence in what your profit's going to look like 10 years out. So I would not recommend that. And I don't think our clients would appreciate that much either. So let's stick with weeks, and let's actually narrow it down a bit to a 6-week forecast. Now you do have an option to ignore previous points. Like if we know this was an outlier or an anomaly, we could ignore that 1 point. I kind of feel like that's sweeping things under the rug, so let's keep that at 0, and we'll keep the true forecast here. Now, confidence interval, this is an interesting one, and this basically defines at what level of confidence do we think the true values are going to fall into this shaded range. So at 95%, that's pretty darn confident, which is why you see a pretty broad or pretty wide range here. If we drop this down to 75 and apply, you'll see that it shrinks down quite a bit. And that's because we're trying to hit a tighter target. So naturally, we're less confident that the numbers will actually fall into this narrower range. So best practice is generally to use 90 or 95. Let's go with 90 for our purposes. There we go. And you can also apply a seasonality factor. Like if you know that mid-June or July profits tend to dip over the summer, then you can kind of manually tweak that forecast window yourself. So there you go. That's our forecast. I think I'm happy with that. Feel free to adjust the settings, kind of customize or personalize it as you see fit. But for our purposes, I think that does a nice job. It adds some good insight about the overall trend of profit and what we might expect to see for future profits over the course of the next 6 weeks. All right, I've got one more specific visual demo for you, and I've saved a fun one for last. We're going to talk about gauge charts. So you can find the gauges right here underneath the pie, and we can drop one onto our canvas. We need to make a little bit of room for it, so let's go ahead and just shrink down our returns view and our trended profit view to make some room for these gauges up at the top of the page. That looks good. Now, essentially what I want to do is use the gauge to provide a quick visual indicator of pacing towards our targets. And remember, we defined order targets and revenue targets as 10% lifts over the previous month. And we did that using time intelligence functions in DAX. So for our first gauge, let's call this our total orders gauge. We'll hop into our sales table, grab total orders, and drop it into the first field, which is the values field. And you'll see a few things happen here. It's populated the total value, 23,000. Again, no other filter context yet, aside from our report level filter of 2016 or 2017. And what it's done is default to a minimum of 0, maximum of about twice the current total, so that it defaults to a half-filled gauge. Now there are a couple tweaks I'd like to make here. Number one, I want this gauge to always show monthly performance for the current month, because our targets, our goals are defined at the monthly level, and I want to provide a recent view of performance, not just the grand total. So to do that, we're going to work with our visual level filters here, and we're going to need a field from our calendar lookup. In this case, monthly. So I'll take the start of the month field and drag it right in here. Now I've got a couple options here. Because the data that we're working with at this point is fixed, we could simply select June 1st, the month of June, and update our gauge to the latest month that way. Problem is, we need to get smarter about this. We need a flexible solution that will scale if we end up adding more data over time. If AdventureWorks, for instance, starts sending us sales or returns data each week or each month and expects new reports, then this basic filter just isn't going to cut it, because we're going to pull in July data and it will still filter to June because we've fixed the filter in that way. So what we need is a better solution like top N. And what we're going to do here is show the top one item, and that item is going to be the start of the month. And because it's a date field, Power BI gives us these earliest or latest options. So we want the top one latest month. And when we apply, we see the same value, which is exactly what we want. June is the correct value because it's the current month, except now our solution is more scalable and more flexible by using that top N filter instead. So that works for our filter. We're good to go there. Next up, we need to provide context, because right now this gauge is meaningless. We could simply have a card showing this number and it would accomplish the exact same thing. So the beauty of gauge charts, kind of like KPI cards, is that they accept interesting values like dynamic minimums or maximums and target values. So let's go ahead and grab our target, order target DAX measure, and you'll see that calculation right here, previous month orders times 1.1. And let's drag that into the target value field here. And now what that does is it creates this indicator with the target, which in this case is 2,382, telling us that we are slightly behind target overall for the current month. Now there's another option that works pretty well here too, which is to take that target, that order target, and move it to the maximum value. That way the gauge fills up until it hits the goal or the target value. So if you have a partially filled gauge, it means you haven't reached your target yet. So I think this is actually a bit more intuitive, but again, this is completely up to you. If you prefer to see that order target in this format, that's fine. I think both look nice. I'm going to keep mine on maximum value, and let's just resize this a little bit. That looks good. And update the title. And let's make this a bit more descriptive to something like current month orders versus target. There we go. And if we want to be consistent with our exec summary, we could do something like this. There we go, and center it. Beautiful. So there's our total monthly orders gauge. We can go ahead and take that, copy it, paste it 2 more times, because we're going to do 1 more for revenue and then a 3rd for returns. So let's work on our second one here, and we're just going to swap in and out the values. So our filter can still stay exactly as is. We can actually collapse our calendar. And in this case, we don't want orders and order target. We want revenue and the revenue target. So we've swapped them out. In this case, current month, we've got 1.83 million in revenue against a target of 1.95. So coming in just under. And we can change the title as well to current month instead of orders, current month revenue versus target. And then our last gauge here, we're going to show returns. Head to our fields, drill into our returns table. And we'll grab total returns instead of total orders. And now remember, we don't have a return target. So in this case, let's just use the previous month return as our maximum value. And because this is a negative metric, I want to call that out and make that explicitly clear using some color consistency. So let's change the data color. There we go. And adjust the title here as well to current month returns, and not versus target. This is versus previous month. And there we go. Next up, I want to cover a very important topic when it comes to Power BI reporting, and that's report interactions. Now, consider a dashboard like this. In the Format tab, you'll see a button on the left called Edit Interactions. When you select a specific visual in your report and click Edit Interactions, you'll see a number of different controls associated with each other visual on that page. And in each case, you'll see a filter icon and a no filter icon. And what these report interactions do is they allow you to determine how filters applied to one visual impact the other visuals. In other words, it determines how you want your visuals to talk to each other. And remember that in most cases, by default, all of the visuals on the page will be configured to react to each other. So as filter context changes with every selection on each visual, the other visuals filter down accordingly. But sometimes you don't want that to be the case. Take this example here. The product matrix shown on the left, the country slicer at the top, and the map itself are all configured to react to filter changes to the timeline, which is the selected object or visual. And you can see that by the activated filter icons in each of those 3 visuals. Now, on the other hand, our 3 cards here, the month-to-date profit, quarter-to-date profit, and year-to-date profit, are all configured to not filter in response to changes in the timeline. And this is a common example for cases where you'd like your card to always show a specific time period or the current month. Or maybe you're showing data from 2 unrelated tables that can't provide valid filters for each other. In any of these cases, the Edit Report Interactions tool is incredibly useful. I want to show you one more example as well. Consider this case. In certain types of visuals, a 3rd option appears, and that option allows you to highlight subsegments of the data rather than simply filtering or not filtering. So in the first case here on the left, when the interaction mode is set to filter, then when we select bikes from the tree map, it produces a filtered list of subcategories in the chart below. So all we see are road bikes, mountain bikes, and touring bikes. In the second example, When the interaction mode is set to highlight, which looks like a pie with a slice pulled out, selecting the bikes category in the tree map doesn't filter down the list of subcategories, it simply highlights the relevant subsegment of data. So both options are perfectly valid, it's just a matter of how you want to display this relationship between your visuals. So let's head back to our report and try configuring some of these interactions ourselves. So back in our AdventureWorks report, let's head back to the Executive Summary tab. And let's say, for example, we want these KPI cards in the top right to always reflect the current month. In other words, we don't want these cards to react to changes in filter context from the date slicer here. That means that what we need to do is edit the report interactions to change the way that these visuals talk to each other. So we'll select the slicer as kind of our parent visual. We can go into the Format tab, and you'll see this Edit Interactions button on the left. And when you click to activate, all of those icons will appear for every visual on the page. All the cards, the maps, the matrix, the tree map, the bar chart. And you can see that by default, they are all configured to filter in response to changes to our date slicer. So all we need to do to tell the cards to ignore filter context from our slicer is disable or switch these filters to none. And once we do that, we can deactivate the interactions. And now check it out. As we move our dates, the other visuals in our report change, but our cards remain constant. Now keep in mind that other filter changes produced by other visuals in the report will continue to change those cards. We've only changed the interaction between the slicer and the cards, not the relationship between other visuals and those cards. So in this case, I'd like to be able to filter down our revenue, our orders, and our returns by different categories produced by filter context from other visuals. So this is okay, but keep in mind that if we were to select the tree map, for instance, and edit the interactions, you get an entirely new set of interaction modes. Now, one to call out here is by default, the subcategory bar chart is set to highlight instead of filter, which is why when we deactivate, as we filter these categories in the tree map, you see that we still continue to see the full set of subcategories. We're just highlighting those which fall into the selected category above. Now, if we were to change that interaction mode to filter, now we're not seeing the full set of subcategories each time. We're seeing a filtered down list based on the selection in another visual. So in this case, I think the highlight mode is actually more effective here because I like to see the full list of subcategories and get a sense of the rank of where the highlighted values from a given category fall. So let's go ahead and deactivate the interactions. And really, it's just interesting to play around and see how things react to each other. So in this case, we have a highlight relationship from the subcategory table up to the tree map as well. You'll note that it's highlighting subsegments of these boxes rather than changing the entire tree map itself. So as you can see, it can get pretty complex. There are a ton of different potential relationships and interactions that you could customize here, especially in our case where we have a large number of visuals on the page. But keep that in your back pocket. It's a great tool to customize how your different visuals react to different filter context. All right, so by this point, we've talked about all of the filters that Power BI Report View has to offer, except for one, the drill through filter. So it's finally time to dig in and see how this tool works. Now you'll find drill through filters between your page level and your report level filters. And what these do is they allow users to jump to different pages like bookmarks do, which we'll talk about next, while simultaneously filtering based on the specific item that they've selected. So it's a little bit confusing. It's one of those things that's quite a bit easier to show than to explain. But if you look at this example here, we've built a report page, product detail. This should look very familiar, featuring product level performance. Everything on this page is designed to show product level detail, and we've added a drill through filter for product name. What that means is that users can now right click on any report visual on any other page in the report that contains product names and select the drill through option to jump straight to this product detail page. And not only that, but the page will filter simultaneously based on which product the user right clicked. So it's almost like a bookmark filter hybrid, and what it does is create some really interesting interplay between the pages of your report and allows you to kind of create specific paths that users can drill into. So let's head back to our report and set one of these things up. Now, once you're back in your report view, head to the product detail tab. And the first thing I want to do is just add a simple text card to indicate what product we'll be looking at here. So I'm going to grab the card option, and from my product lookup, I'm going to take product name, drag it into the fields, and let's give it a quick format just to be consistent. Data label, I believe on the exec summary we used Seago bold. I'll pull it down to about size 20. We do not need the category label in this case. And let's give it a little background with that light yellow shade, just like we did on the exec summary. So you'll note that it's defaulted to first product name, which in this case is actually okay, because this will be changing based on that drill through filter. So normally this wouldn't be very helpful, but think of this just as a placeholder for the time being. So I'll just kind of reposition things a little bit, and there you have it. So this is kind of my label to indicate what this whole page is going to be showing. Now the next step is to grab another instance of product name and drop it right here in the drill through filters window. And I don't even have to make a selection. I don't have to change a thing. What this is going to do just by existing here is it allows me to go to any visual that contains product name level information, like this matrix for instance, and right click, and now I have access to this drill through option, and that product detail page is already populated. I didn't have to set up anything, I didn't have to configure any settings, and now watch what happens. I've right clicked the Sport 100 helmet in red, and when I drill through to the product detail, there we go, Sport 100 helmet in red. I'm seeing the current month orders, revenues, and returns for this product specifically. I'm seeing trended profit through the whole sample plus the forecast. I'm seeing how returns have trended over time. Looks like a spike the week of 5/15 that we should probably investigate. So really user-friendly and really easy to configure. Now the other thing it's done for me, which is pretty cool, is that it's added this back button automatically. And it says control click to go back. And when you do that, it takes you right back to the exec summary where you started. And you can do this literally for any row containing a product name level field. So here's the logo cap. This one hit its target. Looks like it exceeded the order target by 11 orders this month. It beat the revenue target. So what we've done here is essentially create this choose your own adventure kind of narrative that users can experience to interact with the data in any way that they choose. So when we talk about self-service BI, it's kind of a buzzword these days, but this is really what it means. It means you're giving users and analysts and developers and data scientists tools to very easily do this sort of data discovery and reveal these patterns and trends much more efficiently and much more effectively than with traditional tools. So there you have it. Those are drill through filters. Definitely a tool that you want to keep on your radar. So now that we've talked about drill through filters, the concept of bookmarking should come pretty naturally. Now consider a case like this, where we've got a dashboard and we've been filtering and exploring it in different ways. In this case, we noticed that Q4 sales were particularly strong in the Portland market. What we can do is activate our bookmarks pane from the View tab and create a new bookmark to lock in this view, lock in the filter settings, and name it Q4 Portland Sales. What that will allow us to do is link any other object in our file, in our report, back to this specific view. So no matter what the current filter settings are on that page, they would recalibrate to match how those filters were defined when the bookmark was created. So a really useful and relevant case study for using bookmarks is something like this. You could create a new page in your report specifically dedicated to something like key insights and recommendations. And this is where you could capture those findings that you've uncovered as you've been exploring your data. So in this case, our second insight says Portland sales were strong in Q4, led by high top ebony and red wing brands. And then what we've done is insert those buttons, those little eye info icons, and we've linked them to specific report bookmarks using the object action properties. So this creates incredible opportunities, not just to present data, not just to show charts and graphs, but to build a story and actually create a meaningful narrative from that raw data. Because at the end of the day, that's what analytics is all about. It's not about writing code, it's not about crunching numbers, it's not about memorizing formula syntax. It's about deriving meaning and context from the data, and more importantly, using it to make real change. So I absolutely love the bookmarks feature. Let's head back to our Power BI report and try this out in our AdventureWorks dashboard. All right, so there are a number of places where we could potentially use bookmarks here, but as a demo, let's create a button or a bookmark that links from our executive summary straight to our product detail page. And we're not going to do anything fancy in this case. We're not going to pre-filter to any specific view because we already have that drill through functionality in place. But let's head to our product detail tab. We're going to go into view, show the bookmarks pane, and all we need to do is add a bookmark from here. And let's go ahead and double click to name it. Product detail, just to match the name of the tab. And for now, it's as simple as that. We can close that bookmarks pane. We can go back to our executive summary. And let's create a little bit of space right down here beneath our matrix. And we're going to add a button and a little text box that basically says, okay, if you're interested in this product level info, then click this link and I'll drive you straight to even more product detail on that second tab. So what we're going to do here is head to the home tab. We're going to insert a text box first, and got a lot of stuff, so it's kind of tough to manage our shapes at this point. There we go. And let's just type something like view product detail. And I'm going to make it bold, italic, maybe a size 18. Okay, details don't really matter here. And we're just going to drag it kind of right under here beneath that matrix view. And because we can't link a text box to a bookmark, there's no actions pane here that we can use. We'll just need to insert something else, whether it's a shape or an image or a button. So buttons give us some interesting options. We've got arrows, back buttons, info buttons, help buttons, and so on. So let's go with this little info box here and just click and drag it right next to our text that says view product detail there. And now we get this action drop down in the visualizations pane that popped up when we selected the object. And within the actions drill down, we can activate it and say this is a bookmark, and the bookmark that we want to drive to is our product detail bookmark. And that's it. We have set up and enabled our bookmark. All we need to do to test it is control click, and there we go. Takes us right to our bookmark page. And remember that back button that was created when we added that drill through filter automatically? Well, if you select it and look at the pane, you can see that automatically an action has been activated, and in this case it's a back button. So we don't need to create a new one here. We can reuse this one. It'll take us right back to our executive summary. So again, yet another example of a really, really powerful yet intuitive tool in Power BI. And you'll see this time and time again. Once you develop those fundamental skills and understand how this tool is working, which if you've stuck with the course up to this point, I hope you have, then you've got some incredible power at your fingertips here. Speaking of which, next up I'm going to give you a little taste of parameters, which are going to take things to a whole new level. Stay tuned. Alright, I want to take a minute and walk through a slightly more advanced demo. We're going to use what's called a what-if parameter to do some scenario testing. And if you look at your modeling tab, you'll see this new parameter button that launches a dialog box that looks like this. Now, essentially, these parameters are preset DAX measures that produce values within a given range based on user inputs: the data type, the minimum, the maximum, the increment, and the default value. And these can be really good tools to use for things like forecasting or scenario testing. So the example you see here and the example that we're going to practice is creating something like a price adjustment percentage captured within a parameter so that we can compare total revenue based on actual information and actual prices against an adjusted revenue based on the parameter adjusted price. And I'm going to show you exactly how that works. Now, one interesting thing to note is that when you create a parameter using the dialog box, Power BI actually generates and creates a new table for you with DAX calculations already in place for the parameter and the parameter value. So those generate series and selected value functions that you see at the bottom of the screen, those are automatically created behind the scenes, although we could build them from scratch if we chose to do so. So let's head back to our report and try creating a scenario test of our own using these parameters. All right, we're going to head to the product detail tab, and you're going to want to follow along closely with this because there will be a number of steps, and we're going to have to get back into our DAX world and write a few new measures to make this all work. So first things first, on the modeling tab, here's my new parameter option. Let's go ahead and launch the dialog box. Now the settings that I'm going to use, I'm going to give it a name, something like price adjustment with a percentage. And that's just part of the title, it's just text, because the values that we're going to use, as you'll see, will eventually translate into percentages. The data type is a decimal number, and let's set the minimum to -1, maximum to 1, the increment at 0.1, and the default to 0. And we can keep this add slicer to page activated. So to recap, we've essentially created a scale of values defaulting to 0 with a minimum of -1, maximum of 1 in 0.1 or 10% increments. So let's go ahead and press OK to create that parameter. And so a few things have happened here. It's dropped this slicer onto my page, and I'm going to resize my trending profit to create some room here. So I've got this slicer, and as I drag it, you'll see that it contains the values, the minimum of -1, the default center point of 0, and the maximum of 1. And not only that, but at the bottom of my field list, it's created a new table with 2 new fields. One is the price adjustment percentage, which is calculated as a generate series function. You can see that the 3 arguments that the function takes are the minimum, the maximum, and the increment. And the second field, an actual measure, essentially uses the selected value function to capture or harvest whatever value is currently represented by this slicer. And that means that as we move this slicer left and right, we are producing a value using a measure that we can now reference in other measure formulas. Because if we don't do that, then this is kind of just sitting here as an island, and it's not really impacting anything around it. So the first new measure that we need to create is an adjusted price. And if we go into our product lookup table, you'll recall that we've already created a measure for average retail price. What I'm going to do now is create a new measure in this product table. I'm going to name this measure adjusted price, and I'll define adjusted price as the average retail price times 1 plus whatever the currently selected value in my parameter slicer is. So I can search for price adjustment, and you see how it gives me that measure that was automatically created? That price adjustment percent value measure, remember, that's capturing the current value of that slicer. So by multiplying my average retail price by 1 plus that slicer value, I'm essentially defining an adjusted price that modifies my average retail price in steps of 10%, from 0, which is essentially dropping the retail price to nothing, or up to 200%, which is essentially doubling the actual retail price. So that's step 1. I'm going to press enter to create that measure. And now, just to see if this is working, let's add a multi-row card and click off of our slicer, add a multi-row card. And the two fields that I want to pull in are my average retail price and my adjusted price. So right now, because my price adjustment in the slicer is set to 0, these two fields should reflect the same thing. And I'm noticing we need to format here. So I'm going to select adjusted price. And why don't we format this as currency? There we go. So now if we move this slicer, you see the adjusted price changing all the way up to a maximum, which should be double the original or actual average retail price, which it is. Other side of the spectrum, we can drop all the way to the point where the adjusted price is 0. So this is working exactly as we'd expect. Let's set it to 0. Let's kind of resize, create a little bit of room here. There we go. And I'm going to drag my multi-row card right underneath the slider there. So that's step 1 and 2. The next step is to actually take that adjusted price and feed that into some of our other calculations in our sales table, like our revenue measure and our profit measure. Because at the end of the day, those are the actual values that I'm scenario testing here. We're really trying to see what impact this type of pricing adjustment will have to actual bottom line revenue and profit. So let's go to our sales table and let's drill into our total revenue measure and remind ourselves how this original revenue measure was calculated. Used a SumX to multiply the order quantity by the product price in the related product lookup table. So rather than reinvent the wheel and create a new adjusted revenue measure from scratch, let's copy this entire measure, press enter, create a new measure within the sales table. I'm going to press Ctrl V and paste that. And now instead of total revenue, this version of it is going to be named adjusted revenue. Okay, and I'm still multiplying order quantity from the sales table. The only difference now is that instead of multiplying quantity by actual product price, I'm going to multiply order quantity by that measure that we just created for adjusted price. So we've removed the related function. We're not pointing to a related price field in the product table. We're multiplying order quantities by this new adjusted price measure instead. So when we press enter, the measure is created. There it is, adjusted revenue. And now the final step from a DAX standpoint is to create one more. And if you recall, we had defined profit as revenue minus cost. Therefore, adjusted profit is simply going to equal our adjusted revenue minus the total cost. So same exact formula, except instead of plugging in total revenue, we're plugging in adjusted revenue. Now we'll lock that one in as well. And now we've got adjusted profit and adjusted revenue. So let's take this thing to the finish line and visualize what this looks like. To do that, I'm going to copy this line chart that we've created, paste a second instance, which we can pull in right here. Just going to kind of rearrange things a bit. There we go. And now I don't need my analytics tools here. I can get rid of my trend line. I can get rid of my forecast. I'm going to go back to fields, and instead of simply showing total profit, I'm going to show total profit right alongside adjusted profit. Okay, so now both are being visualized here, and at the moment, both values are exactly equal because my price adjustment is set to 0. Now, if I bump up that adjustment to 0.2 or 20%, look what happens. Now we see that adjusted profit is $549. Total profit or actual profit is $345.74. So what that tells us is that with a 20% lift in the product price for the AWC logo cap, we could potentially increase weekly profit by about $200. And then if we adjust in the other direction, and if we reduce product prices, you'll see that these kind of reverse order, right? All the way down to a 50% reduction in price means that you're actually losing money on that hat. So you can see where the break-even points are. You can see how these different scenarios play out. And remember, this is still at the product level. So everything we're looking at here is related to this logo cap. Remember, we can go back. We can drill into a different product, like the water bottle. And we can see a completely different trend and test completely new scenarios with each product individually. So let's go ahead and just kind of tweak formatting, get things to a good point here. We'll default to a price adjustment parameter value of 0. Stretch this out a little bit. So there you go. Good example of how to use these parameter tools to create different types of interactive scenarios inside of your Power BI reports. Next up, I want to take just a minute to talk about managing and viewing as roles. Now within the Modeling tab, you'll see a security tool group with 2 options. When you click the Manage Roles option, it allows you to actually define filtered views so that your report can be tailored to specific audiences. So in this case, we're choosing to filter down the territory lookup table based on the condition or the expression that the continent field must equal Europe. And you can create a number of different roles based on different DAX filter expressions. So in this case here, we've created views for each territory manager, Europe, North America, and Pacific, based on those simple DAX filter statements. Continent equals Europe, continent equals North America, etc. Now what's important to make clear is that you're not just pointing a user to a pre-filtered view. So when you select the Europe role that we've created, for instance, you're not seeing the Executive Summary tab pre-filtered down to Europe. You're seeing a version of the report that literally doesn't contain data for any other continent. And that's why this is different from simply creating a bookmark or a pre-filtered view that you can link to. This is actually running the selected table through a DAX filter expression and chopping out rows that don't meet the condition. So what we're dealing with here is essentially row level security, meaning we're defining specifically what rows of our data set certain users or user groups are able to access. So this is very simple to set up. Let's head to Power BI and I'll show you how this works. All right, so back in our Exec Summary tab, what we're going to do here is head to the Modeling tab, click on Security, Manage Roles. This is where we create or define a new role. And just like the example we talked about, let's create individual roles for each territory so that we can provide AdventureWorks sales managers from different regions with reports that only contain the data that's relevant to them. So let's start with a role named Europe. And basically we define which table we need to filter down. In this case, the only table that we need to filter is the AW territories lookup. And then we write a simple DAX filter expression that returns a true-false value. So in this case, continent equals Europe. It's as simple as that. Now this little icon tells us that this is the table that's filtered. And in the window here, we see the expression that defines the filter. So press save. There we go. And now when we click View as Roles, we have Europe as an option here. So watch what happens and pay very close attention specifically to our map and to our map slicer. When we click Europe, press OK. See what happened? We are now filtered on Europe, but our continent slicer only contains a single value aside from select all, which is Europe. So that really emphasizes the difference between simply creating a filtered view and actually defining row level security that prevents rows of data from actually reaching the report. So from here, we can simply say stop viewing. Back to normal. We can manage roles, create another for Pacific, click the territories lookup, and write the same kind of expression for Pacific instead of Europe. Press save. View as roles. Now we've got a Pacific option as well. And there you go, same thing. So a Pacific sales manager in this example has no idea that data from Europe or North America is tied into this model or even exists. So it's a great tool when you have sensitive information or need to create very specific access rights for certain user groups or teams in your organization. So let's go ahead and stop viewing Pacific. Now, one thing worth calling out here is that by implementing row level security rules, this does have impacts in other places. And one area is when it comes to actually publishing reports. Now again, publishing and collaborating will be covered in depth in an entirely separate focused course, but I will provide a quick preview on what it looks like to load this to service. Now, if I have row level security roles defined, that prevents me from publishing this to the web. So in this case, I don't really need those roles. So I'm going to go back and delete the two that we created, just so that later on I can demo what that publish to web functionality really looks like. So we'll save, and now we're back to usual. We've got no additional roles, and that should do it. So good intro to row level security and using Power BI's manage roles options. All right, to take this section of the course home, we're going to wrap up with some pretty quick rapid fire preview demos. And these are topics that we're not going to dive very deep into, but I want to bring to your attention just so that you're aware of the functionality. So first up, importing custom visuals. You'll see these three little dots, this ellipsis, in the lower right corner. This allows you to import custom visuals either from files or from the Power BI Marketplace directly into your report. So you can search different topics or categories, look at suggested visuals, and then once you pick one that you like, press add, click OK, and boom, it's accessible right there. You don't even need to restart Power BI. You can start working with it immediately. And to clarify, this is a completely free, totally open source marketplace of custom visuals that already has a ton of really interesting options, but it's continuing to grow by the day. So definitely worth taking a look at. And I'll just take 30 seconds now to show you what this looks like in the actual Power BI environment. So like I showed, here's my visualizations pane. Click these three little dots. It says import a custom visual. I'm going to choose from Marketplace. And right here, it opens up the Power BI Visuals Marketplace. You can search different categories. You can look at top editor picks, filter visuals, some really creative ones in here, like network visualization. You can do image timelines, custom KPI charts, different types of maps. I don't know what Sandance is, but it sounds really cool. And then really all you have to do is click add. I'm going with Sandance. Press OK. And check it out. I've got a Sandance now. So again, we could spend hours digging into all of the custom visual options available. Best bet is for you to just scroll through, check out that marketplace on your own, and start exploring some new visuals. So quick crash course in desktop versus phone layout. Desktop layout is the exact interface that we've been working with this whole time. That's the default, the standard. When you switch to phone layout, you'll see a view like this. And what phone layout does is it allows you to design on a canvas size that's optimized for mobile viewing. So important thing to note, you don't actually do any building of content within the phone layout view. You build in the desktop layout and then switch into phone view and kind of assemble your pieces and resize within that new constricted canvas. Now this really won't come into play until you start getting into Power BI service and publishing, but because it is an option in Power BI desktop, I wanted to quickly cover it here. So let's quickly whip up a mobile optimized version of our exec summary. So by default, we're in our desktop mode. If we go to the view menu and click the phone layout, what it does is it gives us this shrunken down canvas and assembles all of our pieces or components over here on the right. And that includes everything, even these little icons that we dropped in, slicers, maps, charts, visuals, logos, all of the pieces are here. So as we start actually dragging items onto the canvas, you'll start to see that we really don't have much flexibility for sizing. So we're not going to be able to get all of these elements into a mobile phone view unless we stack them, one on top of each other. But let's try to get the most important things in here. Maybe it's the current monthly revenue. Maybe it's the current monthly orders here. Try to squeeze in returns as well, kind of our big KPIs. We could probably show our subcategory view down here and stretch it out a bit. And then why don't we pull our tree map? There we go, make this a bit bigger. It's kind of hard to work with. There we go. And maybe it's the top ordered product there as well. So, obviously you don't have to follow along with what I'm doing exactly, but maybe something like that makes sense. And now when you switch back, we haven't edited anything on the desktop view at all. We've just created a new variation of it here in the mobile view. And now if you do end up publishing this report, then it will become accessible on the Power BI mobile app, and this is how users will be able to see and interact with that report. So there you go. That's phone versus desktop layout. All right, the last feature that I want to quickly preview for you is the publish button. Now keep in mind that this button is essentially the gateway to an entirely new world called Power BI Service. It's got a ton of features and functionality, sharing tools, collaboration tools, apps, workspaces, data gateways. The list goes on. The fact is, it's just way too much to try to cover as part of this course, but I do want to take just 30 seconds to show you what the process kind of looks like to get started. So keep in mind, I am signed in. You see my name in the upper right. And when I publish, it's going to allow me to publish to my workspace, which is the default. This is kind of a blank canvas account right now. Press select, and it's off and running, starting to load this up to Power BI Service. So there you go, success. Usually takes around 20 to 30 seconds, not long at all. And then from there you can click the link, and that's going to take me right into app.powerbi.com or Power BI Service, and populate and render the report. So here's my report, still fully functional, fully interactive, all of the tools, everything we created, including the drill throughs. It's all maintained here exactly as it was in desktop, even our parameter testing. Our buttons link really smoothly. And this is where you'll find all of these tools that allow you to start sharing this content, collaborating with coworkers, creating apps and workspaces. This is also where you can publish either to the web or to SharePoint. You can export to PowerPoint, download as a PBIX. Now, one thing I will say is that this report could be published to the web because it contains no private or proprietary data. That said, if you do choose to publish and share this publicly, all I ask is that you please just give a quick shout out to the course. So again, we're going to drill into all of the functionality in this whole Power BI service world in the upcoming course, but that just about wraps up our desktop features. So to wrap up this section, I thought it would be helpful to share some of my top data visualization best practices. Number one, strive for clarity and simplicity above all else. Power BI has a lot of tools, a lot of features, a lot of bells and whistles, but remember that sometimes less is more. Your goal should be to maximize impact and minimize noise. It's all about balancing design and function. Number two, remember that your job isn't just to build charts and graphs. Your job is to create a narrative. So remember, without context, data is meaningless. Make sure that you're using tools like filters and bookmarks and creating effective visualizations that translate raw data into powerful insights and implications. And finally, always ask yourself 3 key questions. Number one, what type of data are you visualizing? Is it integer, categorical, time series, geospatial? Based on that, what exactly are you trying to communicate? Are you trying to show a relationship, a composition across categories, a trend over time? And then finally, who is the end user consuming this information? Because the report that you build for an analyst or a fellow colleague may look very different from a report that you would send to an executive. So there you have it. Those are my top broad data viz best practices: clarity and simplicity, creating narratives, and asking yourself those 3 key questions. All right, time for a quick solution walkthrough for our last homework assignment. And basically what we've done here is create a brand new report page for customer details. And I'm not going to walk through the actual building of every single step. I don't think that would be necessary. But what I'll do is show you my completed version, and we'll walk through each component piece by piece. And keep in mind that your formatting, your style could look different from this, and that's totally okay, as long as you've got the correct visuals in there and the correct filters and functionality. So number one, we add this matrix here to show total orders and revenue by customer full name. And when you try to pull in return data, what you should see is something like this, where you get the identical return values in every single row. And remember, the reason why that's the case is because we do not have a table relationship in our data model between the customer lookup and our return table. What that means is that we can't filter any customer related values to analyze those total returns values. So returns are off limits for this page. We're going to be focusing entirely on our sales data, the profit, the revenue, the orders, those types of fields. So spot check, when you sort the total revenue column, you can click to sort ascending versus descending. You should see Mr. Maurice Shan at the top of the list, who generated $12,407.95 in revenue. And the last step here for question 1 is to update the conditional formatting for those 2 columns, which you can do right here. So for total orders, we've activated data bars. And for total revenue, we've activated the background color scales. And in my case, I've gone from a white to greenish blue shade. Again, your style is completely up to you. Next up, we added some donut charts, and we formatted the titles to match with our product and executive summary pages. The first is breaking down order volume by gender, the second by income level, and the third by occupation. And what we've done here is update the report interactions from the matrix as well as each donut to make sure that these donuts are set to filter and not highlight. So you're going to want to make sure you select each donut individually and make the adjustments. If you only edit one of the donuts, you may still default to highlighting in certain cases. So that looks good. And now if we select Mr. Maurice Shan specifically, we should see these all filter completely down to show gender equals male, income level equals average, and occupation equals professional, because those are specific attributes to this customer. And you can select any blank area of any chart to unfilter. I like clicking in the middle of one of my donuts, just kind of an easy target to hit. And then last note here is just to use those formatting tools to align and distribute. You can hold Control, select all 3, align the top, and distribute them horizontally. There you go. And that's question 2. Question 3 asks us to add a line and clustered column visual, which is this icon here, line and clustered column chart. And we're showing total orders on our column values and total revenue on our line values, and using start of month not the hierarchy version, just the start of month, on the shared x-axis. So when we spot check here and drill down to just the latest month, June 2017, you should see Mr. Marco Lopez drove the most orders that month with 3. Now we're going to update interaction mode again, select the matrix first, interaction, and make sure that that combo chart is set to filter and not highlight. If we select Mr. Marco Lopez, you should see that he placed orders in 4 different months: June 2016, August 2016, March 2017, and June 2017. So that all checks out. That takes us to question number 4. Add a tree map to show total orders by current age. This one's pretty straightforward. We're going to group by that current age field from our customer lookup table. Values are total orders. Now, one thing to keep in mind, right now, I see 928 orders for age 50, 855 for age 49. Remember that the DAX measure that defined current age was based on the today function, which is volatile, meaning that the today function returns different values based on the actual current point in time. So even though our data set is fixed, these customers are actually going to continue to age before our eyes. So don't be concerned if you see slightly different numbers here in this tree map. Next thing we did was add a card for the customer full name. We made some formatting changes to turn off the category labels. We updated the title. We added a light yellow background. And then more importantly, we added this visual level filter for full name where it's a top N with the top 1 item by total revenue. That returns our highest revenue driving customer, which we know is Mr. Maurice Shan here at the top of our list. From there, we copied and pasted to keep the formatting, added 2 new cards, kept the filter in place, but simply dropped in new fields for total orders and total revenue, and updated the headers and titles accordingly. And a couple spot checks here. When we filter on female customers only, you should see Mrs. Janet Munoz with 6 orders and just over $12,000 in revenue. And then among high income customers specifically, our top customer is Mrs. Lisa Kai, who placed 7 orders and drove $11,330. Now, last step here, we added a text box here for executive summary and then dropped in a button with an arrow next to it. Now from there, we went to the exec summary tab, went to the view menu, activated the bookmarks pane, and we added a bookmark named executive summary tied to this view. That was all it took. Then we went back to customer detail, clicked on this arrow button, turned on the action property, selected the bookmark type, and linked it straight to that executive summary bookmark that we just created. And final little spot check to test, control click that arrow, and it should take you right back to your exec summary. So there you go. Last step here is really just to make any last kind of tweaks or formatting adjustments. I added these lines here as visual separators to kind of break up the dashboard into clear and distinct sections. But again, the specific styling and formatting is totally up to you. So congratulations, you just wrapped up the final homework assignment in the course. Go ahead and save this workbook with pride as a completed version, and make sure to give yourself a little pat on the back because that was a ton of work and we've built something that's really, really interesting and powerful. So there you have it. That officially wraps up our reporting section of the course. All right, so as you probably know, over the past year or so, Microsoft has been making some pretty incredible strides integrating artificial intelligence into tools like Power BI. Now, some of these tools like Azure Machine Learning Models or sentiment analysis or text analytics are currently only available to enterprise or premium capacity users, but the good news is that there are some great AI tools that are accessible to free or pro users as well. So what I want to do here is cover some of the AI-driven visuals that were recently introduced to Power BI Desktop. Now, important note, what you're looking at here is the December 2019 release. Make sure you've got a current version of Power BI so that you see these new visuals. If you're not sure, head to the upper left corner, jump into Help, About, and you should see the version number. So I'm on 276, which is the December 2019 release. Now, the first AI visual I want to talk about is the Q&A visual, which looks like a little call-out box or text box here. You'll see a little light bulb in the lower right corner. There are 3 visuals here that I'm showing with that light bulb. That indicates that it's an AI visual. So we're going to use our VentureWorks report here that we built throughout the course. Let's go ahead and clear this filter on our fields. Just want to work with a data model that we're already comfortable and familiar with. So first things first, we're going to add a new tab or page. Let's call it Q&A, nothing fancy. And here we go. We've got our blank canvas. There are 2 ways we can insert a Q&A visual. You can click the button just like any other chart, or if you go to the home menu, you'll see an ask a question option, which does the exact same thing. So let's go ahead and delete that duplicate. We can drag this out because this is the only thing we're going to be showing here. And the first thing you'll probably notice is that we have a question bar here and some suggestions to get started. So Microsoft is looking at our data model and offering some suggestions, things I might want to look at. So total cost by SKU category, total revenue by SKU category, top genders by year to date. You can show some more to kind of get a full list. Now, listen, I'm going to be honest with you guys. I very rarely will use these suggestions. They kind of feel like a shot in the dark. Sometimes you'll get some interesting suggestions, but in this case, we're not that interested in the SKU category. Some of these are just a little weird, like day of week over time. That really doesn't make much sense. But if you click on one, you can see kind of how this visual works, right? It populates the query, turns that query into a visual, and because this is an AI visual, you're not going to get the same chart type every time. Power BI is going to look at your query, it's going to interpret what you're asking and what you're looking for, and it's going to render the most appropriate visual to answer that question. So here we're looking at SKU category with total profit as our values. So let's go ahead and clear that out and ask a question of our own. Now what's important here is that we want to be able to ask a question the same way that we would speak to a friend, right? This visual wouldn't be very powerful or useful if we had to type the same way that we create a DAX measure, for instance, write things like AW underscore sales bracket. That's not natural language. That's not a natural query. So what we can do here is type the same way that we would speak, right? So maybe we want something like revenue by category. Press enter. We got a result. Granted, it's maybe not the one that we want, but Power BI recognized keywords in the query, which it underlined in blue, and it took a stab at rendering what it thinks we're looking for. So SKU category, and I can see with the tooltip that it is showing adjusted revenue. Not quite what we want here. The good news is we can click on that keyword and we can use a different suggestion. So in this case, we want total revenue, and instead of SKU category, we want the product category name. There we go. And now we get something a little bit more reasonable, right? We get bikes, accessories, clothing, and based on the tooltip, we're looking at that total revenue measure. So that looks great. Now, Power BI is pretty smart when it comes to this visual. So let's say that I was typing very quickly and I did something like this. Revenue by category name. Well, it gave me the correct results, same view that we just showed. And now what it's done is underlined that first term, revenue, in red, and it's saying, hey, we think you're probably trying to type revenue here. So we're going to show you the results for revenue by category name. Just like Google does, the autocorrect tool, Power BI is driven by, obviously, AI behind the scenes. And as part of that AI, it understands synonyms and corrections just like the one we're looking at here. So again, I can click in and I can say, yep, you know what? I want total revenue by category name, and boom, we're off and running. Now, this is really just scratching the surface of what this visual is capable of. This is a simple query, one measure, one column or dimension name. We can get a little bit more sophisticated than this, and we could do something like total revenue for red bikes. Okay, and because this query is designed to aggregate values to a single result, Power BI has displayed the answer or the result in the form of a card with one value, 4.87 million. If you're not sure, if you don't trust that that's right, We can go ahead and test that. We can add a card ourselves. Let's expand our filters. And in this card, we want to show that total revenue measure. And we want to filter it down for the bike category. There we go. And for the color, the product color, red. 4.87 million, boom, there we go. The Q&A visual did its job. It returned the proper result, which is actually pretty impressive when you consider the complexity of this query. We're looking for a measure, aggregated values, based on an attribute, red, which is a value in a dimension from one table, the product table, and also category equals bikes, which is a dimension from a second table, the product category table. So the fact that Power BI was able to interpret that instantly and render the proper result is actually pretty incredible. Now we can take this a step further. Beauty of AI and machine learning is that you can train these models and train these tools to get smarter over time. So let me show you what that looks like. I'm going to click this gear icon here. This is going to open up this menu. Granted, this is a brand new visual. Things are changing and evolving, so you might not see this exact view. But basically, I've got three options here. I can review questions that have been asked in this visual. I can teach the Q&A visual to get smarter and understand new synonyms, and I can manage any custom terms or synonyms that I've defined. If you click this link here, you'll go to the official Microsoft documentation if you want to dig a little bit deeper. But let me show you how this works. Now, if I click Review Questions, I'm going to see a list of questions that have been asked in this visual. Now, you won't see any questions here if you've only interacted with the visual in Power BI Desktop. In order for this to work, you have to publish this to a workspace in the Power BI service environment, which we do cover in a separate course, Publishing the Power BI Service. So as a test, what I've done is upload or publish this report to a workspace in the service environment. I asked a bunch of questions inside of this visual, and they populated right here. So the important thing to note on this tab, or this view, is that any query that has a red underline or a keyword that Power BI didn't understand has this pencil icon where it says Fix Needed. And when I click that icon, it takes me to the Teach Q&A tab. It populates that query, and when I hit Submit, what it's going to do is show me a preview of what the Q&A visual would return here on the right side. So in this case, a card with the value 24.91 million. And it also lets me define the term in red, the term that Power BI wasn't able to interpret. So in this case, I'm looking for product type, which isn't actually a column name or a field in my model, but I know that this user, because it was me, is actually looking for the category, right? Bikes, clothing, accessories. So what I can do is tell Power BI, hey, whenever you see someone type product type, what they really mean is category name. Okay, so I've just defined a new synonym, and watch this preview update. Boom, there you go. So now instead of the card, it's showing that bar chart with the breakdown by category name. So when I save that synonym, I've now made this visual smarter, and I can manage any terms that I've created right here in that last tab. So pretty cool stuff. If I close out of that dialog box now, and I head into our model tab, you'll see this kind of populate one other place, which is in the Properties tab. So if we look at the category name inside of our category lookup table, there's this box called Synonyms. Check it out. Category name, no space, category, and product type, which is the one that we just defined in the Q&A visual. So pretty cool stuff, pretty user-friendly. One last query that I want to show you. Let's say we do something like orders by order quantity. In this case, Power BI interpreted this as a line chart, but really we're not showing anything in a time series. We don't really want a line chart here. I think a bar or column chart would be a little bit more appropriate. So what we can do is convert this to a visual using this button here. Just turns it right into a line chart, and all we need to do is click, and we can modify it, change the chart type, we can format this, we can filter it any way that we like, just like any other visual. So there you have it, pretty powerful stuff. That's the AI-driven Q&A visual. Hey everyone, so for this demo, I want to dive into another one of Power BI's AI-driven visuals called the Key Influencer visual. Now, instead of applying this to our current AdventureWorks project, what I want to do is show you how we can use this visual to explore a new demo data set that's a little bit more appropriate for this kind of analysis. So what I've done here is create a new Power BI file. It's called Power BI AI Visuals, and you'll find a completed version of it as well. Both are available for download. You can follow along or just watch, totally up to you. But the data set that we're working with here, there's one query in this file, and it's called Kickstarter Projects. Now, for anyone not familiar with Kickstarter, it's basically a platform where entrepreneurs can post projects or business ideas and try to get them funded from other users. So let's take a quick look at what we're dealing with here. I'm going to pop into the Data tab, and we have one record or one row for each project. We've got a unique project ID, project name. It's categorized into subcategories and categories. The goal amount is basically the target level of funding in order for the project to be successful. We know when that project launched, and ultimately we know what the outcome was. Was it successful? Did it fail? Is it currently live or in progress? That's what we have in this column here. And then we also know the number of backers, the number of people who pledged or supported the project. We know what country it came from. We know the total amount pledged in US dollars. And then we've got a year field here as well. So I've filtered this down to just 2017 projects. We've got about 40,000 records here in this table. But if you're interested, jump into Power Query. You'll see the full unfiltered data set, which is about 350,000 records. So you can play with the full one. You can cut it up different ways. Totally your call. So let's head back to our report view, and we're going to go ahead and insert the key influencers visual. Looks like this little, kind of like a lollipop chart looking thing with the AI light bulb in the corner. So let's drop it in. If you don't see that visual, make sure you've updated your Power BI desktop version. I'm on December 2019, so make sure you're current. And let's just stretch this out to take up almost our entire canvas. Now, here's the thing. Before we just start dragging and dropping all willy-nilly here, let's take a minute and understand what the purpose or goal of this visual really is, because this is not your average visual. Most chart types and templates like bar charts and pies and areas and histograms, whatever, they're designed to visualize concrete data. They just change the format, they bring it to life in a visual form. What the Key Influencers visual does is much more sophisticated. It actually helps us understand and expose the individual factors that drive some sort of an outcome. And that outcome could be categorical, like a project being successful or unsuccessful, like we have in this case, or maybe it's a customer review being positive or negative, or that outcome could be numerical or continuous, like determining what factors impact the price of a house or make the price of a house increase or decrease. That's what this visual is all about. And for anyone who wants to kind of dig deeper under the hood into the actual statistics and data science behind this, it's outside the scope of this course, but basically what we're working with here are regression models, either logistic regression for categorical variables or linear regression for numerical variables. Basically, the idea is to understand the dependence and the interrelationships and correlation between variables here in our table, and specifically how changes to some independent variables impact the predicted value of our outcome or our dependent variable. So, all right, that was a lot of words. I apologize, getting a little heavy there. Now let's start playing with this and see what this is all about. So we've selected our visual here. We've got three different fields or wells that we can play with in the Visualizations tab: Analyze, Explain By, and Expand By. So Analyze is the outcome that we care about. So let's go ahead and start with that project outcome field, which is categorical. And as you can see, it says, all right, what influences project outcome to be failed, live, or successful? I want to see what impacts successful projects. So I'm going to select successful there. And now my next step is to drag fields into this Explain By well based on basically any field that I think might influence this outcome. Okay, so if I think that country might be a factor here, I could just drag country, drop it in, and the visual updates. So we see a lot of information here. On the left side, we'll have a list of any key influencers, any factors that Power BI has deemed to be statistically significant and influential in impacting that outcome. In this case, we just have one. And then on the right side, we have visual representation of our entire data set for a given field. So we've got 5 countries in our data set: UK, US, Canada, France, and Australia. And Power BI has told us that there's one significant influencer here, which is that when the country is the United Kingdom, the likelihood of this project outcome being successful increases by 1.11 times, all else equal. Okay, and the way that that value or that factor is derived is by comparing the success rate or the project success outcome in the UK compared to the average country. So all other countries averaged out. So in the UK, for the 5,856 projects, 42% of those were successful. When we compare that against all other countries averaged out, we see that only 36.24% are successful otherwise. So quite an increase there, and that's why when country equals UK, that's identified as a key influencer. Now, note that we only have one influencer here in the list on the left, but we're seeing 5 countries here on the right. And that's because whether or not a value or a factor is noted as an influencer has to do with a number of things. For one, it has to do with the difference of success rate compared to the average. So for instance, US and Canada are very, very similar to the average. And it also has to do with volume. So you can see the count of Kickstarter projects. From France, only 979. From Australia, 1,500, compared to the US, which is almost 33,000. UK, which is almost 6,000. So those factors all go into this regression model behind the scenes in order to determine this list of key influencers. So at this point, we're only looking at one factor, country, but we obviously know that there are other things that determine if a project ends up being successful or not. So all we need to do is think about, okay, what other factors might possibly be influential here? And maybe category is a factor as well. So we can drag category in right next to our country, and now all of a sudden we see a totally new list of influencers here. In fact, that country equals US or UK influencer is now pushed way down to number 7 in the list. And we have these category influencers which are outweighing it significantly. So now we're actually seeing that when you factor in or consider country and category, the number 1 influencer is when the category equals comics, followed by dance projects, theater projects, music projects, and so on and so forth. And you can continue with this process. Right now we're looking at 2 categorical fields, but we could pull continuous or numerical fields in here as well, like the number of backers or the total amount pledged in US dollars. And now what you're seeing, kind of as you'd expect, are that these new fields we just pulled in are the new biggest or most influential factors. And it makes sense. The number 1 factor is that if you have a project that raised more than $4,968, you're almost 4 times more likely to have a successful project, all else equal. And that makes sense. Same story here with backers more than 100. Here's the thing. You raise more money, you get more backers, you're more likely for your project to hit its target. So that all is intuitive. That makes sense. And when we click on one of those factors that's based on a continuous field, what Power BI does here is it kind of bins those values, just like you would with a histogram, into different chunks. So more than 4968, between 2635 and 4968. You can kind of see how each of those bins of values compares to the average. If we had a clear linear relationship here, Power BI might plot this as a scatter plot with a line of best fit. But the one thing that's kind of missing to this point is that we're sorting by default based on the impact, these influence factors here. But what we don't know at first glance is, okay, this is an influential factor, but how much of the data set does it actually represent? Is it a large portion? Is it a very small piece? And what you can do is hover over these bubbles here, and it will tell you. So this influencer contains 25.38% of the data. This one contains 19%. This one down here contains under 1%. And what you can do to make this a little bit more clear is actually go into the format pane here, drill into the analysis options, and you can enable counts. And what that does, it's kind of subtle, but it adds that little ring around each of these bubbles, which represents the percentage. Right now it's based on an absolute percentage, so 25% actually looks like a quarter of the circle. You could change that to relative, which makes the largest factor 100% and then indexes all the other ones accordingly. Sometimes that can make it a little bit easier to see and interpret. And the last thing that actually does is it gives us an option here to sort either by impact, which we're doing by default, or we can sort by the count. And now we see that actually this factor here, which isn't a very big influencer, is a big piece of our data. It represents almost 26% of our data set. Now, last thing to cover really quickly here before we move on to the next demo, which is going to cover continuous variables, is this top segments tab. And what the top segments tab does is it actually runs a cluster analysis behind the scenes. And what Power BI is doing here is it's combining factors into segments or populations that seem to have a very high level of influence. So you can click on any of these to see more information about them. So segment 1 is defined as a segment where the number of backers is greater than 100 and the category is not games. Okay, so within that segment, almost 90% of those projects were successful. And that's compared to an average of only 37%. So a very, very influential, very successful segment that we've defined here. You can also see that it contains about 6,400 records, which is about 14.6% of our data. You can learn more and explore down here, but that's basically the idea. You can click through, see which types of segments Power BI is defining, and this can help you understand things like, who your target audience really is. Maybe you realize that middle-aged women in the Northwest are, your best customers, and you're really not resonating with men in the South. Those are the types of insights that this sort of segment analysis can really enable. So there you go. That's the key influencer visual, looking at a categorical outcome like we are here. In the next demo, we'll keep this example going, and instead of looking at a categorical outcome, we'll pull in a continuous variable there and check out some of the differences. Stay tuned. All right, so it's time for part 2 of our conversation about the Power BI Key Influencers visual. Remember that in part 1, we analyzed the impact to a categorical outcome. So what influences a Kickstarter project to be successful? Now we're going to run a very similar analysis, except we're going to use a continuous or numerical value for our outcome instead. So in our Power BI AI visuals file, I'm going to add a new page here. I'm going to call it Key Influencers Continuous. Now I'll just drop in a new instance of that Key Influencers visual, and we've got a nice blank slate to work with. So just like before, we're going to start by dragging a field into Analyze, but instead of using a categorical field like Project Outcome, this time I'm going to use a numerical or continuous field like Amount Pledged. So things look pretty similar here. The only difference is that now we're saying what influences Amount Pledged to either increase or decrease. Those are the standard options that we get with a continuous variable. Now, if you go into the Format tab and click into Analysis, you'll see that Power BI detected this as a continuous analysis type. You can override that if you want. I could say, no, this is categorical. And what we'll do is try to bucket every unique value in that field into its own category, which is utter nonsense. So in this case, it got it right. This is continuous. And we're left with that increase, decrease option. So the question that we're posing here is, what influences the amount pledged to increase, to go up? So let's start thinking about potentially influential factors here. We know that the number of backers is highly correlated, so we can pull that into the explain by well here. And check it out. We get this nice scatter plot with dots representing each project in the table. And we see this nice clear linear relationship between the number of backers on the x-axis and the amount pledged on the y, which makes sense. You have more backers raise more money, and we get that nice upward sloping line. This is a linear regression model, and the slope of this line is what allows us to determine these factors and these influencers. So what we're saying is that when the number of backers goes up by 946, the average amount pledged increases by about $109,000. Now, here's where things get a little bit interesting, which is that by default, when you pull a continuous variable into the analyze field, you're going to see don't summarize. And what that means is that Power BI is going to run this analysis at the table level of granularity. And what I mean by that is that the level of granularity in our source table is at the project level. Each row, each record represents one project. That's why we see each dot in the scatter plot represent one single project. But what if this is just too granular for me to even make sense of or generate insights that I can use to optimize my business? What if I actually want to see the relationship between backers and amount pledged at a higher level, like by category or country or subcategory? Well, I can use the expand by option to do that. What we can do is aggregate these values for both amount pledged and the number of backers. I could choose average here instead, or I could take a measure. In this case, we've defined average amount pledged as the average amount pledged. Makes sense. We could use a measure here instead, same exact thing, and we can choose an aggregation for our explain by fields as well. So let's choose average for both, and now what we're going to do is determine the level of granularity that we want by pulling a field into this expand by well. So if we want to see the relationship between the average backers and average amount pledged by category, we just grab category, pull it in here, and look at this. We get that same scatter plot, but now each dot no longer represents a project, each dot represents a category. So the way to interpret this tooltip here is that on average, projects in the games category have 343 backers and have raised about $25,500. Same goes here with design projects, with technology projects, and so on. So now on average, for an average project, when you get 89 more backers, you can expect to raise $1.85 thousand more dollars. And that's just a way to run a very similar analysis, but explore things at a different level of granularity. And when we pull a field into expand by, what we're doing is determining that granularity without treating it as an influencer, which is what we'd be doing if we pulled that in here instead. So there you have it. That's how you can use Power BI's key influencer visual to explore or predict a continuous outcome. All right, so as we talk more about AI and machine learning and statistical modeling, it's important to remember that these tools can be incredibly powerful when they're used appropriately, but incredibly dangerous when they aren't. Now, the thing about tools like this key influencer visual here is that they're great because they help make machine learning accessible to everyday users, but a little scary because those same users often lack the foundational knowledge to understand what's happening behind the curtain and how to properly interpret the results or make intelligent decisions based on them. So speaking of interpreting results, I think this is a good time to take a step back, take a pause, and review one of the most important rules in statistics and analytics. Correlation does not imply causation. Now, I'm sure many of you have heard this before, especially if you work in data or analytics, but let's take 2 minutes and break this down. Correlation is when two variables, x and y, move together, kind of like this. They move in the same direction. Causation, on the other hand, is when variable x causes variable y. In other words, there's a clear cause and effect relationship here. Now, what if I were to show you a scatter plot like this? We're plotting violent crime rate on the y-axis and some mystery variable on the x. And based on this 25, 30 observations here, we've got a very tight correlation, pretty clear linear relationship between the two variables. So clearly they move in the same direction, clearly they're correlated, but you might be tempted to think, that this x-axis variable is the driver behind violent crimes. It's causing violent crimes, and that if only we could cut back on whatever this variable is, we might be able to make our streets safer. The problem with that is that we're looking at ice cream cones sold, and you may be scratching your head, you may be a little confused, and that's totally understandable, because the human brain is biased to look for cause and effect relationships where in fact they don't exist. So if you're still wondering kind of what's going on here and how this could possibly be true, here's a hint. Our y-axis, violent crime rate, could just as easily be drowning deaths, or forest fires, or even your dreaded crab attack. So think about what those things have in common, and you'll probably start to realize that this has nothing to do with ice cream at all, and everything to do with temperature. As temperatures rise, you have more people out later, gathering in public spaces. As a result, crime rates increase. You also have more people going to the beach and swimming in the ocean, so drowning deaths increase, and so on and so forth. So because ice cream sales are such a close proxy to temperature, we've created a false narrative that paints a completely misleading story. So key takeaways here: ice cream does not turn you into a violent criminal, it does not make you drown, it does not start forest fires, and it certainly does not encourage crabs to attack you. Now, obviously, these are silly examples here, but the core principle, the concept, holds true, and it's a really important one to keep in mind. I'll leave you with one kind of more real-world business case here. Should be a scenario like this. Maybe you run a startup, you've been live for about 4 months, and you're plotting your weekly marketing spend, which you've been ramping up, against your total revenue. Now, if you were to imply causation based on this chart, these results here, you might think that ramping up your marketing spend is a surefire way to drive more revenue. And that may be the case, it may be true, but it also may not. So the idea is you've got to think about the other factors that might be at play here. Maybe over this 3 or 4 month period, you've also been ramping up a new sales team, or maybe your organic traffic has been growing due to referrals or PR or something like that. So bottom line here, be thoughtful about how you interpret these results, and please use caution before you make big decisions based on these findings. All right, it's time to talk about my all-time favorite AI visual in Power BI, the decomposition tree. Now, this one's still a preview feature, so you're going to want to make sure you have the latest version of Power BI Desktop installed, and once you open it up, you're going to need to head to your Options and Settings, open up the Options window, and then what you can do is drill into your preview features, just give that checkbox a check where it says Decomposition Tree Visual, and press OK. So you'll probably be prompted to restart Power BI. Go ahead and do that, and you'll see this nice little icon here. Kind of looks like a flow chart or a process diagram with that AI light bulb. That's our decomposition tree. So if you'd like to follow along with me, go ahead and open up the AI visuals file, and we're going to create a new page here called Decomposition Tree. So let's go ahead and give it a click, drop it onto our canvas, resize things a bit. Looks good. Now, you know me, before we start tinkering, I always think it's important to talk about the why. So why are we using this visual? What's the objective? And what I love about the decomposition tree is that it's great for ad hoc data exploration. It's a great way to understand how your data is distributed, and it's an excellent tool for root cause analysis. And what I love about it is that it's smart, it's intelligent, it's AI driven, but it's also really intuitive and really user friendly. So let's go ahead and give it a click, and you'll see kind of 2 fields that should look familiar from our key influencers visual. We've got an analyze well and an explain by well. So what's important to note is that anything we pull in the analyze field here needs to be a quantitative metric. So we can pull a categorical field in here like project outcome, but it's going to get aggregated either as a count or a distinct count. So really what this visual is designed for is for continuous or quantitative fields. Things like the amount pledged in US dollars, for instance. You can see that by default, this was aggregated to a sum, which in this case makes sense. So not really impressive quite yet, right? We've got a little bar here showing the total amount pledged, 544 million. Now, where it gets interesting is when we start populating the explain by fields. And think of these explain by fields as the ways that we'd like to break down these dollar amounts, this amount pledged. So I kind of like to think about this like a hierarchy, right? Where I want to break things down at a high level maybe like category first, and then a little bit deeper like subcategory, and then we'll go all the way down to the project name. And you can actually drop these in any order. It's just kind of the way that I think about it in my head. And you'll notice nothing really changed here except this tiny little plus icon appeared, which was so subtle that you might have missed. But what that does is allows us to build our decomposition tree. And we've got two options here with light bulbs. These are the AI-driven options where we can find out what makes our metric the highest or the lowest, or we can manually select one of the fields that we dragged in ourselves. So I'm going to start there because it's really clear, really intuitive, and also a really powerful option. So I'm going to take my amount pledged, I'm going to break it down by category. Boom, there you go. Instantly, I can see that games, design, and technology products make up the bulk of my amount raised or amount pledged. There's a big drop off before film and video, publishing, and then I can actually scroll down a bit to see dance here at the bottom. So from here, I can keep building my tree. I can select any one of these nodes and break it down at another level. So subcategory, for instance. Here we go within games, tabletop games, clearly the biggest driver here. And let's drill one level deeper to project name. And there you have it. We've built a decomposition tree in about 30 seconds, and it looks great. And check this out, it's totally interactive. You can select any of these nodes, totally dynamic. You can see exactly how your data is distributed, where you'll find the bulk of the volume. It's just a great, very user-friendly tool. And honestly, if they left it at that, it would still be a pretty valuable addition to the visualizations pane. But where it gets really cool is with the AI features. So let's close those out, and let's go back to our plus sign. Now what if we choose the AI-driven high value? Okay, we see the same result that we did manually, pulled in the category field, and it's showing games at the top. Same order here, kind of descending in volume. Now, what we didn't really realize happened is that Power BI looked at all of the available fields in order to find the one field with the biggest chunk of volume. That happened to be category with games here, which drove $144 million. But if, for instance, we had country as well, now all of a sudden US is the top driver. And it's really just based on the ratio of that 454 million out of the total, and that's what determines the rankings here, as well as which field was selected to be displayed. And that's nice, but it's not really artificial intelligence. It's not that smart or that impressive. But where it gets more interesting is if we go into our formatting pane, drill into analysis, you can see that by default, the analysis type is absolute. In other words, it's based on volume. That's why we see always the kind of descending by volume. We see the biggest categories pop up first. If we change this to relative, watch what happens. Everything changed. Now that AI-driven high value is showing project name, which is the lowest, most granular field that we have. And it's showing this top project, the 7th continent, as the biggest relative factor that contributes to the amount pledged. So the simplest way to explain kind of the rationale here is that basically Power BI is saying, okay, given all of the project names, what would I expect a project to drive in terms of pledge amount? In other words, it's the average across all projects in the entire table. And the reason why this project here, the 7th continent, is appearing at the top and why project name is appearing at all is because the difference between what this project drove and the average among all projects, that difference was bigger than any other difference in the data set. It's bigger than what the US drove as opposed to the average among all countries, and it's bigger than what games drove compared to the average among all categories. And that's why AI has determined that project name should appear here, and why the 7th continent is technically the biggest relative driver towards the amount pledged. So really interesting findings here that would be very tough to kind of realize without doing some pretty heavy analysis on your own. So let's go ahead and clear that out. I'm going to kind of recreate that initial tree that we built because I think it's a pretty helpful one. Category, subcategory, and project name. Note that if you hover over the headers here, you can lock specific categories. So if you always want to start at the category level, but you'd like users to be able to rearrange these or pull them out. You can go ahead and lock one category or one column here of your tree, but leave the others flexible. Now, last thing I'll call out here that makes these visuals so great is that you can treat them just like any other visuals. You can format them. In fact, Microsoft just released a lot of new formatting options for this decomposition tree visual specifically. So you can change the look of your data bars if you want. You can change the connector lines, all sorts of formatting options here. And perhaps the best thing of all is that you can filter and cross-filter these visuals based on things like slicers or other visuals in your report. So check this out. It's as simple as dropping in a map, for instance, or let's use a filled map here. Pull country in, and now check it out. Our decomposition tree is now dynamic. It's tied to our map. We can look at the UK, we can look at France, we can look at Canada, or the US, and everything updates dynamically. Again, really powerful tool when it comes to ad hoc data exploration, data distribution, and root cause analysis. So there you have it, the new AI-driven decomposition tree visual.